Very good morning to all the participants to the third day of the 5-day workshop on our programming. So today we have a session with our expert speaker, Dr. Arpita Basak. Ma'am is from Guwahati University. She is in the Department of Statistics there. Ma'am is an assistant professor, and ma'am is a young mind with experience and skill which is especially related to queuing theory. Ma'am is also a doctoral guide there. So I would like to read ma'am's profile in brief. Although it is the profile does not speak of all the qualities possessed by her, all the skills possessed by her. This is just in short that we summarize about the expert speaker. So I would just like the right to read ma'am's profile with her due permission. Ma'am, may I?
Yes, ma'am.
Yeah. So Dr. Arpita Basak pursued her doctoral degree from Guwahati University, focusing on the topic some statistical aspects of queuing theory. Her research area includes queuing theory, statistical inference, and public health. She has also done collaborative research work with Population Research Center under the Ministry of Health and Family Welfare, Government of India. She has published several research papers in reputed journals of international and national stature with high impact factors. She is recognized as she is also engaged in guiding scholars, and these scholars are engaged in several topics. To name a few, queuing theory and other areas of our expertise. So we welcome ma'am to our session of this 5-day workshop on R. So ma'am, I hand over the session to you.
Thank you, ma'am. Thank you for the introduction. Good evening, all of you. So first of all, I share my screen. Ma'am, please allow me to share the presentation.
Yes, allow.
Yes.
Your screen is visible, ma'am.
Ma'am, screen is visible, ma'am?
Yes, yes, it's visible, ma'am.
So good morning, all of you. So today we are going to explore. Am I audible, ma'am?
Yes, ma'am, you're audible.
Yes, thank you. So today we are going to explore one of the most important tools in the data analysis, that is hypothesis testing, and see how it can be performed using R. Okay, and I will also show you how R help us to validate the assumptions, our assumptions regarding the population scientifically. So before we begin, let me tell you what we will cover today. These are the objectives of this session. The first one is the understanding the logic behind hypothesis. So, so first one is the understanding the logic behind the hypothesis testing. So under this point, we are going to know why testing of hypothesis is required, what is its importance and its key indicators. Next, we are going to explore the different types of test and the assumptions they require. Next, we look at the next I will show you how to perform this test in R, and finally we will learn how to interpret the output, or we can say that how to interpret the results. So as we all are actively involved in research, so we know that every research begin with curiosity, a question. For example, suppose, do students from two colleges perform equally well or not? Or does a new teaching method improve learning? So these are the questions. So once we have a questions, we form an assumption on the basis of the questions, and call it as a hypothesis. So hypothesis is nothing but the assumptions about the populations. And so we can say that the hypothesis is simply an idea we believe might be true. Okay. So, what is hypothesis testing? A statistical method to decide whether an assumptions about the population is likely to be true or not on the based of the observed data, that is the sample data. So, or in other words, we can say that the hypothesis testing is a statistical method that help us to decide whether an assumptions about the population is true based on the observations or the data we observed. So in every hypothesis test, we start with two statements. The first one is the null hypothesis, where we in which is denoted by H naught, and this null hypothesis where we assume that there is no difference, no effect, or we can say that it is our default belief. So null hypothesis where we assume that there is no effect or no difference. So next is the alternative hypothesis. As the name suggests, the alternative, it is just uh, null hypothesis where we assume that there is no effect or no difference. On the contrary, in the alternative hypothesis, we assume that there is an effect or difference, and which we are trying to find evidence for. Okay. For example, if we are checking if the average height uh, is 170 centimeter, then H naught says that yes, the average height is 170 centimeter, but this H naught states that it is not equal to 170 centimeter. Now, here we have two diagrams. So, in the first diagram, we observe that the curve is in bell shaped. That means the data follows normal distribution. And in the second diagram, we observe that the curve is in skewed form. That means that the data is not normally distributed. Normally distributed. So when our data follows a normal distributions, we basically use parametric test like t-test or ANOVA. But when the data is skewed or not normal, we switch to the non-parametric test, such as the Wilcoxon test or the Mann-Whitney U test or the Kruskal-Wallis test. So this is the basic difference between parametric and non-parametric test. So the first assumption is that in testing of hypothesis, whether our data is normally distributed or not. So next is hypothesis testing process. So say someone claims that the population mean age is say 50. So here the population mean is denoted by mu, where we someone claimed that the population mean age is 50. So obviously our null hypothesis, which is denoted by H naught. So since the mean of the population is generally denoted by mu, so here this H naught is mu is equal to 50. That means there is no difference, no effect. So obviously, and this H1, which is the alternative hypothesis, where we assume that mu is not equal to 50. That means our alternative hypothesis is two-sided. Just focus on this word, our alternative. When we say that mu is not equal to 50, that means our test is two-sided. And when we state that suppose mu is greater than 50 or mu is less than 50, then we can say that then our test is one-sided. Now we take a sample from this populations where we assume that the mean age is 50. So and calculate the mean, sample mean, and suppose the sample mean age was 20. Now if such a difference is unlikely to happen when the true mean is 50. That means that this is significantly lower than the claimed mean population age of 50. We assume that the population mean age is 50, but when we collect a sample and we calculate the sample mean, we get age was 20. So just check, see the line. If the null hypothesis were true, the probability of getting such different sample mean would be very small. That means that if I assume if our null hypothesis is true, then the chance of getting such different sample whose mean was 20 is very small. That means, so we reject the null hypothesis. Reject it. So in the other words, mm, so in the other words, we can say that the getting a sample mean of 20 is so likely if the population mean was 50. So the next thing is when to reject H naught. The first thing, the first is the first we assume a statement about the population, that was the population mean age was 50. Next we draw a sample from this populations and calculate the mean, and we get the sample mean age was 20. Since this is significantly lower than the claimed mean, if the null hypothesis were true, then the probability of getting such a different sample mean would be very small. And so we obviously, since the difference is large, the mean age is 20 and the population age is 50, then obviously we reject the null hypothesis. So now the next question is when to reject H naught. Yes. If the sample mean is close to the assumed population, then obviously the null hypothesis is not rejected. Now, if the sample mean is far from the assumed population, then the null hypothesis is rejected. Now, the question is that how far is far enough to reject H naught? Or we So we decide this by using the level of significance. Here, the concept of, we introduce the concept of level of significance, which is denoted by alpha. So the difference is how far is far enough, which will be decided by using the level of significance, which is denoted by alpha. So what is the level of significance? It is the maximum risk of rejecting H naught when it is true. So it is a maximum possibility that our null hypothesis is true. Still we reject our null hypothesis, because when we collect sample and we when we collect sample and calculate the sample statistic, we observe that the difference is the sample mean, and there is a worst difference between sample mean and population mean. And So this level of significance is the maximum risk that, and commonly we consider at is at either 5% or 1%. The 5% is more popular than 1%. So what is the meaning of 5% means? Meaning 5 chances out of 100 to be wrong. That means what is the wrong? Wrong is the rejecting H naught when it is true. Suppose we draw samples 100 times, and out of this 100 times we have 5% chances that we draw wrong decisions. What is the wrong decisions? Is the rejecting H naught when it is true. So when we consider that alpha is equal to 1%, here we commonly set as the 5%. Suppose we, when if I consider this level of significance is at 1%, then we have only 1% chances out of 100 to be wrong. So wrong is the rejecting H naught when it is true. Next is what is the critical region and decisions root. So based on this level of significance, we draw boundaries. Okay, just check. So this is the boundaries. This portion is the boundaries, and this boundary is called the critical values. And this critical values are uh, fixed on the basis of the level of significance. So if the test statistics, so what is the test statistic? Is a numerical value calculated from the sample data, or we can say that it measures how far the observed data is from what is expected in the null hypothesis. So the first thing is first we in testing of hypothesis process, uh, first we claim the first we state the null hypothesis, next we state the alternative hypothesis, and then we fix the level of significance, which is very important. Then we collect data and calculate the test statistics, and then on the basis of this alpha we draw our boundaries. This called the critical values. Now if the calculated value, if the test statistic value falls in this region, okay, that means if the test statistic value is less than the critical values, then in that case we reject H naught. Clear? Hello, am I audible?
Yes, ma'am.
Yes. Acha. Did you get my point? What is the process or the procedure in testing of hypothesis? First, we define the null hypothesis and alternative hypothesis. Then we collect sample from the population and calculate the test statistics. Okay. Next, we define the level of significance, whether 5% or 1%. Then on the basis of the level of significance, we find the value of we find the value of this critical values. Now if this test statistic values is less value is less than the critical value, then we reject the null hypothesis. This is the concept behind the testing of hypothesis. Now, in like every decisions in testing of hypothesis, there are two types of errors. The first one is the type 1 error. So what is the type 1 error? So when we reject the null hypothesis under the condition that it is true. Okay, so so rejecting a true h naught is called the type 1 error. Is like the punishing an innocent person. Okay, then what is the, and this type 1 probability, that the probability of this type 1 is denoted by the alpha, that means the level of significance, called the level of significance of the test, and which is set by the researcher in advance. Okay, before starting our research or this, we first of all we have to set this the level of significance. The next is the type 2 error. What is the type 2 error? Failure to reject the false null hypothesis. That means we accept, or we can say that accept the false null hypothesis. Type 1 is the reject the true null hypothesis, and type 2 error is the accept the false null hypothesis. And the probability of this error is denoted by beta. And obviously we can't avoid both completely, but we always try to minimize the type 1 error by controlling alpha. Okay, that's why we fix, we set this, we fix the probability of type 1 error before starting the testing. uh, the first one, in testing of hypothesis, the first test is the one sample t test. Okay, and this one is the testing a mean against a value. This is a one sample t test. So when we use one sample t test to determine whether a sample mean significantly differs from a hypothesized population value. So as I already mentioned that this one sample t-test is a parametric test, and when we test whether a sample means significantly differ from the population value. So there are some assumptions. First one is the, when we use this one sample t-test, when the population variance is unknown, the sample size is small, and the population from which the sample is drawn is normal. So this is one of the assumption of parametric test, that is the data is normally distributed. So it is the most important assumption that the parent population from which the sample is drawn should be normal, and the observations are independent. These are the assumptions under one sample t-test. So now the suppose this is the example. Suppose test the claim that the true mean mark of HS students in a college is 305. This is the as we can say the assumptions, or we can say the question. The true mean mark of HS students in a college is 305. So we talk about the mean, and we have only one characteristic, that is the marks of HS students. So in that case, we use the one sample t-test. So just listen carefully. So when we talk about when our assumption is on a mean and only one group or one characteristic, Then we use the one sample t-test. Hmm. Next, then what is the null hypothesis? That is, since this population mean is denoted by mu, so mu is equal to 305, and obviously the H1 is a mu is not equal to 305, and this is a two-tailed test, because when we write the null hypothesis in this way, mu is not equal 305, then the test is two-sided. Okay, then obviously we have to specify the desired level of significance. So here alpha is equal to 5%, and we choose a sample from this population. That is, we can say that we draw a sample from this college. That means that we collect marks of some students, 30 students, HS students, and note their marks. So here the sample size is n is equal to 30. So first, after collecting the data, then obviously we enter the data in either Excel or SPSS, because in R it's time consuming to enter a big data. So it is always convenient to enter data in either Excel or SPSS. So first thing is we have to import data from Excel. So I have already shared the Excel files. So this is the R code. We use the function read.csv, and this is the path, or we can say that, this is the destinations where we store our data. This is the name of the data, one sample, and this is the we can say that the path. Okay. Uh, our sample size is 30, but here we, due to limited space, I just show the initial 10 sample size, 10. The first one is this is the serial number, this one is the ID of the students 1 to 10, and these are the marks of the students. You can import from SPSS also. Now, next thing is we have to check the assumptions of the test. So what is the first, what are the assumptions? The first one is the observations are independent, then population variance is unknown. So since the population variance is unknown, we have to estimate this. And the sample size is small. Yes, the sample size is only 30. Then the parent population, this is the most important assumption, that the one of t-test, that the parent population from which the sample is drawn is normal, and we have to test this assumption, so whether our data is normally distributed or not. And in R, we use the Shapiro-Wilk test to verify whether our data follows normal distribution or not. So what will be the null hypothesis under this test? The data is normally distributed, where H1 is the data is not normally distributed. Okay. is not normally distributed. And in R code, this is the in R, this is the test, that is the Shapiro dot test. And just check here, this access is the object, or we can say the variable where we store our data. Okay, that's why since we have two columns, the first one is the ID and the next one is the marks. That's why to define it significantly, we have to use this sign. This is the variable where we store our data, and then give this dollar sign and the variable for which we do this test. So our here the variable is marks, the marks of the students. So this is the output of this code. This Shapiro will normality test. Your data is this. This W is the test statistic value. Okay, and this p value, we will get this p value is 0.4412. Now on the basis of this p value, we draw the conclusions. So what is our conclusion? Since this p value is greater than 5%, that is our level of significance. That's why we accept the null hypothesis and conclude that the data is normally distributed. Okay, if this p value is less than 5%, then we reject our reject the null hypothesis. Since this p value is greater than 5%, so obviously we accept the null hypothesis and conclude that the data is normally distributed, because our null hypothesis is that the data is normally distributed. So here now, as the normality assumption is satisfied, we can now perform the t-test. If this, if the data does not follow normal distribution, then we can't perform this one sample t-test. So for the first criteria is that we have to test whether we have to first check whether our data is normally distributed or not. So the next is the R code for the one sample t test. So this is the inbuilt function in R, t dot test. Then give the first bracket. Then access is the variable where we store the data. And since we have two columns, the first one is the ID and next is the marks, and we do t-test on the variable marks. That's why we have to define it. So this give the dollar sign, this xx, then dollar sign, then marks, comma, this mu is equal to 305. That is our assumption. That is where we assume that our null hypothesis, where we assume that the mean marks of the HS students is 305, and we have to mention or this value, that is the population mean, that is 305. Now since our test is two-sided, yes, just a minute. Since our test is two-sided, mu is not equal to 305, then we don't need to mention your alternative is equal to this comma. Just a minute. Just suppose someone write this alternative is equal to two-sided. So when our test is two-sided, we don't need to mention this. It is by default they consider it two-sided. But when your alternative is one sided, then we have to mention this, that is one sided test. Okay, this alternative is equal to one sided. And this is the output of this function, that is one sample t-test. Your data is this is the test statistic value, that is 5.7848, and this is the df, is the degrees of freedom. Since our sample size is 30, so the degrees of freedom is 29, and the next is the p value, and this is a very small value. So obviously, since it is a smaller than the 0.05, then obviously we reject the null hypothesis and conclude that there is sufficient evidence that the mean mark of HS students is not equal to 305. Since this p-value is less than 5%, so obviously we reject the null hypothesis. So here we have one sample and one characteristic. What is the characteristic, or we can say what is the this marks is the characteristic, and we have only one sample. That's why we use the one sample t-test. Next is the two sample t-test, or we can say the is for independent groups. The two sample t-test determines whether the mean of two independent groups are significantly different from each other. Okay, so this either one sample or two sample test, these are all based on means. Okay, means when since it is a case of two sample t-test, so we have two groups, two different two independent groups. Okay, determines whether the means of two independent groups are significantly different from each other. So we have two groups. So what are the assumptions of this test? First of all, we have two independent groups. The parent populations from which the samples are drawn are normal, which is the most important criteria of parametric test. And the last one is the variances of the two groups are equal. These are the assumptions: independency, normality, and the homogeneity of the variance. Up to this, if you have any doubts, you can ask. Hello. No doubt. Am I audible?
Yes, ma'am.
So for two sample t-test, we have two independent groups, and for one sample t-test, we have only one group. And since we have two independent groups, then obviously we have two means, and in one sample we have only one group and one mean. And since we have two groups, then we one of the assumption under two sample t-test is that the variances of the two groups should be equal. Next, so in what cases we can use two sample t-test? So the example is test the claim that the mean marks of higher secondary HS students in the two colleges are equal. So we have only one characteristic. What is the characteristic? Marks of HS students, but we have two independent groups. What are the groups? Two colleges. Okay. So the null and the alternative hypothesis, the mean marks of HS students in the two colleges A and B are equal. Uh, since we know that the null hypothesis is a hypothesis, is no difference, no effect. It's a default hypothesis. So your H naught is obviously mu1. When what is the mu1? Mu1 is the mean of the first group, or you can say the first population, or in this case we can say that the mean of the marks of HS students of the first college. And mu2 is the mean marks of the HS students of the in the second college. Then obviously the null alternative hypothesis that the mean marks are different, that is mu1 is not equal to mu2. Since is there is not equal, so the test is two-sided test. So the first thing is we have to import the data from Excel. So this YY is the variable where we store our data, and we this is the file name, is the two sample, and I think the size of the sample is 71 or 72, but here we just uh, for your convenient, I just show the first initial 10 samples. Then this is the serial number, is the ID of the students, this college name, and marks. So we have two colleges, say A and B, and these are the marks of the students. Next is the first, we have to check the assumptions of the test. So what is the first assumption? The normality check. Now, when we have only one sample, the code is, we use the Shapiro-Wilk test. In one sample, we use the Shapiro-Wilk test for normality, but the this code is slightly different because we have only one group, or we have only one college. So we write just the Shapiro test, then give the first bracket and the variable name where we store the data. But in this case, since we have two colleges, we have to mention the colleges separately. So we that's why we use the function with WITH. Then we write the variable name where we store the data, then use the test name, that is the Shapiro test. Then this marks is our dependent variable, or we can say the characteristic of this test, and college is the group. Which group? They are, since there are two colleges A and B, so we have to define this college. So college is equal to A. Because here we have two college A and B. So this normality test for the first college, or the sample we have we collected from the first college. So this one, and obviously this is the output of this code, or you can say function. So here the test statistic value is the 0.97 and the p value is the 0.46. Then obviously, since it is greater than 5%, then obviously accept the null hypothesis. So what is the null hypothesis under Shapiro test? That is our the data is normally distributed. So we can say that the data or the sample we collected from the first college is normally distributed. Next is the we do the same test, normality test for the college B. So just same code, just replace it by B, and this is the output. is the test statistic value, is the p-value. Since the p-value is greater than 5%, then obviously we accept the null hypothesis and we can conclude that the sample we draw from the college B is normally distributed. So what is the sample? Marks of the HS students. Next assumption is the equality of variances. So what is the null hypothesis under this test? The variances of the two groups or the two samples are equal, and obviously the alternative hypothesis is that the variances of the two groups are different. So for variance test, we use this code in R, that is var.test test. Then we do the variance test for the variable marks, and we give this symbol. And what are the groups? This college is the under this college we have this variable. Under this variable college we have two groups, A and B, and this is inbuilt function data is equal to the yy. What is the yy? Is the variable where we stored the our data. This var dot, this is the inbuilt function. This may be changed according to your variable names. This data is inbuilt function, and and this is the variable name. You can use any name here. So this is the output. This f is the test statistic value, and this is the df. In two sample t-test we have two dfs, and next is the p-value, and this p-value is greater than 5%. So we accept the null hypothesis and we can conclude that the variances of the two groups are equal. So we fulfill the all the assumptions of the two sample t-test. The first one, since as all the assumptions are satisfied, we can now perform the two sample t-test. The first assumption is the normality, and second is the homogeneity of variances. So this is the R code for two sample t-test. So this is the inbuilt function t dot test, and this is the variable, this dependent variable or the characteristic of this study, that is the marks of the HS students. This is the group. We have two colleges, and this is inbuilt function data data is equal to yy, and we since the variances of the two groups are equal, we have to mention this. That is var, that is variance dot equal, is equal to true. So this is the output of this code. That is the two sample t-test. Data is the marks by college, and this t is the test statistic, and this is the df, and is the p-value. Is the p-value is 0.6, and since this p-value is greater than 0.05, then obviously we accept the null hypothesis and conclude that the mean marks of HS students in the two colleges are equal. So next one is the paired t-test. So now what is the the paired t-test, also called the dependent t-test, is used to compare the two related groups or samples, typically before and after measurements on the same characteristic. In two sample t-test we have two independent groups, but in paired t-test we have two dependent groups. That means we collect data from the related groups. For example, suppose before and after measurements on the same characteristic. So what are the assumption of this test? Same group measured twice. So we have the same sample, but we measured twice. That is before and after treatment or anything. So that means the samples are not independent, they are dependent. And we have two related groups, not independent, and the data are continuous and normally distributed. Normality is the main assumptions of parametric test. Okay. Is the example. Suppose a researcher wants to test whether a training program improves test scores. This is the question, or you can say the objective, anything, that a researcher wants to test whether a training program improves the test score or not. So first of all, the researcher collect scores, test scores of the some students. Here we here the size of the sample is 10 before and after the training program. So same students, we just collect the data before the before giving the training program and after the training program. So obviously the data are not independent, they are dependent. These are the students. We have 10 students. This is the test score before the training program, and this is the these are the test scores after giving the training program. So for pair t-test, what is the null hypothesis? Uh, Here first we assume that this D is denoted by the mean of the differences. What is the difference? That is the after minus before. That is 65 minus 60, 67 minus 62. These are the differences, and this differences the mean of the differences is denoted by capital D. And here the null hypothesis is that D is equal to 0. That is, training had no effect. That means the marks of the mean marks of the students before taking the training is same as the mean marks of the students after receive the training. So the alternative hypothesis is D is not equal to 0. That is, there is a significant change, or the training had an effect. So first of all, we have to check the assumptions of the test. So what is the we have just checked the normality assumption. The differences between the paired observations must be approximately normally distributed. So what is the assumptions here? The differences between the paired observation, that is this observation, that is 65 minus 60, 67 minus 62, this observations follows normal distribution. So this is the R code for normality test. So since the size of the sample is just 10, that's why we entered the data here is the before marks and test score and after marks. In previous for one sample and two samples, since the size of the data is large, that's why we use the Excel. And since here the size of the sample is just 10, that's why we directly enter the data uh, on R. So this is the before marks and after marks. Then we know that C is called the vector, and these are the marks. So next is the calculate the differences. So we use the variable DIFF. You can use any variable instead of DIF. So after minus before values. Next, for normality, we know that in R, we use the Shapiro-Wilk test, and this is. But yes, I would love to be. So this is the test. This Shapiro dot test is an inbuilt function. Then use the first bracket and write the variable name is DIFF, because we uh, test the normality for the differences between the paired observation, not the individual group. So this is the test statistic value 0.933, and is the p value is the 0.47. Since it is greater than 0.05, then obviously the differences are normally distributed, because under Shapiro test the null hypothesis assume that the data is normally distributed, and since the p value is greater than 0.5, then we accept the null hypothesis and conclude that the differences are normally distributed. Since as the normality assumption is met, we can use the paired t-test. So the R code for the paired t-test, we use the same test for one sample two sample and paired t-test. So here this is the inbuilt function t dot test. We use the before variable, this is the marks of the students before receiving the training program, and this is the after marks. And we have to, since it is a paired t-test, we have to mention this paired is equal to true. This is the inbuilt functions. You can't change it. PAIRED is equal to true. So this is the output, is the paired t-test, and the test statistic value, and DF is 9, since the sample size is 10, and this is the p value is the 1.528 e to the power minus 0.7, and this is a very small value, and since it is obviously less than 0.05, so we reject the null hypothesis and conclude that the training program had a statistically significant effect on test scores. Since we reject the null hypothesis, so we conclude that this. So next is the analysis of variance, that is ANOVA. So when we use ANOVA is used to determine whether the means of 3 or more independent groups differ significantly from one another. So listen carefully. For one sample t-test, we have only one group. In two sample t-test, two sample t-test is used for two groups, and when we have more than two groups, we use the analysis of variance technique. So the first under analysis of variance technique, the first one is the one-way analysis of variance. So it is used to test whether there is a difference between means of more than two groups when we have only one categorical independent variable with multiple levels. So what is the one categorical variable, independent variables means, if we consider the example of marks, then marks is the variable, and with multiple levels means the number of colleges. Okay, so since the analysis of variance technique is used when we test for more than two groups. So this one way analysis of variance, we have only one variable but multiple groups, that is more than two groups, but we have only one variable. That's why it is called one way analysis of variance. So just check, t-test for independent samples, we have two groups, but one factor ANOVA have this one factor ANOVA test has three groups, 1, 2, and 3. This is for the t-test and this is for ANOVA. So now the next thing is, what are the assumptions of this test? So first of all, we have more than more than two independent groups. Next is the data are continuous and normally distributed, and the last assumption is that the variances of the groups are equal. This is same as the t-test for independent samples. We can say that this is the generalized version of the t-test for independent samples. Since ANOVA is used when we have more than two groups or two samples. So we consider the same example. In the one sample t-test, we have only one college. In two sample t-test, we have two colleges. Two sample t-test for independent groups, we have two colleges, and for ANOVA we consider three colleges. So the variable remain the same. The mean marks of the HS students in the three colleges are equal. So what are the alternative and null and the alternative hypothesis? There is no significant difference between the mean marks of HS students in the three colleges, and this one is the uh, null hypothesis, and this is the alternative hypothesis. The mean marks are different. Uh, so first is the we import the data from Excel, and just I this is the data. First of all, you have to convert your Excel file into CSV. I think you know about this. So this is the variable. This is the serial number, then ID of the students, is the college name, and the marks. We have three colleges, A, B, and C. So the first initial 9 sample units. Uh, then check the assumptions of the test. The first one is the normality check. Since we have three groups, so we check the normality test independently for each group. Suppose if I consider this, it just okay. So is the just this chaperone normality test. This is the test statistic value and is the p value. uh, the normality check for the college A, and since this p value is greater than 5%, so we accept the null hypothesis and we can conclude that the sample data that we collected from the college A is normally distributed. So next is the next we check the normality assumption for college B and use the same code, that is the Shapiro test, and we use the width function. Why? Because we have more than when we have more than one group, we have to use this function width. Then for college B, since the p value is greater than 0.5%, so we accept the null hypothesis and do the similar test for the college C, and we observe that for college C, the p value is the greater than 5%, then obviously we accept the null hypothesis and conclude that the sample withdrawn from the college C is normally distributed. Next assumption is that the variances of all the groups are equal. So this test is that is the homogeneity of variance test. So the null hypotheses are under this test, the homogeneity of variance test, the variances are equal for all the groups. And what is the null hypothesis? Alternative hypothesis, the variances are different. So we use the Bartlett test for homogeneity of variances, and in R the code for Bartlett test is bartlwet.tst is an inbuilt function. Then we use the variable, that is marks, then the group name, that is college, and this is obviously inbuilt function. This data is equal to the this is the variable name where we store our data, and we can change according to our convenient, but we can't change this function, this Bartlett test and this data. So this is the test statistic value 1.5947, and this p value is 0.45, which is greater than 5%, accept the null hypothesis, and we can conclude that the variances of all the groups are, or all the yes, all the groups, we have three groups A, B, C, are equal. Next is, as all the assumptions are satisfied, now we can perform the one-way ANOVA test. So this is the R code for ANOVA test. First of all, we have to define a variable. Here we use one way. You can use any name. So this one is the one-way ANOVA. This AOV means when we go for ANOVA test, we use the function AOV. This is a inbuilt function in R. Then our variable, that is the marks, group, college, then data. Just copy. So next we write the function summary and use the variable name, that is one way. Copy. we will get the result. Uh, this this is the output of this function is df sum of squares, mean squares, f value, and this is the p value. Since the obviously this is the test statistic value, that is the f value, and this is the p value, uh, which is greater than 0.5 sorry 5%. So we accept the null hypothesis and conclude that the mean marks of HS students in the three colleges are equal. So these are all the parametric tests: one sample t test, two sample t test when the groups are independent, then pair t test when the groups are dependent, and when we have more than two independent groups, we go for the ANOVA test. Now, what is a non-parametric test? So classical, or you can say the parametric test, assume normality and equal variances conditions. But in real life, data often violate those assumptions. So non-parametric tests are more robust. They work on ranks rather than raw values and are often distribution free and less sensitive to outliers. That means in non-parametric test, we don't need to assume that the our sample or our data is normally distributed and the variances of the groups are equal. Okay. Mm, So when these assumptions are not fulfilled, this normality and the equality of variance in parametric test, then we go for the non-parametric test. The first non-parametric test is the Wilcoxon signed rank test. So Wilcoxon signed rank test is a non-parametric test alternative to the one sample and the pair t-test. Okay, so if one sample and pair t-test, if the assumptions are not fulfilled, that is the normality assumptions and the equality of yes, normality assumptions, then we go for the Wilcoxon sign rank test. And these are the assumptions of this test: data is not normally distributed, data is either ordinal or continuous. In parametric test, the data must be in continuous form, but in non-parametric test, data is maybe either in ordinal or in continuous form. Next is the since it is alternative to the one sample and the pair t-test, so the data is either paired or one sample. Next is in Wilcoxon sign rank test, we testing the median against a specific value, not mean, like t-test. What is the meaning of this sentence? In one sample t-test or the pair t-test, we basically test for the mean. For example, in one sample t-test, we assume that the mean marks of HS students in a college is 305. But in Wilcoxon sign rank test or in non-parametric test, we basically go for the median, not mean. So I think all of you know what is median. What is median? Hello? What is median? Okay. So median is the middlemost value of a set of observations, and mean is the average. This is the difference, median and mean. And in parametric test, we use the mean of a set of data, and in non-parametric test, we use the median of a data set. And what is the median? Median is the middlemost value. So first is the Wilcoxon sign rank test for one sample. So what is for what type of example we can use this test? Test the claim that the median height of a group of students. Hmm. So, what is the test? That the median height of a group of students differs from the national median height of 170 centimeter. So, here, the first we have only one group, that is a group of students, and we use the median instead of mean. So in Wilcoxon sign rank test we use median instead of mean. And why it is called the one sample? Because we have only one group. So the claim is that the median height of a group of students differ from the national median height of 170 centimeter. So this is the population median. That is 170 is the population median. So what is the null hypothesis? And obviously we make the assumptions on the basis of about the population, not the sample. And we draw sample and check on the using hypothesis testing technique whether the assumptions about the population is true or not on the basis of the observed sample. This is the basic concept behind the hypothesis testing. So here the population median is 170. So we then the our null hypothesis is that the median height of the students is equal to 170. That is m is equal to 170. This population mean is usually denoted by mu. Since it is a median, so it is denoted by m is 170, and this is your alternative hypothesis. And obviously we collect a data uh, of a group of students. The height, these are the heights in centimeters. uh, this is our data set. So the next step is the first we enter the data. We use the variable name heights. You can use any name. This height c is the inbuilt function in R. We use it for vector. Now what is the code for Wilcoxon sign rank test? This is the inbuilt function in R, wilcox dot test. And this is the variable heights is the variable, so heights. And similar to the one sample t test under parametric, we use the mu is equal to 170. In this case we have to use we also use this mu is equal to 170. Here mu means median, is not mean. Okay, so this is the output of this function, the Wilcoxon sign rank test for continuity corrections. V is the test statistic and p value is this. And alternative hypothesis, obviously the true location is not equal to. So when we run this test, we will get this output. Okay. Since the p-value is greater than 5%, accept the null hypothesis and conclude that the median height of the students is equal to 170 centimeter. Next is the Wilcoxon sign rank test for paired sample. So since paired means we have two groups but two dependent groups. Okay, we draw the we collect values from the same sample before and after. Okay, so example, suppose a researcher wants to test whether a new teaching method improves students test score or not. So this is the sample. Now if the difference, since it is a paired t-test, So if the differences of each, if the differences follow normal distribution, then we use the parametric paired t-test. But when we have this same data set, if this data set follows normal distribution, then we go for the paired parametric paired t-test. And if this data set does not follow normal distribution, then we go for the Wilcoxon sign rank test. So the data consists of test scores from 10 students measured before and after applying the new teaching method, and each student has a paired set of scores. We have the for student 1, we collect the data. These are the test scores before and after applying the new teaching method. So what is our null hypothesis? The median difference between pre and post test scores is 0. Since it is a non-parametric test, so we go for median, not mean. That means there is no the new teaching method had no effect. Okay. Then what is your alternative hypothesis? That the median difference between pre and post test score is not 0. That means that the new teaching method had an effect. So first of all, what is the R code for performing this test? First we enter the data, pre test scores and the post test scores, and we use the inbuilt function, that is the Wilcox dot test in R, that is the post value and the pre value. And we since it is a paired sample test, so we use the function paired, and which is equal to true. And this is the output of this function, that is v is equal to, this is the test statistic value, and this is the p value. And so as usual, when we run this functions, we will get this output, and on the basis of this output we can conclude that on the basis of this output we can say that we accept the null hypothesis and conclude that there is no significant effect of new teaching method. Okay, or we can see that the median difference between pre and post test scores is 0, same thing. Okay, we can write in this way also. Okay, there is no significant effect of new teaching method. Next is the Mann-Whitney U-test. So Mann-Whitney U-test, also known as the Wilcoxon rank sum test, is a non-parametric statistical test used to determine whether two independent groups differ significantly in terms of their median. So this is Wilcoxon rank sum test is the alternative to the two sample independent two sample t-test. Okay, so when the normality and the equality of variance conditions are not satisfied in independent two sample t-test, we go for the Wilcoxon rank sum test. So what are the assumptions? Two independent groups, the data are either ordinal or continuous but not normally distributed. The sample size can be small or equal, and compare medians rather than means. In parametric test, we use the means of the population or sample, but in non-parametric test we use the median. So this is the example. Suppose a researcher wants to test the effect of two diets, A and B, on weight loss. So it is a case of two independent sample. What are the two groups, independent groups? Two different type of diets, A and B. Okay, and weight loss is your variable or characteristic of your data set. Clear? So these are the null and the alternative hypothesis. The median weight loss is same for both diet A and diet B, and obviously there is a difference, and in alternative hypothesis there is no difference. So this is the sample. These are the participants. We have 20 participants. Then out of 20, these are the diets. We have two different types of diets, A and B, and these are the weight loss values. This is not a is not related samples. Both are independent. Why independent? Because we have two different types of diet and one character variable, that is the weight loss. This is the R code. First of all, we enter the data in R. We use uh, uh, my variable name is A, and we use the vector function in, and second one is the B, this. And we use the inbuilt function Wilcox test. We have two groups, A and B. We can use this alternative is equal to two-sided. Why two-sided? Because we write there is no difference in the median of weight loss between the two diet groups A and B. Okay, that's why is two-sided, and we use this inbuilt function exact is equal to false. This is for two independent samples. When we use the Wilcoxon test, we have to use this inbuilt function, that is exact equal to false. For paired, we have to write the paired is equal to true. Then this is the output of this function. W is the test statistic value, and we have this p value. Uh, Obviously, this is less than the 5%. So we reject the null hypothesis and conclude that there is sufficient evidence that the mean weight loss is different for diet A and diet B. Last is the next test is the Kruskal-Wallis test. This is just alternative to the one-way analysis of variance. This Kruskal-Wallis test is a non-parametric statistical test used to compare three or more independent groups. Okay, this is just alternative to the one-way analysis of variance. So what are the assumptions? Three or more independent groups. The data are either ordinal or the continuous, but not normally distributed. And as usual, the sample sizes can be small or unequal, and compare the medians rather than means. So this is an example. Compare the exam scores across three different teaching methods. Um, these are the alternative hypothesis. The medians of all groups are equal. At least one group's median differs from the others. So this is the sample data. So we have, since it is a, uh, we used this test for more than two groups. Here we have three methods, 1, 2, 3. These are the participants. These are the test scores marks. So method 1, we have 5 values, similar for method 2 from 6 to 10, and for method 3 from 11 to 15. So first we enter the data under the variables method 1, method 2, and method 3. then use the inbuilt function for performing this test is the Kruskal dot test. Since we have three groups, we use the function list. Don't write it. Uh, so without using this, if you don't use this list functions, we can get this value. You can't get this value. So this is the list. We have to use this inbuilt function list, then method 1, method 2, and method 3. So this is the output of this function. This is the test statistic value is 11.015, and this is the p value. Since the p value is less than 5%, so we reject the null hypothesis and conclude that there is a significant difference between the medians of the groups. So these are the alternatives of the parametric test. For one sample and the paired sample, we use the Wilcoxon. For independent two sample test, we use the Mann-Whitney U test, and for ANOVA, we use the Kruskal test. The last one is the chi-square test. So in t-test or the Wilcoxon test or ANOVA or Kruskal test, where we assume that the data are continuous. But in chi-square test is used for categorical data. So there are the two main types of chi-square test. One is for the test of independence, where we test two categorical variables are associated or not, and one for the goodness of fit test. This is for the distribution. So here we today we discuss only the test of independence. We have two categorical variables. Okay, not in these are not independent. So what are the assumptions of the test? Have two categorical variables, one to test if they are related or independent, and data is in a contingency table. Okay, this is the example to test whether there is a significant associations between smoking habits and exercise routines. So in chi-square test is basically used for categorical variable. We have two categories, and we want to test whether whether the categories are related or independent. Okay, so we consider one example where we test the associations between the smoking habits and the exercise routines. So this is our data set. Smoker, non-smoker, exercise regularly. This is a categorical variable. It's a yes no variable. Is no height, weight, then the marks. Then these are the continuous variables. But here, yes no variables are called the categorical variables, or the male female or the pass fail. These are called categorical variables. So here, that means uh, 5 participants report that they are smoker and they exercises regularly, whereas 28 participants reported that they are smoker but they do not exercise regularly. Similarly for this. Then what are the null hypotheses? The first one is there is no significant associations between smoking habits and exercise routines. There is no significant associations between smoking habits and exercise routines. And what is your alternative hypothesis? Smoking habit and exercise routine are associated. Since initially we mentioned that the null hypothesis is basically a default hypothesis or a default assumptions where we assume no effect, no difference, nothing. So here we assume that there is no associations between the variables smoking habits and exercise routines. So whereas we alternative hypothesis is this. So this is our this is the data set. So one of the assumptions of the chi-square test is the data is in a contingency table. So for create a contingency table, we use the function matrix. So first is the variable name. So you can use any name here. So this is not inbuilt data here. Matrix is an inbuilt function in R. So we use the matrix function to create the data in a contingency table. So this is the vector sign C, and these are the values. Since it is a case of matrix, so we have row and columns. So we use the and row, means number of rows is 2 and by row is equal to true. So add the row and the column names. Row names is smoker and the non-smoker, and the column names is this. So just when we uh, uh, run this code in R, just you get this one. Okay, the smoker, non-smoker, exercise and does not exercise. So the data is in a contingency table. So next we use the chi-square test. It is an inbuilt function CHISQ dot test, and data is the variable name. So when we run this test, we get this output, that is the chi-square. The test statistic value is the 9.9, and your since it is a 2 by 2 contingency table, so the DF is only 1, and the p value is 0.00159, which is less than 5%. So reject the null hypothesis and conclude that the smoking habit and exercise routine are associated. This. So if anyone has any questions, then you can ask.
Yes, ma'am. I have a question.
Yes.
Ma'am, it's about ANOVA part.
Yes.
Mm.
Please ask.
Yeah, it's about the absorption of ANOVA. Yeah, ANOVA.
Anova.
Mm. Yeah, the assumption.
So what are the assumptions? So first,
Yeah,
these
yeah,
are the assumptions.
yeah. My question is for
Mm-hmm.
to test the variance of group are equal. Uh,
To test
to
variances.
test, yeah, are equal.
Yes.
So
Hmm.
yeah, you can next slide.
Yes. This is the
Next.
alternative test. This is the
Next.
normality check.
Yeah, yeah, here, ma'am.
Homogeneity of variance test. Okay.
Yeah,
Then.
homogeneous variance. The next,
Hmm.
right?
Hmm.
Yeah. The next, yeah, here.
Hmm. Hmm.
So here you instead of the previous one, you use var test as
Yes.
a function.
Bartlett test. Yes.
Yeah. What is the difference between var test and the var test in R?
What is the Bartlett test and the
var test. This one, I will write.
this one, or
This one with I will write for you, ma'am. Okay.
is the variance test?
Yeah, variant test. Yeah.
Oh, okay, okay. Huh. This variance test for we use this variant test for two groups. When we have two groups, we use the variant test to check the equality of the variances. But
Okay.
when we have more than two groups, we have to use this Bartlett test. Okay.
Okay. Okay. Okay. Thank you so much, ma'am. Thank you. Yeah.
Hmm. Any questions? Any questions?
Ma'am, is your session
Yes.
over, or students can take a? I mean, if they're comfortable, then they can put up the questions at the end also.
Yes, yes. They can put
Then you'll
my present.
continue with the session now.
My presentation is over.
Over? Okay.
Yes.
Uh, so, dear participants, if there are any other questions, then you may kindly clear your doubts with ma'am. Any topic, if you're having any doubts, you can clear your doubts. Okay, ma'am, in the chat, there are no other questions. So, I
Yes. Yes.
think,
Okay. Okay.
yeah, so I think we can end the session. And in case of any doubts or queries students are having, they can, I think, connect to you. You can share your
Yes,
email
yes,
ID,
yes,
ma'am.
yes, yes. I will share in the chat box.
Yeah. We are getting, participants' feedback. It's good session. So I think the participants are able to very well understand the concepts, and they will be able to use it as well in future in their research papers, in their thesis, etc. Okay, ma'am has shared her
Yes,
email ID.
yes. If you have any doubts or anything, you can contact me. Okay, this is my email ID.
Okay, so ma'am's email ID is arpita.basak, all in small, @guwahati.ac.in. So it's given the chat box, so participants can. Okay, so as we have no queries, so we come to the end of today's session on hypothesis testing using R. And ma'am, we are very much grateful that you spared your valuable time to share your knowledge and understanding on the concept with our participants, with our faculty members, with our research scholars. And I hope they will be able to use it in the future period. And it was very nice how, in a lucid way, you explained it right from the ABCs of hypothesis testing to the application of it by using R. So thank you so much, ma'am. We hope to collaborate with you in the future events as well. Thank you so much.
Thank you, ma'am, and thank you, participants, for listening patiently. Thank you, ma'am.
Thank you. Thank you. So, dear participants, we have come to the end of the session. The next session will begin again at 2 o'clock. So I request you to join the session again at 2 o'clock. Now you may go, we may break up for lunch, and then we can join again at 2 o'clock. Thank you so much. Good afternoon, participants. So we'll start with our session. Our expert has joined us. So now for the session, we have with us Dr. Vivek Verma, who is an assistant professor in the Department of Statistics in Assam University, Silchar. Sir is specialized in Bayesian analysis, epidemiology, sampling theory, demography, biostatistics, and clinical trials. Sir earned his PhD in statistics from Gauhati University, and he is an MSc in statistics with a gold medal from the University of Burdwan. He is also the proud recipient of the prestigious DST INSPI RE Fellowship. Dr. Verma has previously served as scientist D and research officer at AIIMS New Delhi, where he contributed to large scale cohort studies and stroke research, and as a research fellow at Gauhati University. He has led several ICMR, ICSSR, and DST funded projects in public health, healthcare policy evaluation, and clinical research. His doctoral work focused on Bayesian estimation under ranked set sampling with applications to demography, and he has authored over 60 research publications in reputed national and international journals. Dr. Verma brings with him an extensive expertise in analyzing advanced statistical methods to real world health and demographic challenges. So, we are really grateful to have you here with us in today's session, in third day, second session, and we really feel fortunate that our research scholars and faculty members will be able to get information, idea, knowledge from the expert minds. So, sir, we welcome you to the session and we hand over the session to you.
Thank you, ma'am. Thank you. May I share my PPT?
Sure, sure, sir, sure.
Just confirm. Is my screen visible?
No, sir, you have started. Yeah, it's visible now. Yeah.
Okay. First of all, am I audible? Me or
Yes, sir, you're audible.
camera?
Yes, sir,
Yes.
you're audible.
Audible. First of all, I would like to. Okay. Thank you. First of all, I would like to thank the Assam Royal Global University for giving me this opportunity to interact and share whatever the experience I have of being a statistician. And I also want to congratulate the organizers of this online workshop on data analysis for academic research in R. And special thanks to Aruna Madam for being in touch, and bearing with any statistician is not an easy task. They keep on rolling, they keep on changing, they have multiple questions, but ma'am is always helpful and supportive. Because of her only, I can't means I got that opportunity to interact with all of you. Thank you, ma'am, for these all arrangements and coordinations.
Thank you so much, sir. Thank you.
Really. As the topic was decided for me, that is about the regression, but I thought that the story should start with the correlation. Um, then may I start, ma'am?
Yes, sir, you may.
Okay. As you all have gone through that one, because I have gone through the means brochure, that it says that already someone means the participant got that interaction and knowledge about what is called basics of R, some of the topics associated with statistics. I am more into that when you are going to organize any kind of research. What are the steps you should follow? The story never started with the descriptive. It gets started with once we are going to talk about the correlation, or better to say association. Here we are going to talk about the correlation, as the Dr. Arpita has already emphasized how the parametric non-parametric test is there, ANOVA is there. Then you have already explored how to make your decision and how you can cross check your decisions with certain level of accuracy. Okay. What is called correlation? As you have already heard about that one, when you are going to talk about that one, that is about that is a statistical tool, nothing more than that. It says that it talks about the two things. What is the strength among two variables? and along with the strength, what is the direction of that? Is that concordant or discordant? Means concordance means if one is changing, whether the change with the other variable is in the same direction or is in different direction. If it is changing, what is the quantum of change? In order to get that answer, the correlation is usually described in three different ways. Whether that is a positively correlated, negatively correlated, or positive correlated means in the same direction, that is increasing means increasing. If that is decreasing with decrease in the values, then that is called as perfectly negative correlated. And when there is no concordance or say no correlation, then both of the variables will act independently. That is the beauty of that. Then being any scholar, or you are a young means say researcher who you want to know some of the topics when you are going to emphasize your findings or the contribution, then your question should be very specific. My focus of the study is to know the existence or lack of relationship among two variables. The variable will be predefined and can be assessed while planning your study plan. Then as we all know that the major concern, if you look after the graph, is that the arrow is a straight line. That straight line is one of the important concern we usually misinterpret. We are going to emphasize the same. Positive correlation is says that both of the variables, those who is on the x-axis and another on the y-axis, that is a positively correlated in the sense that is linearly correlated. If one unit change in one variable, then the similar sort of change will also observe in the another variable. The linear word is one of the important thing. The negative correlation says that the one variable is rising and another variable is working in the opposite direction. Zero correlation says that there is zero correlation doesn't mean that that is not correlated. Zero correlation in case of correlation is says that they are not linearly related. If you are going to get a values, correlation usually lies between 0 -1 to +1. If your value is 0.3, then usually people say that that is poorly correlated. It never be a poorly correlated. It is always is better to say that is not linearly correlated. That may be curved linear, that may be one-sided linear, that may be scattered to some point, may be distorted with certain point. These all things are possible, and that brings us for the further analysis. So have that word clear. When we say linearly related, positive or negative, when we say there is no relation, then be specific, means there is no positive correlation or no linear correlation. Okay, anyone has any doubt? Feel free, because this is an interactive session. I request as well as always suggest the participant to be interactive. If you have any queries and question in any of the content, feel free to ask. Now, this is the way, means usually we define the correlation in among the two variables. It's easy to depict also. You just do the scatter plot, you can check. But what will happen if we have more than one variable? Then the presentation cannot be through a two-dimensional plot. Then in that case, we have different plots which we can depict to measure the correlation. Some of them I have depicted. If we just look after that one, that is the first graph is talking about that. That is a matrix of the set of the variables. The diagonal element always talk about the one, and the off diagonal element will talk about the direction of the strength of the correlation. That is called as the complete correlation matrix. The correlation can be a upper sided and lower sided. If you look after the second plot, and that is looking much more attractive. If you are working with the topic like regression, you have multiple variable to assess. I prefer to, when you are going to go for the regression, first prepare your correlation plot. If that plot is making some sense, you can add directly in your research work. That will also strengthen the content, as well as also will be a self-explanatory mode of explaining your correlative variables. Now, is that correlation is only two-way? No, it was never be a two-dimensional correlation. Usually, based on your x and y variable, as I have talked, based on the type of the variable, the correlation has been defined. Then what are the possible correlation one can explore? That is, if your x variable is continuous and y variable is also continuous, then you have already heard about the correlation. That is the Pearson's correlation, Spearman's rank correlation, and Kendall's tau. That is easily available textbook. If you are going through above graduation and above, you are very much familiar. But what will happen when you are dealing with a variable where one is continuous and another is categorical? Then the measure of correlation is not among the known one. Then there is a separate correlation matrix whose name is point by serial correlation. That is for your knowledge. It is not a topic for the discussion. This is for the introductory talk about those who are in the research. When you have a one continuous variable, one categorical variable, don't use any of these three. A separate correlation measure is there. What will happen when you have a both of the categorical variables? Then Spearman's rho, Kramer's V, and Kendall's tau are very known measures that we can use for the categorical variable correlation. In that case, when there is a two categories, it is not known as a correlation. Usually we talk it as a association. Okay. Now, as the topic is about how we can use that correlation using R, the command is very simple. I think you have already familiar with that. The command has three parts. First is uh, that is called indexing, where you are going to talk about the variable or the analysis which you are planning, which we say that COR, denoting the correlation. X and Y, if you look after that one, X is says that the first variable and Y is called as null. Here by default they have mentioned that null, but you can add it as your own variable. Use everything means when you are going to use the entire data for your analysis. As I have told you, the known correlation measure is Pearson's, Kendall, and Spearman's. By default, when you are not going to discuss about the method, the R command is going to execute the correlation using the Pearson's formula that you have already explored in your first or 2 days of lecture. I have shared a database with you, which is a basically generated database. It is some of the variables or characteristics is associated with National Family Health Survey. That is the fourth round. Then what I have incorporated among that. That is X is denoting the serial number. HHID is the household ID from which household the individual got selected. Residence is a type 1 means rural, and type 2 residence is type 2, then in that case urban. Wealth has been categorized into 5 categories: poorest, poor, rich, middle, rich, and richest. Gender 1 means male and 2 means female. If you have heard about hypertension, then in that case that is one of the important thing is systolic blood pressure and diastolic blood pressure. The variable, if you once you will see that, I will show you how that will look like. Systolic blood pressure is the, if you are going to do that BP measurement, the highest value is that, or the top value is called systolic blood pressure, and the lower value is called as diastolic blood pressure. For an individual whose BP is normal, the ideal state of the systolic should be closer to 120 and diastolic should be closer to 80. Similarly, cholesterol, say weight and height, you are already aware. These are the variables that I have considered for the exploration in that particular session. Let's see. The command is there. First, I have to incorporate my data. I am not going to discuss this repetition of that step, because once the data has been fed, the entire session will consider this data as a reference database for the exploration. Keep these variables in your mind: residence, wealth, gender, systolic blood pressure, diastolic blood pressure, cholesterol, height, and weight. These are very known variables, so that is nothing to imagine. If we just check, I just did that command. I have incorporated, as you have heard, core is the core correlation variable. NFHS is the data name. As I have incorporated, NFHS is the variable which is storing the database. And 6 to 9, if you just go through that one, we have a total of 10 variables. I am considering 6 to 9: systolic blood pressure, diastolic blood pressure, cholesterol, and weight. The correlation is like that one. Can anyone say which variable is highly correlated? Participants. Hello. Hello. Am I audible? I got some responses. Which variable is, seems to be the highly correlated one? If we just look after that study, then cholesterol. Okay. Any other guess? Cholesterol with whom? See, the range of the correlation is -1 to +1. -1 is the correlation in the negative direction, means highly correlated but in negative sense. That is called a negatively correlated. Once the value is closer to -1 or +1, then we say that is positively correlated or negatively correlated. If you look after that variable, then you can see that zero point 0.8, can everyone see? Systolic blood pressure is zero point 0.8 associated with the diastolic blood pressure. If your systolic is high, then the chances is quite high that your diastolic will also be high. But no such kind of correlation is observed among the other variables. Can you get that -1? If systolic is increasing, then in that case, your weight will increase, then the systolic will decrease. This is some sort of negative correlation we can see. But it is not making sense. That's why that is its recognition is -0.006. It's closer to zero. We can't say that is linearly associated with systolic blood pressure. That is the major thing that we have to always focus. When you are going to incorporate your variable for the regression, first do that correlation check. How weight can be correlated? Just check. Cholesterol with weight variable is -0.002. It's quite it's closer to zero, neither to 1, not to +1, not to -1. That is the not linearly correlated. Okay. Then if we are going to plot, see, this is a table which we have to think about a lot, which one is correlated or not. It's better to depict the same thing using a command. I think you all have heard about the libraries. You know how to install the library. In order to get that plot, you need two different packages. First is called ggplot and another is called gg correlation plot. This is called gg core plot. Just do that. R is the variable. If you just check correlation command, I have used R as a variable for the correlation. And which package it is using? By default, it is using the Pearson measure for the measuring the correlation. Then what is that? The same pictorial way which we have discussed. These are the things which you can see. Just giving the type. If you just look after that one, type is lower, means that a matrix will be presented in the lower dimensional one, that you can see in the lower. Okay. Cholesterol, height, weight, systolic blood pressure and diastolic blood pressure. Okay. Just check 0.81 is there. The red is saying closer to 1 and blue is saying -1. Okay. Rather than saying everything through the language, we can also use the depict the images, that will be more interactive and informative. Okay. Now, we have all measured that what is the correlation among the two variables. Now the story started with the regression. When you have a set of variables that are correlated, then what is the outcome we can see? Then the story started with the regression. The correlation is not going to talk. It only says about the measure. It is not going to talk about the quantification. What will happen with one variable change to the another variable? That is only talking about the measure of variable. Like if someone says that the sum of two number is 5, no one can say what these two numbers are. Similarly, when we are going to talk about the correlation, it is a derived measure which is not going to consider, and it is also unit free. One should always remember, when there is a question about that, define a measure which is unit free, the first measure we can talk about it is a correlation. Then the regression comes into the picture. What is the purpose of regression? Nothing more than that, a way through which your outcome variable can be understood by the help of the predictor variable. Like we can say, when you are a teacher, then you deliver your talks in an open session where all the students are equally attentive and can be considered as equally eligible to get that knowledge. But when we are going to assess the results, then we say that all students are not getting the same grades. Being a teacher, our interest is that what is the lacunas which is associated with some of the students whose performance were not in satisfactory. Then the regression is going to the more helpful measure. So then what is the purpose of the regression is that to determine relationship between dependent, there is your outcome variable or variable of interest or study variable, and one or more independent variables. In our previous deliberation, we have seen that only one variable is seems to be correlated, that is a systolic with diastolic. Okay, nothing more than that. What are the common types? Usually it has multiple types, but for that particular session and introductory talk, we are going to confine with the two one that is called linear regression, because we started our journey with the linear correlation, and logistic regression. The simple linear regression, what it says, that is the linear relationship between predictor and outcome. If you can recall your school days, then the equation is y is equal to ax plus b. That is called simple linear equation. What is the change in the regression? I will add it over the course of time. You will understand why it is called as regression, not a linear regression, okay, or linear function. The same equation you can see, outcome variable a is a constant value, slope, which is known as slope of the constant, y is equal to ax plus b. A and x is your predictor variable, and b is your intercept. Its name is very specific. What does it mean? We will discuss that. Okay, when your variable is continuous, then it sounds good to discuss about the linear regression. When your outcome variable is category, it's not possible to describe in a linear form. Then we take the help of some sort of transformation, which is known as generalized linear models, where what is that, the same linear regression will be defined by using some other measure rather than the variable. Then it can say predictor, they say outcome y can be defined as not as a linear function. We will say 1 by 1 plus e to the power minus z. Z your predictor variable, or the variables which you are considering as the associated variables and independent variables, basically commonly known as independent variables. Now, if we talk about the linear regression, let me tell you one thing. The topic which was assigned is called simple versus multiple linear regression. The equation is very simple. If you are going to use these things using R, that what is the purpose of linear regression? The simple. If you talk about the in terms of the users who want to explore, predicting a continuous or target outcome. Keep notice that linear regression is possible when your outcome variable is continuous, based on one or more predictors. When you are going to use one predictor, that is called as simple linear regression. When you are going to use more than one predictor, then that is called as multiple linear regression. There is nothing called rocket science while doing the coding, but only thing that you have to follow, which variable should be considered while doing that linear model. The code which is required for the throughout the session is only this one. Okay, this is a simple code. Systolic blood pressure is your outcome. I want to check that systolic blood pressure is a causal factor for hypertension, and I have associated only diastolic variable. Okay, then in that case the data is nfhs, the same data which I have incorporated. The as you have already used the command summary, which is usually giving the summary of the mean, first quantile, third quantile, median, and minimum value and maximum value. That is called 5-point summary. Usually it provides the same summary command. If you use for your regression model, then that will lock, this will provide you this output. LM is, if you look after the quotes, LM is linear model. Okay, when we are going to use for the logistic, you can see that is the command will be GLM, generalized linear model, the same thing. So nothing will be should worry. You have to do only one thing. I have provided the data, you just feed to your data, just copy and push these codes, that will automatically run. Some of the places where they will ask for the packages, I have given you the package code. You just install that package, that will do your work easy, and you can replicate for your own purpose also. Here I am not going to talk about how to fit a regression model. I am going to talk about how to check the fitting is appropriate for the regression model. These are the basic steps which a scholar or the residents which I have seen throughout my career is that they are usually either unaware or misleading about their interpretation, and their conclusion is never be helpful because they have not replicated such steps. I am going to introduce you what are the steps once you to follow before declaring an equation as a model. So let's start with a simple example. What I did, I have seen that the systolic blood pressure and diastolic blood pressure are highly correlated with zero point 0.8 measure. I did that relation. What is the relationship between systolic blood pressure and diastolic blood pressure? Let's check. I did that one simple example. Outcome variable is systolic blood pressure and predictor variable is diastolic blood pressure. Okay, then you just check. ALM formula is there. Formula is this one. This is the function y is equal to a plus bx plus data. You can say intercept. Can you see? That is the, just check here. Intercept I have talked about here. Intercept b, a times x predictor. Here predictor is diastolic blood pressure and this is your a. that you have to multiply, and intercept is b, which is mentioned. It's associated standard error. And usually while doing your interpretation, have a focus on PR mode of t, that is called as p value. If that is significant, then the first question is, are significant at which level? Then the R is also providing. If that is 3 star, means closer to less than 0.01. If that is 2 star, means, sorry, it is less than 0.01. If it is closer to 0.01, then that is called as triple star. If it's double star, that is 0.01. If it is 0.05, then that is single star. If it is 10%, then that is dot. And that is, if it is blank, means no significant. How many stars we can see? There are three significant, three stars. Then what we can say? Diastolic blood pressure is significantly associated with systolic blood pressure at a marginal level of 1 in 1,000 times, 1 by 1,000. There will be one cases where that probability is not defined properly, and out of 999 times, that will be covering the same relationship with the diastolic blood pressure. Then what we can think ideally? If I know the diastolic blood pressure, multiply with 1.18 and add 22, then we are going to get that value of systolic blood pressure. Some of the important thing one can think about that one. The first thing is the multiple R square. Can you see 0.65? It says that why that is required, even though we are getting that diastolic blood pressure is significantly associated with systolic, but the important concern is that our model is only capturing only 65% of the data, means remaining 35 remain unexplained, even though the model performance is satisfactory. So being a scholar, be careful whether my model have the good capacity to explain the data, or some subgroup analysis, or some model refinement is required, some transformation is required, multiple things which we can take care to improvise our R square to go above 75 or 80%. Okay, so be careful, even though everything is looking good, but the model is capturing only 65%. That is not acceptable when you are going to talk about the healthcare. Okay, now as you have seen, the intercept value is 22.25 and diastolic blood pressure is 1.187. Is my slide visible? This is a subset of the database. If you look after that one, serial number 1 and 2, household ID, this one, residence type, wealth index 4 means that is uh, rich and richest group, gender 2 means female, 1 means male, systolic is this one, diastolic this one. We are using systolic and diastolic. Let's use that equation to interpret that result. What it says, diastolic is dbp is 87. I have the 87 value, that is called x. Y is equal to ax plus b. 87 is multiplied, if you round up that 1.187, then it's become 1.19, plus 22.3, then it's become 126. But if you look after the patient number 2, then its diastolic systolic blood pressure is 127.3. Can anyone say is that matching or not? Hello, can we say 126 is closer to 127.3? Hello, participants.
Yes, sir.
Okay. Is that closer? Okay. Now, when we are going to use that word closer, for that closer already Dr. Arpita has explained. There are two kind of closures. First is called, that is called clinical closure, which you can say 127 and 126 is not a major change. But when you are going to talk with the statistician, then you will say your discretion is not always acceptable. Many times those which is looking closer is not exactly closer. Then in that case, what we can see, that is called residual. Even though we fitted the model perfectly, everything is looking good, because I have said that only 65% of the data is captured through that model. That's why 1.3 is there. All the story started from residual. That residual is called as error. When that is exactly matching your systolic with diastolic, then it's become a linear function. Since this linear function has some error, that's why that is called as linear regression. The only thing that is different from the linear function, which we have studied during our school days and which we are studying even higher studies, the only rate of change is called residual, that is called error. Because of that, controlling that error, the entire session was planned. Okay. Now, let's start with what are the assumptions. I did that regression directly. Is that correct? Never. It was never be the correct method. There is some sort of strategies that one should follow before declaring any model as the outcome model. What are the steps we should follow? First, since this is a linear regression model, you should start your exploration. Is that variable linearly associated? Okay, just look after that plots which I have given to you. If y and x are the two variables, then the linear should be in that way. One is increasing, another is increasing, and the distance from the line which we have plotted through the plot should be uniformly capturing the each and every observation. But when your plot is like another type and the data is sparse, then in that case, if you are going to fit your model in our situations also, you are going to mislead the interpretation, as well as your findings will never be reliable. Okay. And one more thing, the linearity says that will also say what is the proportional change observed in y with the change in x. Means we can also quantify a 1 unit increase in the value of that particular value x, what is the quantum of change which we can observe in value of y. Okay. If you just check 1.19, that is a positively correlated. Means if you increase your systolic blood pressure, diastolic blood pressure by 1 unit, then 1.1 unit times increment will occur in the diastolic. If this is negative, then what will say 1.1 unit decline in the systolic or systolic blood pressure value, because the direction, even though the strength is same, because of the change in the direction, the correlation will change, move to the negative way. Okay. Then how to check that linearity? The first thing is that we can do the linearly plot using two way. That is called, you do the x-axis and y-axis plot using the scatter. If you have already attended that scattering plot session, then you can do that one. But what will happen if we have more than two variables? It's not that easy task to do. So let's see. The linearity says that as a residual is clear to everyone, that is called original value. Let me go through that one. That is very much necessary. Residual means original value minus predicted values. Okay, that is called residual. Then when a residual versus fitted plot, residual means error versus fitted value, the values which we have calculated over the different sample size. If that is in that fashion, then that is called as linear relationship. The only thing that we should measure is that the residual plot will show no fitted pattern. If there is any pattern in the data that is very sparse, then what we can say, that is that is not linearly related. So that is linearly related because there is no association among one variable with another variable. Okay. And the red line, if that, can you see that 1 0 is there? More the closer the red line towards the zero, more is closer to the linearity, and more the diversion from the zero, that is your the model is not going to linear. That may be non-linear, curve linear, or maybe anything else, but this is not, that is significantly deviated from the linearity assumption. That is a very simple. I just wanted to do that one. How the data will look like? Just check. This is our database. Can anyone say is there is any pattern or not? There is no pattern. The data is, even though that is looking accumulated, but that is very sparse. The command which you can do, we have fitted the model, plot model with the same model lm, where systolic blood pressure follows diastolic and data is nfhs. Then you just add that command, plot model comma 1. The first model output is about the linearity. That should be properly made. What we can say, there is no pattern in the residual plot and red line is closer to 0. Okay, if we just check the red line, that is closer to 0, that is not that much significantly deviated, then what we can say, the variable and outcome is linearly associated. Okay. And we have also checked the same thing in the correlation. The correlation says that that is pointed, means the variable is perfectly, means significantly and perfectly associated with one another. Okay. Then what we can say, the systolic and diastolic variables, systolic is influenced with the diastolic, and similarly diastolic is influenced with the systolic blood pressure. That first assumption has been checked, means the linearity relationship is will make some sense to those who want to use. Now That is called homoscedasticity. What is called homoscedasticity? That is a simple. What is that? Residual we have already discussed. The difference between observed and predicted values should have a constant variance. Constant variance means what? Means each and every unit that has been participated within that data collection is of the same or closer to in terms of variability. If they are diverse, say you are traveling in a train, that is a trend where you are going to collect the income of the individual in the general group, in the first class AC, in the second class AC, in third class AC. Then it's saying that the variability in the income is almost same, is not acceptable. But when you are going through the local train, then you can say the most of the individual will belong to the same economical group. That is the difference. That when we are going to talk about the homoscedasticity, the regression is possible when your variability is in explanation form and is uniform. That is more or less should be closer. The second assumption, we should check whether the variability has been properly managed or not. Then it should be a constant variance across all level of independent variables. Whatever the independent variables you have considered, the variation is almost same. If you just check the second line, if this is linear, you can check the each of the dot and the line has a similar distance. Okay, but when you are going to take the another plot, then you can say the distance from the last unit and the first unit is not same. Then what we can say, the variance among all the units lower to the points is not same as the values which is far away from the point of the line of the pit. That should be assessed, but that is not easy to assess through hand job. We have to take the help of the art. How to do that one? If you just check that one, how you can check spread versus location plot. I think, okay, spread location, spread means how dispersed the data is in terms of plot, whether that is uniformly spaced or not. Just check. When the data has been plotted, you can check the number of points above that line and number of points below the line is almost same. Okay, then we can say the data is homoscedastic. So let's check how the data will look like in our case. Can you see the red line which has been depicted here is the number of points which is above the dot and below, sorry, above the red line and below the red line is same. Then what we can say means more or less the variability is equally captured. Okay, then what we can say, the our database which we have considered is linear and homoscedastic. Okay, that is a way through which, how to do that one. The command is very easy. Same plot, then model, which the model which we have prepared, and just add comma 3. 3 denotes the spread location plot. You can see it is also mentioned on the top of that slide. Okay, that is there. That is also available in there. You have not to worry about that one. Now, another way to do assess that one, whether I what I am concluding is that acceptable. So let's check. Whatever we are concluding is based on a single plot. If you have heard about a story, there is a book called Lies, Damned Lies and Statistics, where it is specifically mentioned that one, when we are going to plot something and our axis were managed by the researcher, then many times the under reporting or over reporting is very obvious. In that context, it's better to work with a model or a measure which is bias free. How to do that one? Then in that case, they say that okay, not to go with the subjective reporting as we did, that you just plot using the skill location plot to check that one visibly and you conclude it. It's better you define some sort of measure, whether whatever you are saying and data is showing is matching or not. Then there is a measure called basis pagan test, which is for the non-constant error variance. It says that there is a homogeneity if your null hypothesis got accepted. Null hypothesis about the homogeneity and alternative hypothesis about the heterogeneity. Okay, just check what is it. The package which is required to do that one is called library. You use install the car package, and the name of the test is ncb. That is called ncb test. That is a non-constant variance test. That's why the name is N for non, C for constant, P for variance, T for test. And you just do that command for model only. If your, as we all know that if your p value is less than 0.05, then the null hypothesis get rejected, And if your p-value is more than 0.05, then our null hypothesis got accepted. Our null hypothesis assume that that is a homogeneous variance. But p-value is 10 to power minus 16. It says that the data is not homoscedastic. It's a heteroscedastic database. Means the data is, even though that is looking pictorially, that is uniform variance, is not exactly a uniform variance distributed data. Then that will strengthen your capacity, and you can conclude the data is it's not homoscedastic, it's heteroscedastic. Therefore, whatever we have concluded and the model performance was 0.65, one of the reason is that there is a significant variability among the database. Okay, why that is there? Some of the patient is hypertensive and taking the medicine. There is systolic blood pressure is even though controlled, but they are not free from another measure. Some of the patient were taking medicine and they are hypertensive. It may be the situation I just run away from somewhere and I just participated in the survey. That is a significant elevation in the systolic blood pressure because of my own, say, curiosity. One more problem is there if that was done by the doctor, which is known as white collar disorder. I am sitting in front of a doctor who is assessing me, my blood pressure increases significantly. That many things is there that is possible in the database. That's why that is saying there is a heteroscedasticity, and the researchers should manage it properly or can go for the subgroup analysis where that homogeneity will define properly. Now, then the data, this is a linear model. In the case of linear model, we, as you have heard about that, your parametric and a non-parametric test. If your data is normal, then all the parametric tests are possible. When the data is non-normal, then you have to opt with the non-parametric, even though that is not standardized, but we have to take help of that non-parametric test. Similarly, while doing the regression model, you have to check whether my data is following normal distribution, yes or no. Then who should follow the normal? It should not be followed by the observation, it should be followed by the residuals, means observed value minus predicted value. That database that has been prepared should follow a normal distribution. Why it is required? It's not possible to check the linearity for each and every variable. Then better to talk with the regression model, which residuals, that is accumulation of all the predictors in case of multiple regression, to check how the data in case of check that one. If that is there, that is a normal base set curve. If this is a non-normal distribution, that this is a bimodal, some sort of curve linear, that is some leptocartic, mesocartic, different shapes will be there in the data. Then how to check the normality of the residual? Command is again very simple. Just put plot model comma 2. 2 denotes the QQ plot. What is called quantile plot? Means the amount of observation which you have, and with the same range of normality, if it is lie within that one, that will closer to single line. Okay. Then if it is called concordance with the normal assumption, the more it is deviated from normality, more your data becomes a non-normal distribution. If we just check, that is called. For the normality probability plot, we have to check that whether the our observed data and the residuals are following in a straight line. So let's check how the plot will look like in our case. Oh, it has been done. This is our database. Then what we have seen, is this a straight line? In this plot, all points don't fall approximately to the same reference line, so we can assume the data is not normal. Then we got the failure. At which state? First, linearity was more or less existing, but that is homoscedasticity was violated. Then in that case, proper management is required. Similarly, the data in the raw form is not going to follow any normality assumption. Then in that case, we should also check how the data can be normal, or is it truly a normal, or some other distribution will be more appropriate to model that variable. Again, that is the that plot is again is a subjective one. So let's check is there is any measure to do that exercise. There is a measure whose name is called Shapiro-Wilk normality test. That test is only made for the normality. That one limitation is there, that is called as a large sample theory assumption. What it says, if your data is above 3 but below 5,000, then that command will be helpful. If your data set is above 5,000, then in that case that test is not going to execute in R. Okay, what I did, I just reduces the database to check whether really the database is normal or not. as I have told, the null hypothesis is assuming the residual is following normal. Okay, in the ideal situation, I want to assume the good part of the study, it is saying that is normal. But the p-value is again is a conflicting one. It says that it's less than 0.05. Then the null hypothesis got rejected. Null hypothesis got rejected. It's normal. Means the data is significantly non-normally distributed. even though even though you learn your regression model, that is not acceptable to interpret based on the results which you have obtained through your linear regression. Okay, so be careful. These are the very simple commands. What is required for that one? That library mass is there. That is a by default library which is available in your R by default, and you have to do that simple exercise. What is called STDU, standard deviation. STDU RES means standardized studentized residual that is called model. Then in that case, Sapiro that test is going to help you to get that result. That's just single these two lines. You just copy and paste. You can check whether your model is in the acceptable mode or not. Why I am giving this one? Usually, when you are a scholar and or a researcher who has crunch of the database, then in that case you can cross check whether my data is in the form of linear regression model or not. No, we have started with that one. Whether the data is independent. Independent doesn't mean that I am independent. It's mean that the data that you have captured in the residual is not influencing one another. Okay, if my data is also incorporated multiple number of times, that is many times is called as repeated measures. Okay, one time, then two time, then three times you followed me, or you collected my data by multiple is say surveyor, then in that case you have to check whether the residuals are correlated or not. In the ideal situation, the variation in the systolic blood pressure which observed in me should not match with the others, even though that is matching, but should not be related with one another. Okay, in order to test whether the observation were taken independently or not in terms of error, then you have to do the same thing. How to do that one? We have to check whether there is an influence on the error pattern as compared to the observation which we have obtained. How to do that one? That is termed as auto correlation. Auto means the correlation among the same column, that is the residual column. Why that is necessary? Difference between 10, 20 and 10 is 10. Difference between 50 and 40 is also 10, but they are not the same measures. The residual talks about that one. If your say some of the weight of an children is 20 kg, but your model is saying 10 kg, the difference is 10. An individual is also there whose weight is 50 kg originally, but your model is saying 40 kg. Even though the distance is 10, the residual says that these are two different individuals, not same individual. If there is an association among themselves, then that is called as autocorrelation. Our purpose is that our data should not be autocorrelated. How to do that? There is a test whose name is called Durbin-Watson test for the regression autocorrelation. You just copy and paste that code, nothing to worry about. That is by default integrated with the linear model. Okay, that its name is called Durbin-Watson test. Then what it says? See, check that p-value is 0. 0 is significantly different from the lower than that of 0.05. Then so the data are autocorrelated. The null hypothesis was the data was, or the residual was not autocorrelated, but our database has a significant autocorrelation. I mean, even though we have fitted the model, everything was looking good, but is also affected due to the autocorrelation. Okay, now that is called multicollinearity. What is called multicollinearity? Multicollinearity is similar. We have talked about the residuals. Now we are going to talk about the independent vectors. Some of the times it happens that you have collected the variable which are associated, like that one. I have used weight, and by using height and weight, I can also calculate body mass index. That is called BMI. If these two variables are within the same model, then one influence of weight will be there, and indirect influence of weight will also be there in terms of BMI. BMI is nothing but height by weight square. Okay, the same thing is saying if the predictor is something like that, x1 plus x2 is there, and x1 is following x2, then x1 plus x2 is a variable, and x1 and x2 are also associated. they are adding some sort of bias within that model. Then the purpose should be that we should not consider any kind of variable which are associative among one another, because having one, it is something like an invitation to your family. If I invited the guardian of the family, indirectly everyone got invited. But when I am going to invite an individual of a family, say friend or say colleague, anyone, then in that case that particular person is got associated. So be careful when I am going to invite the parents. Okay, then the entire family will be there. That is called multicollinearity. When I am going to invite only a single person, then in that case that is not a multicollinearity, that is a single variable. So our purpose is also to test that when we have more than two variables within the model and they can be associated among one another, independent variables, then how to check? The first thing is called correlation. Nothing to worry, which we have studied about. Just check those variables which are highly correlated. Just ignore if it is making the same sense. In that case, why it is a sensible thing and require the discussion with the experts. When you are working with a health model or in the associated models in the social science, many variables are seems to be correlated, but they are independent variables. Okay, then if that is making a different sense of understanding, no need to exclude, keep it within the model. That is a discretion of the researcher and the subject experts. When that is making the same thing, like I have told, weight and body mass index is using the same weight variable, then you should consider those who have more weight. Either you can consider weight or you can consider body mass index. That is another thing which you can consider. The first thing to check the multicollinearity is that you start with a simple command, which is called correlation matrix, which I did that one. Core and the same NFHS data, I did repeated the same correlation variable. We can check. We are satisfied with systolic diastolic, and then none of the variable is showing. Okay, that is 6.28 is 10 to power minus 5, means 0.000. After 4 zero, there is a 6, that is almost equals to 0. Okay, don't get confused with the value. Also check e to the power minus 5 is there. E means 10 to power minus 5. Okay, can anyone see any kind of variable which is making some sense? None of the variable is there whose values is closer to 1 or minus 1. Then what we can say, that variables are independent. Okay, okay, even though we did all these things, what are the steps which you have replicated? Just give a recall. First linearity check, then what we did, let's just recall. First linearity check, then we go for the homoscedasticity where they are linearly related, whether the variability among each and every observation with the line of fit should be closer or not. Then we check whether the data means the residual, overall the residual is following normality, yes and no. Then we have also checked whether the error variable or the residuals are associated among one another. If it is so, then we should restrict. If it is not, then we can proceed one step ahead. We should also check whether the variable, independent variable that has considered within the assessment are interrelated or not. That is called multicollinearity. Then what we did, we checked y, we checked x, we checked error. After all this checking, after checking all these 5 steps, then and only we can say the data is in mode of modeling. It is something like a process of baby formation. Once a baby born, the process completed. Only thing matters is care and its growth. Preparation of a model is the ultimate objective of any study. Once you formulated your model, then in that case everything is stuck there, and you have to work with your projection, prediction, and the association. You should not go through the mean variance again. You are going to more into the reliability and utility of that model in a practical scenario. But one thing that we should always consider, we have started everything with the entire modeling, but many times some of the important concern we forgot to address is called as data cleaning. What is called? First is called outlier. What is called outlier? Some of the extreme values that is not possible to explain but exist within the data, or some of the values which was wrongly mentioned within the database and is not practically acceptable. Let's start with that one. A person whose age is 150 years, can anyone imagine how 115 years individuals come to you and participated in your blood pressure measurement? that is not practically acceptable. In that case, that is called as extreme outcome variables. Sometimes that happens also. If someone has an heart attack while doing your data collection, his systolic blood pressure will walk around 250, which is not a usual one. But if you can explain that event is also possible in a routine life, that is also acceptable, it's not outlier. Those who are into the health research, be careful, there is nothing called outlier. If your data collection is correct, typo error was managed, misreporting was perfectly managed, and your team is skilled and trained, then in that case, nothing called outlier. You should go with the different subgroups where these observations are executing. But when some of the observation were like that one, I am traveling in a train, there is a billionaire, you can't ignore that one. That is an outlier which will destroy the entire integrity of the income level of the passengers. That is called as outlier, which is not possible to manage. But those conditions which is manageable, explainable, don't treat this as an outlier. The question is how to check that with there is an outlier in our database or not. Okay, what is called as we have to standardize the residuals. What is called standardization of residual? Standardization of residual is nothing but residual divided by standard error. Okay, the standard error was there. Let me go. Can you see residual standardized error 8.623? This is called a residual standardized error. Based on the residual values, you just divide that one, then you can get a residual standardized error. Then there is a term called leverage points. What is called leverage points? Statistics above 2 within bracket p plus 1 by n. N is the number of observation and p is the number of predictors, means independent variable that you have used to model your outcome. Say there are 3 variables within the model, then the leverage point should be 2, and out of 5,000 individuals has been surveyed, 2 within bracket 3 plus 1 divided by 5,000. That should be the leverage point. And where then how to check that one? The command is very simple. Just plot model comma 5. Okay. Fifth model is that one. This is the outcome. In the plot, if you just check, is my screen visible? There are 3 points. How there are 3 points: 2873, 3874, and 6034. Those values that will be seems to be the in the observation number. This is the basically an observation number. These are the 3 observations whose values was not captured properly within the model. That is called as outlier. What is our first purpose? Go there within the observation and check what outcome is reporting. Is there is any problem we have wrongly entered the database? Is there any specific case which is not a part of a study got involved within that study? Or is there is any case that this is possible but their inclusion will destroy the integrity of the data? The first thing is that using that model you can check is there is an outlier or not. If there is outlier free, then in that case you should be happy enough and can execute your results, which is generalizability is also possible. Okay, then how the software is doing that outlier cutoff? It says that within the interval of the straight line, that is the fitted line, with the 3 standardized deviation, how many observations are there which is beyond that one, which is many a times if you are working with the quality control, it is called as quality width, or that is called as control limit and lower control limit. That is a 3SD. Those who are above or below the control limit will be considered as an outlier, which is not possible to explain out of the 95% of times by using this observation. Okay. Another thing is called influential variable. Some of the variables are like that whose presence or absence can change the direction of the analysis. That is called as influential variable. Then in that case, you should also check, is that like this one? These are the 3 variables which are treated as outlier. What will happen if we remove that outlier from the model? Is this going to make some change? Why? If you just check, that is called Cook's distance. Okay, you can see that Cook's distance here. Then the formula is there. There is a Cook's distance. What is it? 4 divided by n minus number of observation. P means number of predictors minus 1. That is a cutoff. Using that one, the software is going to assess is there is any outlier or in removing that outlier, and what will the influence on the model. That is called influential distance. Just check these 3 points that we have included. It is going to say, as compared to the distance with the standardized line, these three variables have provided the highest peak. If we just remove that one, that will be more or less closer to comes to downward. Okay, that is called as Cook's distance. Then before going for the modeling, we should also be careful, is there is any outlier, is this truly an outlier or is an influential variable. If it is influential, then manage it properly. If it is outlier, just drop it from the data and mention in your study that some of the observation was not acceptable because of this reason, therefore we are not considering this observation for our final model evaluation, because that is not going to be observed in a usual practice. Okay, now what will happen, as we have seen that one, that linearity, homoscedasticity, thereafter autocorrelation, then normality, then multicollinearity, outlier and influence variables. After managing everything at any stage of the time, if you are going to be violated, like I have provided the data in usual session, people always want to fascinate. See, I have a database, you just execute this code, these beautiful fits you are going to see in the real life situation. If you are going to run a model using your variable or the database, 99% of times you are going to stuck with any one of the observation. Once you are going to overcome with this obstacle, then your model will the best model with the highest performance and highest predictability. So the task is not to use R, the task is to utilize R, so that your results and findings can be replicable and can help others also to get motivated and to cross check the composition of the relationship. So what will happen? When the linearity assumption was violated, then it is called as non-linearity. The model system and the method of analysis will be different. Okay. Similarly, you have a separate code and setups that needs an additional exploration to do. When there is a homoscedasticity, the model will work perfectly fit and easy to explain. When there is an heteroscedasticity, you have to go with the adjustment of the error by using homogeneous group classification, or many times it is also known as stratification or subgroup analysis. When there is an influential variation present in the database, check, is this a outlier or it is a high leverage values, means that will improvise your predictability situation. So so be careful every time while doing the regression model. We are not always into or to can satisfy everyone. I build a model, whether I cross check all the criteria which is required to define whether the model is perfect or explaining the content of the data, yes and no. So each and every test is sensible. It's not that tough. Only that you have to add your data, run the model, and you can cross check whether I am in the safe hand or not, or any modification is required or not, whether any cleaning or any kind of variable transformation is required or not. For that, you can take help of any of your statistical say collaborators, and you can also ask, I have obtained that particular situation while doing the model, could you please guide me? That will be, it is something like nowadays a medication procedure was introduced, is known as personalized medicine. What you thought of about a situation is another concern. Is that situation is suitable for me or not, that is another concern. Similarly, when you have your queries clear about the model performance, then all the statistician or the methodologists who are working with you as a subject experts will help you in a better way, so that your effort and your data collection methods, data understanding methods, and the message you want to convey will be more reliable and realistic. So be careful about all these systems. Okay, with that, I am just closing my linear regression session. Anyone has any query in any of the content, feel free to ask. Then I will go with the logistic regression. Anyone has any queries or doubts? Hello?
No, sir.
No. Okay. Is the steps clear? Or anyone has any doubt about the execution of steps or any procedures, then feel free. See, all the PPTs database is with you. Just add your database. You just copy paste those codes that will run automatically. If anyone has any queries while execution of the things, you can contact the person nearby, or you can contact to my email ID. Feel free. You can learn by doing all these practical exercises. Okay. Now we are going to shift to the logistic regression. Okay. Now, logistically, as I have told that when your outcome variable is categorical, maybe the ordinal or a nominal. I am going to talk about not going to talk about the ordinal one. I am going to talk about the nominal one. Nominal variables are those variables. This is a category, but there is no ordering among themselves, like gender, color. Okay, but when there is an ordering, that the method of analysis will be different. I am not going to touch that one. It's better to start with a normal flavor, and you just check the utilities. You will understood in different way. In the regression analysis, I talk about the hurdles one should think about. Here I am going to talk about how the predictability, as I have told that prediction is doing well. In order to predict something, you must have some sense of understanding. How to get that understanding? Either through the experience, or through the from the experience of other, or you have obtained that knowledge so that you achieve to that limit, you can predict something. But when you are working with the system will run from available information and will generate the evidence for the new or upcoming informations. Let's explore in that way. I am going to utilize the logistic regression to formulate it as a predictive model. As I have discussed, the logistic is the same formula I have depicted. That the only thing is that our predictor or outcome variable is a categorical one. Usually that is binary. Okay, maybe the multiple level also, that is called, when you have a multiple levels, the method of analysis will be same, but the interpretation will change slightly. But for the simple learning and for the practice, it's better to start with a dichotomous variable. Okay, the formula say you can say sine of t means the outcome of t, that is 1 by 1 plus e to the power minus z. That is a simple sigmoid curve. If it is look like that is a S-shaped curve. Then the types of logistic. The logistic can be of three types. What is called? First is called binomial. Bi means, as you have heard about that one, bi means two. When there are two variables which are categorical variable, then that is called binary logistic regression. When you have more than two categories, but they are not ordered, then that is called multinomial logistic regression. Multinomial and multivariate logistic regression is different. Multinomial means when the variable has multiple labels, that is called multinomial. When the variable is dichotomous but have multiple variable as an independent variable, that is called multivariate logistic regression. Okay, then another method of regression is called ordinal logistic regression. When you have multiple categories, two or more than two, but they are ordered, like a situation of a patient, mild, moderate, and severe. You can also add as a normal one. The similarly, if you have a Likert scale, okay, none, mild, moderate, and severe, then that is also possible using the ordinal logistic regression. We are going to confound our understanding to the binary logistic regression with the multiple variables. That is called multivariate logistic regression. Okay, let's see how it works. Similarly, as we have studied, when you are going to model or confirm that model is applicable and will be replicable, have to check of some of the assumptions. What is that? First, independent observation. Independent observation means you have to check the autocollinearity, the same code which I have provided to you. Binary dependent variable, check that whether the database is considered as only two outcomes, 0, 1, yes, no, whatever it is, but should not be ordered. Second thing. Third thing, you have to also check the linearity among the variables. Transform the variable into log p by 1 minus p, and the independence we have checked. That one using the code can be done. Outlier will be done using the same command. You just run the codes, give the plot command, you can check outlier. After getting all these things, then you can say this model is going to be considered as the standard model for evaluation. Here I am not going to execute this assumption. I am going to use my model under the assumption that that model is final. Say the first thing is that I have to import the data. The database which I have provided you is called Birmingham Heart Study. If any one of you is associated with health related studies or the clinician, you are very much familiar with the Birmingham. Now it is a course curriculum while doing the cohort study. Why that study is important? This is the first study of its kind whose fifth generation participants are fifth generation individuals are also the participant. Now, because of that study that is started with a very small sample group of 100, 500 or 600 individuals, now up to the sixth generation individual is also following them. That is the biggest database in the cardiological exploration, where the database has been preserved, and what is the change which we have observed over the course of time in terms of genomics, in terms of health, in terms of change in the lifestyle. Everything was procured. Okay, what they have provided some of the things. After the incorporate, the database is also shared with you for the exploration and practice. What I did first, I started with the summary command. Summary, as you have already practiced, summary is divided into the six, that is 6 point summary, that is called minimum, first quantile, median, mean, third quantile, and maximum. Okay, the variables that has been considered within the database is called gender. 0 means female, 1 means male. Okay, age, education are different categories. Current smoker, 0 means non-smoker, 1 means currently smoker. If you are a smoker, then there is a question: cigarette per day, how many cigarettes you are consuming per day. That is behind you the quantum of burden in terms of regulation of the risk factors. Are you taking any BP medicines? That is about the management of the hypertension. Prevalence of stroke, how many individuals are there who has experiences stroke. 0 means no stroke, 1 means stroke. Here mean means around out of 1,005 individuals experiences stroke. Prevalence of hypertension is one third of the total population, 1314, 34%, like that. How many of them are diabetic? How many of them has total cholesterol, means what is the range of that one? Systolic blood pressure, diastolic blood pressure, body mass index, heart rate, glucose level, and 10 years CHD means coronary heart disease. Is there is any heart related incidences or history associated with you in the last 10 years? These are some of the variables that is available with you. You can explore any variable, can model and practice. The number of rows, the rows define the number of observation which we the database has considered is 4240. Okay, and these are the names of the variable. You can check what are the names associated with the variables. That will help you to pick the variable for the modeling. So let's start with the model. First, we start with the bivariate one. Bivariate means what is the association? Our outcome is the prevalence of hypertension. Why? That is a manageable disease. If you are on proper medication and has some sort of understanding about its management, you can reduce the burden of stroke, heart attack, say kidney infection. Many things can be managed through that. Then what I did? First, you can use the 2 by 2 table. What is the purpose of that 2 by 2 table? X tab is the command. It doesn't require any package. That is easily available and you can use directly. Education is a one variable that we want to explore, and prevalence type is whether the person has the hypertension prevalence, yes or no. Just check. Prevalence 0 means no hypertensive. Prevalence 1 means hypertensive. Education has four categories. That is called no education. That is called primary, secondary, and above secondary. These are the four categories. When we are going to talk about the, as I have told you, that is one of the assumption that your outcome variable should be categorical. How to do that one? It's better to make that variable categorical, because 0 or 1 can be treated as a numeric values also. Then how to do that one? Then you just copy and paste this command, st, better not to use that st, you can use that prevalence hypertension. That is for the notation I have used. Factor defined that the variable will be treated as a characteristic, not as a numeric. Okay, the same thing. STT dollar define that column, fixing that which column we want to study. That is the where that hypertension was preserved. Similarly, wealth is also a category, you can use that one. Similarly, for the gender is a category, you can use that one as a gender. That will help the R code to understand these are not the numerical values, but basically these are the characteristic values. Okay, that will also help you not to get affected because of that characteristic of the variables as a treated as a continuous one. Now the what okay, what I want to do, I just wanted to build a model which is predictive. Then in that case, when I, as I told you, if you want to do the prediction, you have to train your system so that they can check. Usually this is not a course of standard learning. Basically what I am going to demonstrate, which is fascinately known as machine learning. Okay, that is an added flavor, and you can practice everywhere, and that will also help your study to be more relevant and effective. Let's see how it works. First, split the data into 70/30. What is called 70? Means your 70% of the observation will be used for the training, means your software will learn from that one, and 30% will be used for the assessment of the data. Whatever you have obtained really making sense for this 30%. If it is good, then you will accept your model is doing perfectly fine and have higher acceptability. If it is not capturing that 30%, you should say the data is not properly managed or the model is not working satisfactorily. Okay, then what I do, there is a simple command, as you have heard, that is called sample. Sample is nothing but is a sample command, is a random selection of the sample from a database. Okay, what I did, I said that see true and false. True means what, that some of the observation who will be treated as yes category, some will be treated as no category. Number of rows, that is 4 to, what is that, number of rows where 4 to 40. Okay, out of 4 to 40, you just split some of the values in the two categories, some of the values in the first category, in a proportion of 70 and 30. Okay, this is for your knowledge. If you just describe 4 to 40 into 70%, that's become 2956, and the number of individual that is for the evaluation after the modeling is 1214. Okay, that is the summary. That will help, means I have split the data into two halves. That is for the training of the data, that is called machine learning. This is through which the machine is learning. Okay, and another 30% for the evaluation of the model, whether that is really acceptable and can be generalized or not. Now the model, let's start with the model. Okay, I did that, whatever the basic analysis association that you have already heard about, the chi-square test, etc., you completed. Now I am more into the model. Simple, just check. I have used the word LM in the linear model. Here I am using the word GLM, that is called as generalized linear model. They are not linear by itself. That will formulated in such a way that they becomes the linear one. That is called pseudo linear models. That's why that is called as generalized linear models. How it is said? That is called, now prepare your model. I just check one thing. That time I have used the whole database, but here I am using the subset of the database, not the whole database. Since the data is binary, it's better to define the family as a binomial. Okay, and as I have told you, some of the variables are categorical, some of the variable are continuous. For the safety one, I have just wanted to calculate the prevalence of hypertension, which is yes or no, whether you are hypertensive or not. That is a simple category, can be influenced with the level of education and the current smoking status. What you say? If your education is good enough, is that going to influence the hypertension or not? Then the people have their own interpretation. If I am illiterate or less educated, then I am not going to take care of my health. Wherever I will get the food, I will take the food. I am not going to maintain my care of the routine checkup, etc. But on the contrary, when you are highly educated, you have your work burden, stress, anxiety, multiple officials meeting, etc., etc., poorly managed your daily schedule. Then it's saying that one variable is the most prominent one is very subjective. It's better to use the tools of modeling. As we can see, if you are smoking more, then chances of hypertensive becomes towards the higher side. Then what the model is saying, as I have told you, the significant model is saying that 3 star, 2 star, 3 star, 2 star means all of the categories. That is the beauty of that one, is considered as that. See, here 2, 3, 4 is there. Where is one? As compared to one, what is the change in the prevalence among the category 2, among category 3, among category 4? What is the change with the respect of 0 non-smoker with the smoker? That is there. Okay, that is all about the button. What we have seen, simple linear regression model is saying that all the groups which we have considered is significant. Okay, okay, then let's see. This is the model has been prepared. We should not worry about it. Our purpose is that really that model is effective enough or is just a myth. Let's check how it will be done. So some of the characteristic which you can store and can present in your table is that first calculate the confidence interval. Why that confidence interval? I will let you know. The command is very simple. CONFINT. CONF is confidence. INT means interval. The name of my model is my logic. Okay, that is a logic model which we have considered. The form which I have presented, y is equal to 1 by 1 plus e to the power minus z, that is called as logic regression. Logistic regression is all come from the word logic. Logic is a link. I'm not going to go into the depth. That is because of that is known as a logistic regression. That confidence interval for each of the variables has been prepared. Why it is required, that will help you into the interpretation. Let me tell you why. Okay. Now, wall test. What is the purpose of the wall test? Wall test is a test which is help you to understand whether the interval is making sense or the model is replicable or not. Okay. Then the odds can be also be defined using the same thing. How to do that one? Just check the odds is a major concern which we want to look after whether it is sense or not. There is a rule. What is called that rule? Odds ratio 2.5, 97.5. If someone subtract 97.5 from 2.5, then you will get 95%. That is called as the 95% confidence interval for the odds ratio. If all the values are below 1, then we can say that is a protective factor. If all the values above 1, then that we will say told you as a risk factor. What we have tested here. Here prevalence, yes, is our outcome variable. Then what will happen? As compared to the educational category 1, if you just check all these things, all the variables are below 1. If any of the variables is like that one whose interval is above 1 and another two values are below 1, then that is called as insignificant. What it is saying here, the interpretation is different. Means the chance of having that hypertension is higher if you have all these categories. Is that clear? Here outcome variable is that you are not affected with the hypertension, then the chances will be lower down. You are not protected, you are on the higher risk. Means the chance of happening hypertension is 65% more among the intercept, and 75% is more among the two as compared to one. 66% more in education category 3 as compared to 1. 64% higher among the education group 4 as compared to 1. And similarly 62% higher chance among those who are a smoker as compared to non-smokers. Then what is our conclusion? What we should say? If you want to control the prevalence of hypertension, it's better to control your habits. First, starting from smoking. Okay, more you are educated, your occupation is in such a way that you are more into the trauma, stress or anxiety. That's why you are more towards the hypertensive characteristic. So maintain your routine life as well as your lifestyle, that is both should be properly managed. Now, up to that one, the model is there. Usually if you look after the papers, they usually talk about the logistic regression, they talk about the odds ratio, they talk about the odds ratio confidence interval and its significance. Then what we want, up to that the regression work is finished. But as I have told you, this is the training of the software or the interface which we are using. How we can cross check ourselves whatever we have formulated is making some sense, then the prediction is started. That is the very much purpose of the regression model. Does this model has the predictability? If it is so, how much it is and how beautifully it can be generalized. Then what we did, then we are going to predict the model. Then we are going to generate a database whose name is test dollar predicted probability. How to predict the probability? The probability will be predicted using that same. The command is simple. Okay, predict within bracket my logic, the same model which we have, and I have used the data. I am not, my logic was prepared using the training database, and we want to use that for the testing database. Then what we are going to say, I have prepared a model, now incorporate my database and check how the prediction is formulated for the new database which was not considered during the analysis. Okay, then what I did, then we have to also check the variables that we have considered within that one is called prevalence hypertension. Okay, and predictive probability is a probability, the level of accuracy which we can cross check through our assessment. As I have told you, the percentage of hypertension within that population which we have considered is 30%. Okay, the same thing I have used that one as a cutoff. The formula is simple. If the probability is less than 0.3, then treat it as an hypertensive. It is not, then considered as 0. That 0.3 is usually adjusted based on study to study. That for the demonstration I have fixed is 0.3. If you have the different database, keep on modifying and tuning your threshold so that you can exactly classify the database. The code is very simple, just copy and paste. That will do automatically for all the variables which you want to study. But have that focus, then in which category you want to use that one. This is basically your outcome variable. Okay. Now what I update, now I just wanted to obtain, there is a word called confusion. Don't get confused. Confusion matrix is called a matrix which says how many person or the percentage of people exactly classified hypertensive and non-hypertensive, and how many of them were just cross evaluated. Means non-hypertensive patient become hypertensive category, and hypertensive category got hypertensive. Just check. This is the actual 0 and 1 means, that is 0 means non-hypertensive, 1 means hypertensive. Out of total actual non-hypertensive, the predictive model is getting 337 as an hypertensive one. And out of hypertensive cases, 194 were found to be non-hypertensive. That is a concern. We should always take care of that, whether our model is working, even though the significant is good, odds ratio is good, but our model accuracy is not good. That's why that is called as confusion matrix. How it may become that non-hypertensive cases becomes hypertension in your model, and your hypertensive cases becomes a non-hypertensive in your model. That's why that is called as confusion matrix. Okay, then how to do that one? The command is very simple. The table command is usually made for this table. If you just execute and copy paste this command, then you can get that one. That is a classification. Then one question, then the question rise to me, how I can check how accurate I am. Just check that one. I replicated the model. The model accuracy is only 57%. Now the question is that if your model, even though everything is significant, is explaining the phenomena, is that possible to predict or replicate for the general population where your accuracy is only 57%? It is something like a dicing a situation. It may be, it might not be. Okay. Therefore, while doing or assessing your model, check how accurate I am and whether that accuracy is achieved, manageable, and explaining the phenomena in an appropriate and conducive manner. If it is not, then redo the modeling, check your assumption, there is some violation, or add those variables whose predictability is much more reliable or explaining the phenomena in a better way. Okay, why I am showing so? See, I can also provide you a database and can fit a model whose accuracy is above 87%. In the same database, some of the variables are there. But my concern is that everything looking good is not necessarily good. Many times you have to check the level of goodness also. Then how to check this one? There, one way is called RO seeker. Before going to the RO seeker, what is called, why that ROC is there? See, that is called diagnostic test. Diagnosis of what? That is called model performance, as I have told. Condition present, condition absent. Say hypertension, present or absent. Same, that is called prediction. Test present, test absent. Means predictability, some of the cases is saying is a hypertensive, some of the cases saying non-hypertensive. That is basically a 2 by 2 table, which is known as diagnostic test, or in terms of coding, it is known as a confusion matrix. How it works? The number of people with A plus B is called positive predictive values, A by A plus B. Out of the total tested population, what is the proportion of the population that were correctly assessed as a true positive? Okay. Out of the total negative is called as the negative predictive values, that is D by D means condition absent and test is also saying negative. If you just check, A and D are the true values, true positive and true negatives, or means truly hypertensive and truly non-hypertensive group. That is called as positive predictive values for the positive as well as negative cases. But there is another term which we have emphasized. A person who's originally that is hypertensive, but your test is saying non-hypertensive, that is called as sensitivity. Means true population is not captured. What is the proportion of true population that you have captured out of the total affected population? And when the population is that b d by b plus d, that is called specificity. Means number of non-diagnosed cases that you treated as a positive one. Okay, that is d by b plus d. Means what we can say, if a is true then c is false, if d is true then b is false. That wise that is called as sensitivity specificity. If you are going to build a model, okay, then it just consider a situation of covid-19. A person got that happened with, I don't know, have you heard about the covid-19 or not? The first death that happened in India due to the covid, can anyone know or have heard about? Anyone of you have heard about the first death case happened in India due to the covid, during the covid? Okay, no idea. The first death case was not reported due to the covid. That happens when the RT-PCR was not that much functional, the rapid test was effective. One of the student, that is a fellow also basically working there, he is from Australia, visited India, and the same day the lockdown was declared. The patient was placed within the Safdarjung hospital, and the rapid test was confirmed that the patient is positive. And the covid is a new and is a horrible disease. Means you can die with the breathing problem and respiratory issues. Many things were jungling up, and that individual was stand alone on the fifth floor of the Safdarjung hospital. After getting that news that the rapid test was positive and the sample was placed for the RT-PCR, which is a confirmatory test, there that was pending. It says that it will take 2 more days. And because with the traumatized situation of the patient that he is positive based on the rapid test, he attempted suicide. Okay, and after 2 days that was found that the RT-PCR was negative. You can understand how severe the situation is when a negative cases were treated as the positive one. And what will happen in a positive cases which was wrongly treated as a rapid test is saying negative, and you just return back the patient is covid positive and spreaded the whole community the covid virus. That's why our purpose is that the true cases of both sensitivity purpose and specificity purpose, that should be properly managed. There is some sort of way through which we can depict, is called as ROC curve. That is called, or also called as AUC, area under curve. Okay, then once you formulated everything, you just also check, that is a way of presentation to show that our model is performing well in terms of train data, and the test data is that. Can you see? Okay, that is, means higher the elevation of the graph, more is your accuracy. The accuracy is 52%. That's why that is 50-50%. It is closer to the diagonal. If your model is will performing well, good in predictability, has controlling the capacity of sensitivity and specificity, then in that case your model will achieve to a greater prospect and will be more replicable. So building model is not a task. The steps followed for the building is the important concern, and everyone should practice step by step. Once you got stuck, follow the remedies which to help you to overcome that situation. If it is not, change the method of analysis. If even though that is working fit and fine and is acceptable, or the parameter is tested, check whether that is replicable, predictable, and usable for the future use and not. That is another concern. Whether the model has the effective predictive probability and capturing capacity, that is also a concern of a scholar or the researcher, to get an optimum value and the reliable value before concluding that this model is the outcome of that research. Without doing all these practices, if you are placing your model in the public domain, really you are compromising with everything. Okay, one more thing is there, when you are going to take care of that, this one, this acceptable actual and predicted value, be careful what are the components which we have placed, is that making sense or not. Many times we just place the values or the variables which are not clinically or the outcome related associated. In order to improvise the model performance, we many times manage the model. Don't do such kind of practices, because it will affect, as I have told you, the example of rapid versus RT-PCR. Then many times it will be a life-threatening situation for those who are replicating this model for the public domain. And your study can be used as a marker for the other studies or the learners for a better understanding. Okay. Okay. Anyone has any kind of queries or question within that, then I will be happy to answer that. This is the last slide. To my things, everything is clear. If anyone has any doubt or want to know about any composition for their studies, or they have experiences such kind of things, then I will be happy to address all this. Say constants basically. Aruna ma'am. Hello. Aruna ma'am, am I audible? Hello. Anyone has any queries or questions? Now, this is the final slide. First of all, I would like to thank all the participants for having that patience. I know that this is not a usual conversation and presentation. Usually, people talk about the beauty of the regression, but when you are going to work with or the play with the beauty, be prepared for the beast also. These are the some of the beasts which are associated with the regression. When you are going to use and emphasize your research, have that courage to generalize, to predict and utilize the best features you have. When I have a good friend of those who are helpful, I will always take that help to emphasize and encourage my own knowledge and disseminate that knowledge for those who are the learners. That is the track which you can replicate and use. And whatever the things I have told you about the logistic regression, that is also replicable in case of linear regressions also. But have that practice. Once you started with, feel free to interact with the your institutional colleagues, seniors, or either supervisors. And if you require, you can also consult the statistician. Those who are working in that field, specifically in the machine learning, that is not a rocket science. This is the way through which machine is also learning. So don't get that traumatized that these are not made for us. This is also a part which you can encourage and can motivate others to practice these things. I hope this, I think everyone has received the material as well as the ppts. Hello.
Yes, sir. It was given to everyone in the WhatsApp group.
Okay, good. Then in that case, we should not worry about that one. The things are available and can easily manageable. Feel free. And first of all, I would like to thank all the organizers. Really, they are the good friend of mine. As many of them were my seniors. Even my supervisor is associated with that institutes. I always respect and feel homely when I get interacted with the Royal Global University. Really, that word makes some sense. That Royal in that terms of that global knowledge. I always appreciate and encourage the institutional board and the team members for their support, encouragement, and always open for the platform for knowledge and learning sharing process. Thank you, everyone. If anyone has any queries or question after the session, feel free to contact my email IDs that is available in the domain. It may be happen that I am late to reply, but you will get the reply very instantly. Feel free, and my best wishes for the all everyone for the future sessions.
Thank you so much, sir. I
Thank you.
request the participants to share their queries if they have any in the chat. Or as sir said, you can connect sir afterwards also in case of any existing doubts. Sir has already shared the material with me and I've forwarded it in the WhatsApp group. So in case of any doubt, you all are free to contact sir. So it was a very nice session, very enriching, again, very lucid, so that we are able to understand in a very easy, simple manner. So, sir, a certificate of gratitude from our side for sparing a
Thank you,
valuable
ma'am. Thank you.
time. And giving us opportunity to listen to you, learn from you. That was a really enriching session. Thank you so much, sir. We would also like to collaborate
Thank
you in the future period whenever we have any, such statistical workshop. We will surely connect you, and we hope that we will be able to gain this kind of knowledge again. Thank you so much, sir.
Thank you, ma'am. Thank you,
Thank
thank
you.
you, ma'am.
Okay. So we have come to the end of day 3. Tomorrow we have the day 4, 2 sessions again. So we'll start the session at 11. I request the participants to join beforehand. You can start joining from 10:30 onwards. The link will be open, and take the opportunity to connect to the experts and get the maximum benefit out of it. And as and when the experts will share the materials, that will be communicated to you all in the WhatsApp group. So kindly make use of that, download it, and save it for future use. Thank you so much, everyone. Thank you for being with us. A very good morning to all the participants, and a warm welcome to our speaker of the day. So before we start the session, we hand over the session to our expert speaker. I would like to give a short introduction about Sir. Professor A. Jiran Mitai is currently working as a faculty member in the Department of Mathematics, Maharaj Agrasen College, University of Delhi. He has over 25 years of teaching and research experience. Professor Mitay has published numerous papers in reputed national and international journals. His recent research focuses on the application of machine learning techniques to economic and public health data. He has also authored 3 books, including one published by Mercury Learning and Information, Virginia, US. Well, this was a very short and brief profile of Sir, but then the knowledge, the experience, the intellectual quality that Sir possesses is unmatchable, unparalleled. Now, we, the participants, the research scholars present here, the faculty members present here, we have to get the maximum knowledge in these 2 hours on the topic that Sir will deliver. And I wish that all will be enthusiastic, will interact, and you'll be able to learn the maximum out of it. In case of any questions, you are requested to put it down in the chat. Sir will take it up once the session is over. I again welcome Sir the session. Today is our day 4, and we are really enthusiastic to know, to learn about this new topic today. Thank you so much, Sir, and over to you.
Thank you so much, Aruna, for the nice introduction. I think we have how many participants now? 18, I think, to be exact, right?
So it's 19.
19.
One joined just now.
Okay. See, this is going to be your 3rd day on this art programming, right? The session started on 13th of this month, and today is 16th. So R is not going to be new to you, because most of the coding, all the coding that I'm going to run through are in R only. So the 2-hour sessions for machine learning is not the duration that wherein one can learn the machine learning from the basic to the what you call final coding. So I'll just run through some slides that I have prepared, and then I'll go to the coding sections with with a data set which I've used in the publication. I think that will be okay to you.
That will be great, Sir.
Okay, so I'll share these slides so that I can start the presentation. So everything that I'll be presenting over here, if you need, I can share it to the Aruna ma'am, and then the same thing can be passed on to the participants if anybody what you call would like to have this. So this is the PPT that I have prepared. I'll start my presentation from the past PPT. I think this is visible to all, right? Is this visible to all?
Yes, sir, it's visible. It's visible.
It's visible, yeah.
Yes, sir.
So we're going to talk about a very interesting new kind of tools, which is now becoming very popular among the researchers across the discipline. And so, I mean, it's discipline neutral. And it's the tool that we're going to talk about today is machine learning. So what is this machine learning? It's a very it's going to be a very intelligent system wherein the system is going to learn from the data pattern and to solve complex problems in various sectors, which includes the healthcare, finance, and beyond. So this is the first slide that I have. Then we go to this. Now we try to differentiate, we try to understand the difference between artificial intelligence, machine learning, and deep learning. I have a picture on the right side, which is depicting the relationship between the two. Artificial intelligence is going to be a broad term, and machine learning is a subset of that, and deep learning again is a subset of the machine learning. So what exactly is artificial intelligence? So artificial intelligence is something where the machines try to simulate the human intelligence using kind of algorithms, rules, or some learning techniques, wherein they start making decisions and solve problems. But what about this machine learning then? Machine learning is a small subset of the artificial intelligence where we use algorithm statistical modeling to identify the word statistics comes over here in the machine learning. Statistics has to be there. So to identify patterns in the data and learn automatically from that and start predicting without explicitly doing the programming all the time. So then what about this deep learning? Deep learning is again a kind of machine learning wherein you start doing the learning in multiple layers. So this easiest example of deep learnings are the neural networks. So most of my presentations is going to be on machine learning and the classifications models. So the application area as of today, some of the application area which I have collected and presented over here, and it's much beyond this. So the application is very, very what you call very hugely coming up in the medicine and healthcare sector. It also applies in a bank. It also is useful in the banking and finance. Some of the what you call points where these things are applied in these different areas are mentioned over here. Retail sector and manufacturing are some of the areas where this machine learning are hugely being used nowadays in the industry as well as in the academics also. Now then, what exactly the machine learning does? The machine learning, what we do is the machines would design some powerful technique to learn from the data that we provided to the machines and pull out some certain functions which do not have a proper mathematical formulations. So the output is going to be a function which does not have a proper mathematical formulations. And these functions will start what we call predicting for two unknown set of data. So see, in the machine learning, why this? It's a the predictive modeling, meaning what? We learn from data, then we pull out a function as an output. It's different from the regression. I have a slide where I'll be what you call differentiating the regression modeling and the machine learning modeling. And I think in that you'll be able to understand in a better way. And the primary goal is to enhance the accuracy of the predictions in the machine learning. So the difference, again, I'm repeating, between the machine learning and the regression analysis, I'll present in the latest slides that there you'll be able to see a difference more clearly. So over here, you just look over here. We input data to the machines. The machine learn from the what you call the pattern relationship, which are hidden inside the data, then pull out a function which does not have explicit mathematical formulations. So the output is always a function. So why machine learning? The precise decisions and intelligent decisions making. That's why machine learning. See, the types of machine learning that we have. There are 4 different types of machine learning that we have as of today. The first one, we call it supervised learning. In the supervised learning, what we do is we have a data set where the outputs are known. See, the outputs, for example, you want to predict whether a person is diabetic or non-diabetic. The dependent variables are kind of level. whether diabetic or non-diabetic, fraud, or genuine or fraudulent transaction or something like that. So when the data sets are level, then we go for the supervised learning. When the data sets are not level, then it's the unsupervised learning. So in the unsupervised learning, in the supervised learning, that the kind of algorithm that we use are random forest, logistic regression, support vector machines, KNN methods, distance tree, some many other boosting techniques. And even the neural network can be used in the supervised learning. So under unsupervised learning, you do not know what is the output going to be. The data are not level at all. Data are totally confused. So in such kind of what you call learning, the clustering methods, detecting community grouping methods are all used in the unsupervised learning. And semi-supervised is something which is a combination of supervised and unsupervised, where some data are level and a large amount of them are unlevel. So if you have such kind of what you call data, then you go for the semi-supervised learning. Reinforcement learning is again another type of machine learning where the learning is done through trial and error methods. You run the model, the mistakes are committed, learn from the mistake, improve it again, continue like that. Example, self-driving cars. I mean, all these kinds of the Netflix, personalized recommendations of the Netflix, YouTubes are all reinforcement learning. So if you have any problem because these are the vertical different types of machine learning that you have. That most of the machine learning that I do is the first one, supervised learning, where I have a data set where the outputs are known. For example, the outputs are going to be either it's going to be a diabetic patient or non-diabetic patients. And the other three types of machine learnings are also machine learning, but which I'm not working with. Okay. So the example that I have belongs to the first type of machine learning. So the traditional programming that we do is given on the left side. We input data to the machines, then the program it, and the answer comes out. And in the machine learning, what we do is we input the data, the learning takes place. The output is now not an answer now; it's a program, it's a function. So in the regressions and other thing that we do is the output is always a number. But over here is the output is going to be a program, and this program will be used to learn learn from the unseen or unknown variable, unknown data. Is this difference okay to you? I mean, what is supervised learning? What is unsupervised learning? What is this semi-supervised learning, and so on? Supervised learning, again, I'm repeating, the data has to be the variable, the Y variable has to be level. It's either yes or no, it's either diabetic or non-diabetic. In the unsupervised, nothing is known to you. Everything is totally kind of what you call unknown variables given to you. You simply need to what you call find out some patterns and group them into different similar data, wherein you use the clusters and other thing. Then you have, see, this is the normal workflow that we follow. Is this visible to you, this one? If somebody respond, then it will be more interesting. See, what is the first thing that we do? I mean, this is what the workflow of the machine learning should look like. The first you define, I mean, what you want to do. Based on your definition, you collect the data. Okay, then the data is pre-processed. Then you do some kind of what you call exploratory data analysis, wherein you if you have any missing values, those missing values should be handled. If any of the data are misrepresented, that should be what you call put into proper representations. So definitions of the problem, data collections based on the definitions, the data pre-processing, then the exploratory data analysis, which includes the missing values as I just mentioned, and other things. And then you come down to model selections. which model you want to do. You want to go for the random forest, you want to go for what you call support vector machines, or any kind of model that you want to do, that model has to be selected over here. The training is performed using that particular model selection. Then the model is evaluated. If the evaluation is not up to the mark, then the model is run again, changing the vertical parameters. This we call it model tuning. The moment you feel that the model is fine, good enough, the accuracy is very high, then you deploy the model. Then keep monitoring and maintenance of the monitoring and maintenance also is very important part of the machine learning, because the data see, once you develop a model, that model has to be monitored and maintained all the time, because data over a period of time evolves and changes, and that change in the data should be able to handle by the model. That's why monitoring and the maintenance of the model also is very, very important. These are some of the popular supervised learning models. I was talking about this one, this supervised one. Okay, I'll be concentrating only on this. Some of the popular supervised learning models are logistic regressions, decision tree, random forest, support vector machines, KNN, and gradient boosting method like XGBoost. So the key area in strength and weakness and best use case are given over here. Logistic is a very simple and best model, and it assumes the linear relationship and simple and interpretable. But the problem is it works very poorly when the data are complex and nonlinear. A distance tree, again, it splits the data into a number of trees. The data into what do you call data into split the data based on the what do you call Fisher rules. Easy to interpret, handle nonlinearity, but the problem is it easily overfits and unstable. Now, random forest is one of the most popular and very widely used supervised learning algorithm. It's an ensemble methods wherein instead of just wait over here. This is random forest. This is if you concentrate only on one this tree, this will constitute a distance tree model. If you concentrate only one, these are three different trees. If you focus on only on one this, then this is distance tree. So in the random forest, what you do is you construct a forest with different trees, a number of trees, and the decisions are taken on different trees. And then based on the decisions of all these trees, the majority of this, suppose for example, this this tree says diabetic, this also said diabetic, and this is non-diabetic. That voting will take place to in all the trees. The majority will be the final prediction. Suppose you have two diabetic and one non-diabetic, the final answer will be a diabetic. That is random forest, wherein you have a forest of different trees with branches, and then what? Addition is taken based on the what you call majority, what the majority of the trees will be saying. This is high accuracy and robust to noise. When you have data with noisy data, then this can be very useful. But the problem with this model is interpretation becomes a little more difficult, and it's used for general purpose classification. Support vector machine. SVM stands for support vector machines. It works well with high dimension and flexible with the kernels, and sensitive to tuning. And it can be used for text, image, and bioinformatics data. KNN stands for K nearest neighbor, which again used for the classifications, and simple, no training is required. The minimum training is required over here. The weakness is slow for very slow learner for the last data, affected by the irrelevant features. Small and low dimensional data set. It can work for the small and low dimensional data set. Gradient boosting. I'll just show the picture of gradient boosting. Gradient boosting and random forest comes under a technique called ensemble methods, right? So ensemble methods wherein decisions are taken in using different trees. So over here in the gradient boosting is sequentially we build a tree to correct the previous errors. The strength is very accurate, handles complex pattern, computationally very expensive, takes quite a lot of time. Finance. See, this is random forest and this is boosting method. See the difference. In the random forest, I mean, in both the cases, you have trees. You'll have multiple trees. Over here in the random forest, what we do is every tree is independently parallelly run, and all the trees will take their own decisions, and the majority decision will be taken as the final prediction. Okay. In the boosting method, what happens is the tree will be sequentially trained. The first decision, the first training will take place at tree 1. The decision is taken. Whatever error that is committed by the tree 1 will be improved sequentially by the tree 2. And the accuracy that you have in the first tree will be a little bit improved by the second tree. Again, if some error, the accuracy is not up to the mark, then the second tree will be trained, the error is committed, that error will again be improved by the third tree. Sequentially, the error keeps on improving till the time you have a particular desirable accuracy, and that the moment you achieve that, you come out of. And that particular, what you call a value, is the final prediction. The trees are independently trained. Over here, the trees are sequentially trained. Over here, the voting method is used. Over here, the what you call sequentially improving or learning from the previous error is done in this particular boosting method. Boosting, you boost the accuracy is boosted to in the next tree from the previous one, and so on. Continue like this. That's why you call it boosting method. And both these methods comes under a technique called ensemble method. Ensemble, random forest, and boosting method comes under the ensemble method. Ensemble in the boosting is sequential. In the random forest is parallel. Just remember that. This is the SVM method, support vector method. Mathematics people must be knowing the hyperplane. This is the hyperplane that we draw. We suppress the two classes. This is diabetic, for example. This is non-diabetic. This hyperplane will be used to separate the two classes, and you'll be in the support vector method. You'll be trying to find out the best possible hyperplane which will be able to separate the two classes, I mean, distinctly. You're dealing with multi-class, then the separations are going to be done not by the hyperplane, by something called kernels. These are called kernels. Okay. This is multi-class. This is K nearest neighbor. You have two data sets. This square and these blue circles are two different. This may be the diabetic. This is non-diabetic. You have an unknown data which is brought inside, and you want to check where this data is going to belong to. So what KNN does is, the KNN start computing the distance of this variable from this and this. The one with the shorter distance, I mean, so for example, this particular vertical circle has this new variable is closer to these circles on the basis of the some distance calculation, maybe using the Euclidean distance calculations. Then what your prediction will be, this belongs to this category, not to this category. So it's on the basis of the distance computations in the KNN. So this is what I was talking about, the difference between the regression and the machine learning. See, the purpose of the regression is to explain the relationship between the variables. When you run a regression model, your objective is to what? To explain the relationship between the variables. But if your primary objective is not on the explanations of the variables, relationship between the variables, but to increase the accuracy, increase the accuracy of, am I audible? Hello?
Yes,
Yes,
sir,
sir,
you're
you're
audible.
audible.
I mean, because I was only talking, I told like people. See, I mean, if you check between these two, you'll come to know what is the difference between regression and machine learning. If your primary objective is between to explain the relationship between the variables, then you go for the regression. If you're more focused on what accuracy and the prediction and pattern recognition, then it's the data science and machine learning. Type of relationship. See, most of the regression modeling, we normally assume the linear relationship between the variables, right? I mean, in some cases, you go for the nonlinear also. But the assumptions are very strict and stringent in the regression modeling. When it comes to machine learning, it can handle the assumptions are more or less, I mean, very, very minimal. Or in many models, you can even run the models with no assumptions also. Can learn from any kind of relationship, be it linear, non-linear, or complex, which does not have a what you call mathematical name to call. So it can learn from the non-linear and complex relationship, which does not have a mathematical what you call functions to explain. This is one very serious limitations of the regressions. It has these assumptions to what you call satisfy before you run the regression modeling. So data handling works well with small and structured data sets. But in the machine learning, it can handle large, high dimension and unstructured data. More flexibility, fixed regression, you cannot do anything. If you're running a linear regression model, this is the equation that you need to obey. Over here, the flexibility depends on the what you call the type of model that you select. If you select SVM, then I mean, so you have variety of flexibilities based on the model selections in the machine learning. Interpretations, again, this is one area where the machine learning is lagging behind the regressions. In regressions, you can easily interpret the coefficients, the minus, the plus, the significant variable, non-significant, all those things can be done. This kind of interpretations, this kind of luxury is not there in the machine learning. It's a complex, and it is sometimes, in many times it's called black box. So accuracy may underperform on complex data regression because this can handle what you call complex relationship and generally will have give higher predictive accuracies. Feature interaction manual, automatic, and adaptability static. You cannot customize. If the equation is fixed, you cannot change. Static is dynamic. You can change the what you call enhance the accuracies by tuning the parameters of the various model that you select. Computations fast and simple. In the machine learning, the computations are very time consuming, computationally very, very intensive and time consuming, expensive, you can say. So when do you go for the machine learning and when do you go for the regressions? Use cases. If you're concerned with understanding the relationship between the features and the variables, then go for the regressions, provided the assumptions are good. But when you are when you're for high accuracies, high performance, or high prediction accuracies is the main goal, then go for the machine learning. So this, if you're saying the last one is important, if you're looking for understanding the relationship between the variable, then always go for the regression. Again, provided the assumptions are good. Okay, so accuracy, machine learning. Now, some of the general machine learning frameworks in R, the packages. The first one is the one that I'm going to use. Is the most popular. Carrot, we call it. When you type Carrot into Google, this will automatically come out. Carrot stands for classification and regression training, and is the most widely used machine learning framework. So when what we do in machine learning is you construct a framework using a package, and these are the packages available in R. These are the popular packages available in R for creating a framework for the machine learning. Okay, the framework wherein you what do you call train models, pre-process, tuning, and resampling and all. So this we call it framework construction of the machine learning. So these are the other what you call softwares which are available in R, which will do almost the same thing that will be done in the Carrot. So MLR3, it's considered to be a modern successor to Carrot. I'll have to confess, I have worked only with the first one. Now, so this will only construct a framework. The algorithms will be given by this. You're interested in going for random forest, then random forest, this is the name of the package. A decision tree, this is the name of the package. Gradient boosting, this is the name of the package. Extreme gradient boosting, this is the name of package. Gradient boosting method, this is the name. And the neural network, NNNet, is the name of the package. And the KNN, K nearest neighbor, this is the name of the package. These are all the names of the package that you have, okay? And the penalized regression, people who have worked with the penalized regression will come to know, Lasso and Rich. These are called regularization regression models, wherein you penalize those particular variables which are of less importance and try to remove it from the vertical model itself. Such models are called penalized regression models or regularized regression models. And this is the package for that. So this will help you in constructing the framework, and this will help you in running the vertical particular machine learning algorithm. So these are the different algorithms, these are the packages, and these are the kind of what you call the nodes that you can carry forward. So these are some of the what you call the metrics of the machine learning. Sensitivity. What is sensitivity? The TP stands for true positive. FN stands for false negative, and TN stands for true negative, and FP stands for false positive. So sensitivity, specificity, precision, and false positive rate are some of the metrics that we use for evaluating your output of the machine learning. So when you are say which particular matrix you should look for, which you should be more focusing on depends on the kind of work that you do. Suppose you are into detection of disease, then you should go for the sensitivity. So what is this going to tell you? How well the model identifies the actual positives. The higher the better. See, if you are, say, for example, a person, the higher the better means what? Suppose you're identifying a person as having cancer or not having cancer. If you identify someone having cancer as not having, then it's very, very dangerous. So when you're looking for kind of disease identification, sensitivity is the one that we should go for. We should be having higher sensitivity. And if you are kind of looking for, say, identifications of fraudulent transactions or a person who is committing fraud in the banking system. See, a person who has not committed for fraud, if you say that you are a fraudulent person, then that is not good. In such situations, then this should have a very high value. Disease identification, this should have a high value, and the other one, this should have a high value. So these are some of the metrics that we normally focus to evaluate your machine learning, the performance, the algorithm that you run. So this much I have in the vertical PPT. If anyone has any problem, you can ask me in this. Should I go to the vertical R coding then? Hello?
Yes, sir.
Should I go to the coding then? See, I will be using a data set from a website called, I'll just type it over here. Is this visible to you? No, I'm not sharing the screen now. See, this abide is a data, it's a neurological data, data exchange website, right? I have downloaded data from this website, and then I have tried to classify, say, the individual as autistic and non-autistic. Okay, the data that I have used is from this website only, and this is a website in USA, wherein they maintained the fMRI data. fMRI means what? Functional MRI data. Wherein functional MRI means what? The patients are allowed to perform certain functions, and the MRI images are taken. So those images were downloaded and processed, and then I applied the machine learning algorithm to classify the patient as autistic and non-autistic. So this is the data that I have, okay, which I have downloaded from here and processed. I downloaded the data from here and I processed, and this is the data set that we have. And these are the descriptions of this represents the various features of the various part of the brain in the fMRI image. Okay. So we had a neuroscientist in the team, and he was responsible for interpreting or identifying all these features after the machine learning is done. So the machine learning portion was handled by the people from myself and another one from the ICMR, Jiten sir, who came the other day. So these are the various brain features which were used for the identifications of the or the classification of patient as autistic and non-autistic. So these variables are now represented over here. Okay, these are the variable that you have seen this side. This one. The abbreviation of these variables are written on top of the columns, and this every row represents a particular patient. This is control means what? Not autistic. Okay, and these are autistic one. So for the autistic and the non-autistic, which we call it control, we have all the brain features in numeric variables. And this will be used to identify, to classify autistic and non-autistic using the machine learning algorithm. So what I will do in the machine learning now is I'll follow this. I'll try to understand the data first, and then I'll identify if there is any features in this, if there is any feature in this which are going to be of less important, and that we call it feature selection. I also will pre-process, meaning what? I'll bring all the features at level playing field, and that will be done using scaling and centering. And then I'll train the model using random forest and support vector. And then the model will be evaluated. Okay. So this is a summary of what I had given just above. So let's do it. Now I'm opening my R over here. What happened in machine learning is I cannot run the what do you call this the algorithm online, because it's very time consuming. If I start learning this training the model online, then it will take, certain model takes 20 minutes, 30 minutes. So what I've done is I had already run the what you call model software. I have saved the output in this. You can check it here. These are the outputs which I've already saved in this, right? So, but I'll just explain the what you call the coding which I've done over here, step by step, one by one, so that you also understand. So for the kind of what you call algorithm that, hello?
Sir, your screen has been stuck in the Abide software only. It's not been on the R. So,
One second,
yeah,
one second.
yeah, sure.
I've been moving to the others. What do you call this thing? I'm so
Okay,
sorry.
sure. Oh, it's fine, sir.
So data, at least you have seen, this is the data, this is the data source. This is the website from where I have downloaded the data. Okay.
Okay, sir.
Is it visible now? Is this visible now?
Yeah, yes, sir. Yes, sir. Now it's visible,
So
the hours to you.
what happened in machine learning is, let me confess you one thing. In such kind of what you call presentation or workshop, I cannot run the what you call machine learning coding. I mean, I have to save the what you call the output on machine learning before I start the sessions, because certain machine learning coding takes at least 20-30 minutes to give the output. So that in the live session is difficult to run. Okay, it will be very time consuming and it will be a waste of time. But still, I'll be explaining the steps of the algorithm which I've written over here one by one. So this what I've done is I've installed 3 packages over here. I mean, have you seen this package? I mean, the installation of package was done in the previous session also, right? If somebody can answer to me, how to install package in R was done in the previous session, right? अगर आप
Yes,
नहीं
yes,
किए, then
sir.
I'll be happy to do it.
Yeah, sir. Please do one more example, sir.
One more example. See, what happened is, what happened is, you can directly go over here and do the installation also. What are the packages? These are the package name. What XLX will help you in working with Excel file in R. Caret is the one that I was talking about in the presentation. This will make the framework of the machine learning. Random forest is the algorithm, is the package which will help you in running the random forest algorithm, right? So these are the 3 packages that I'll be installing. So what you can do is either you directly type over here, install packages, and in the inverted comma, the name of the package. The first package that I mentioned is XLX. What is the objective of this package? This package will help us in working with Excel file. Okay? Is this okay? So when I click on this will start installing again. But the problem is, I've already installed this package in my computer. Why should I install it again and again? So for this, what I've done is I have used a different command over here. If require only, then this package should be installed along with the dependency. Are you okay with this command? If somebody can switch on the mic and just what do you call, answer my, if you are not getting, I will be happy to explain it again. What is the difference between this line and the line above? Both will do the same. What is the difference? In this line, package, every time you click on this, the package will be reinstalled even if you have it before in your computer. Okay. In this line, if you include this one, if require means what? Only if you don't have this in your computer, the package will be installed. Are you okay with this? Are you okay?
Yes, sir. Yes, sir.
So what is the difference? I mean, if you're switching on the mic, you please let me know what is the difference between the first and this. This one and this one. What is the difference?
Sir, the one where we have to install the package is like the package will be installed by default.
Which one? This one?
Yes, sir.
No, see, I'm explaining again. See,
Okay, sir.
as many times you run this command, as many times the package is installed. Right? Package needs to be installed in your computer only once. Remember that. Any package of R needs to be installed in your computer only once. Okay. So if you run this command again, and suppose you run it today, tomorrow you open it again, you run it again, then it will be installed again. Right? Ideally, it should not be installed because it has been installed before. Are you okay with this? Ideally, it should not be installed again because you have done the installation before. So if you do not want to install a package which has been installed before again and again, then you run this command instead of this. What is the command over here? If require, only if require, this package is please install this package. This is the command, right? The same over here. only require please install this command in your computer. So if I run this, I'm running this for you only. If I install this, package is not installed, okay? Nothing is happening, right? ठीक है ना? Let's just check this one. If I click on this, the package installation will start. करके देख ले. No, I'm not doing it because I have saved the output. That output will be gone. So you check you check it this in your computer. I'm sharing both the commands. Okay. So this in the first three commands, the package will not be installed if the package is already installed in your computer. In this command, the package will all the time be installed as many times as you click on this. So I'm not doing this. And then this is what see, I mean, for any package to start using for the very first time in a session, you need to call the library. This is calling of the library, the library of XLX. Without you running this library, you will not, this package will not be available for use. So let me do it. करूं इसको? Library is done. Caret का भी और random forest का भी. So now you are ready with the packages. You have three packages. The libraries are done. The packages were installed before. And now then the next step is to bring the data in. This is the data that I have. I'm going to bring this data inside R. See, where is the data now? ये data मेरा यहाँ पे बेटा देखो. The data that I have is here. One second. This is where my data is. This is the data, okay? And the location for this data is C user admin desktop and ML PPT, right? This location has to be informed to my data is there. You come and bring this data. So what I'll do is I'll go to session, okay? Set the working directory. I'm telling my data is over there. You come and bring the data from there. Set working directory, source directory. My data was in a desktop. It was inside the ML PPT folder over here. And then you click OK. Okay, this is the part which R has set up. You can copy this and put it here for future reference. Okay. So this is the part. User admin desktop ML PPT. You have the data in this. I'm clicking this. Now my computer, my R is now linked to that particular folder. So anything that in that folder, you can directly pick up, call inside R. So I'm calling that. For calling that particular, what do you call this file, that this particular file is in the Excel format, okay? This is in the Excel format and it's saved under sheet number 2. Remember this. Excel, what is the name? Data 0922. This is the name of the data and the sheet name is 2. Remember this. So my data name is this with the extension read.access. I'm calling inside. Calling is read, for exporting is write. Read for bringing in, write for taking out. Okay? Read for bringing inside R and write for taking outside R. So name of the data with the extension, and you'll have to give the sheet name. What is the sheet name? What is the sheet name? Is the sheet name visible? If somebody can switch on the mic and I will just respond to. Is the sheet name visible to you? Hello?
No, sir. No, sir.
So sheet name is over here. See, is the Excel sheet visible to you?
No, sir.
Excel sheet also is not visible. What happened? What is visible to you now?
It's record, sir. Record.
The coach only. Okay. Let me try it again. Is the sheet name visible now? Is the Excel sheet visible now?
Sir, not yet. It will come. Yeah, it's visible now. Yes.
See, this is the data that I'm trying to bring inside the R study. Okay, this is the data. So that this data includes all those brain features along with the autism and the control patients. Okay, so the seat names are seat 1 and seat 2. My data is in what? Which seat? Seat number 2, right? And seat number 1 has the what do you call explanation of the variables. Okay, seat number 2 has the data, and this is what I'm trying to bring inside. Okay. So again, I don't know why this is not moving. So I'm coming to this. So where was the data that I had? कौन सी seat में था? What was the seat number? Seat number 2, right? है ना?
Yes, sir.
2 था 1 था वो. I think seat 1, yeah, I think.
Sheet 1 had the explanation and sheet 2 had the data.
I have to open this data and check it again. I think this is the data. 1 second. I think data has been picked up from some other source. Chalo, data has been brought inside. And if you want to see the data that you just brought, see what happened, what I brought inside. What I brought inside now, I brought this one inside. Ideally, I should have been bringing what? This one, no? Why this is happening? I have brought this one inside. Why this is happening? Because the name of the seat is what? The name of the seat is seat number 1, no? It should have been seat number 2. ठीक है? It's taking some time because data has some volume. हो गया, data अंदर आ गया. My data has come inside. If you want to see the data again, click on this. View command will display the data over here. I think this was the data that we had, no? This was the data that we had. You had 2 groups. One is control, the other one is autism wala. Okay? So you have brought the data in, and now you have also seen the data over here. Now I'm interested in seeing the structure of the data. How is the structure look like? So for that, I give the command str, then data. Okay? So this will give the structure of the data. Okay? This is the structure of the data. देखो यहाँ पे. See, your data has how many rows? This is the number of rows, and this is the number of variable, including one dependent variable. This is going to be the dependent variable. These are the independent variable. So you have a total of 78 independent variable and 1 dependent variable. अब देख रहे हो, when except for the first one, which is the group, यानी which is either autistic or control, the remaining which type of what is the type of the remaining variables? These are important. Before you do the machine learning, this needs to be run. This needs to be understood. Then you go to the machine learning. So what is the first one? What is the type of the first variable? One can switch on the mic and just what do you call, I mean. What is the type of the first variable? One of you please switch on the mic. Hello?
So it's character. The first variable is character.
That is, you please continue what you call responding to what I said. Then only I'll feel like
Yeah,
that I've been listened by the other people. See, character is a misrepresentation of data. It should be factor. देखो, patients can be either autistic or control. Okay, so character में तो इस तरह का classification, such type of classification we call it factor. So this data is misrepresented in the data frame. So what we do is we need to change this particular character into its into its proper format. So group should be what? Correct factor instead of character. For that, I run a command over here. What is this doing? See, it's going to run. What is the name of data? This is data. If you put a dollar sign, you will be able to see all the variable over here. Okay, all the variables, all those 79 variables will be visible over here. Data, then when you put a dollar sign, all those variables will be visible. So I'm interested in changing the type of this first variable, the group data, which was presented as character, which should have been factor. So I select this, okay, then I put this, then I'm transforming to, see, this, I'm going to transform from character to factor. That's why I said as factor. So this data, which is what group, should be now converted from the character. जो भी यहाँ लिखेंगे, that will be the conversion. If you write character, it will be converted to character still. I mean, whatever you write. See, यहाँ पे देखेंगे ना. As dot करने पे, you'll have so many options, right? So many options. One among this is आपका क्या है? What was that? This, I'm interested in this only. Okay, data, the same thing, group. Okay, what was the type you said? We have seen this the first as character, right? Now you run it again, the structure command. This time that variable will be shown as what? As a क्या देख रहे हो? Factor देख रहे हो ना?
Factor.
That the data has been, this particular variable is now feature is now put into its proper format. Okay, this should be done only see, if in any of the numeric over here, if all this also represented wrongly, that also has to be converted. Okay, in the manner as I have done. One second. यहाँ तक ठीक है? हमने क्या किया अभी तक? हमने क्या किया? We recall it again. We install the packages that which are required using this command. This command helps you not reinstalling any package which has been installed before. And then after installation, we run the library. Then we give the directory where your file is to the RStudio. Using that directory and this command read.xlx, you bring the data inside. And then you see the data using the view command and you check the structure if any data is misrepresented, and we have found one, and that data was group data, and group data has been converted into its proper format. ठीक है? यहाँ तक हुआ है ना हमने? है कि नहीं? We done up to this, right?
Yes, sir. Yes, sir.
So how many data you had over here? 740. 740 people got data here, which includes autistic and non-autistic. Okay, autistic are represented by क्या था? ASD, and non-autistic control, we call it control, and those are represented by CTL. Okay, how many we don't know. We know total of 700. How many? 700 कितना था? 40. Of these 740, how many are autistic? How many are non-autistic? That we don't know. We want to check it. तो इसका क्या करेंगे? What we do is, I'll run it for you again. We use the table command, and in the data we call this particular group. We are counting how many ASD and how many control. When you run this, the number will come out. Okay, how many control now? 396, and how many autistic? Kina 344. Data is slightly unbalanced, right? Dono same nahi. If the control and the autistic are not having the same number of distinct observation, we call it slightly unbalanced data. ये unbalanced है, highly नहीं है, slightly है. ठीक है यहाँ तक ठीक है? Are you okay with this? यहाँ तक ठीक है ना?
Yes, sir. Yes, sir.
तो how many variable we had? कितना variable था? Anyone who recall? मैं यहाँ भी लिख दिया देखो. कितना था? 79, which include the group variable. Group is not, we're going to predict the group using the other variables, right? 79 में से group minus करेंगे, you're left with how many? 78 features variable. ये Excel आ रहा है क्या यहाँ पे? Is Excel coming? No.
No, sir. It's
नहीं आ
not
रहा ना?
coming.
This is coming at least now. So we're going to predict this using these variables, okay? So इसमें how many we have? How many of these variables? How many of this variable? This is visible, right? The data is visible.
Yes,
Is the
sir,
data
it's visible.
So how many of these variables you have? This is one. This is going to be predicted using this. How many of this? Batana? 78. Total 79 था. 1 2 group का हो गया. The remaining 78 will be the features variable, which will be used in what? Predicting the autistic patient. ठीक है? So what happen is, out of this 78 variable, you may have a number of variable which are unimportant, which will not help you in any sense in the prediction. Are you getting what I'm saying? Out of the 75 variable, there may be what? Many features which are of less important, okay? Which may not help in the final algorithm. ठीक है ना? I want to remove those variables. उसको include करेंगे then the model will become heavy and it will become more time consuming. So I want to identify only those variables which are important, which will contribute in the classifications. Are you okay with this? So for that, I need to install another package called Baruta. फिर मैं यहाँ से ऊपर से उठा लेता हूँ. इसको उठा के नीचे पेस्ट करूंगा. क्या करूंगा? क्या नाम है इसका? What is the name of the package? Baruta. ठीक है? Baruta. So this package needs to be installed. मेरे तो पहले से इंस्टॉल है. That's why it's not what you call Baruta. देखो यहाँ पे टिक कर रखा ना. जो देखो यहाँ पे जो packages का लिस्ट है ना, all those packages which are installed in your computer will be found as tick. टिक हो रहा है कि नहीं यहाँ पे? देख रहे हो? Is this visible?
Yes, sir, it's visible.
तो आपकी यहाँ पे जो टिक पैकेज है, what is the meaning of that? What is the meaning of that?
Means
The
that package is active.
The package is available for use. It's installed in your computer. Okay. So I have already installed Baruta. I don't have to install it, but you'll have to do it. देखो कितना बढ़िया पिक्चर आते हैं यहाँ से. ये मैं इसको लाइव इंस्टॉलेशन कर लेता हूँ. It will take 1 or 2 minutes to finish. Okay. This is the command to find out the what you call important pieces. मैं run कर रहा हूँ. I'm sharing the coding to you. Don't worry about this. This will take some time. The system started identifying, analyzing the features. The 78. यहाँ क्या लिखे? What is the number you see on the right side? 78. No. 78, right? 78 was the total features. Well, the system is analyzing the 78 pieces. How many of these pieces will be contributing in the actual analysis, actual machine learning algorithm? I'll be dropping those variables which are of less important or will not contribute anything in the model. ये कौन से पैकेज से कर रहा है? What is the package that we're using for this? What is the package? कोई बताएगा? What is the name of the package? Baruta, na? Am I audible? Hello?
Yes, sir. Yes, sir.
Yes,
You're
sir,
audible.
अच्छा क्या कौन से पैकेज से कर रहे हैं बताओ? What are we doing? बोलते जाओ. This will take some time. आप लोग बोलो बताओ क्या कर रहे हैं बताओ? What are we doing?
Sir, it's Boruta.
What are we doing?
Sir, we are calculating if we have that autism function or not from that out of the 78 features.
आप बताओ. मैं बोलूं? ठीक है. Do not switch off the mic. Okay. We have how many? You said 78 features which will be used for classifications of autistic and non-autistic. ठीक है. Yes, 78. It's not necessary that all the 78 features will contribute in the classification. There may be some features which will be of no importance, no use. है I want those features to be taken out before I run the model. So that the model becomes lighter. ठीक है. And to identify those features which are important or which are not important, we need a package. We install a package called Baruta. And that Baruta is run only to identify the important features and to drop the word unimportant features. ठीक है? यहाँ तक ठीक है? Am I okay?
Yes, sir.
Yes,
देखो
sir.
इसका आउटपुट क्या आ रहा है देखना यहाँ पे. What is the output? 1 second. What is the output? क्या कह रही है? This Baruta perform how many iterations? Switch on the mic, don't switch off. ठीक है? How many iterations this Baruta perform? कितना? 99 iteration perform किए हैं. Approximately 1.5 minutes लगाया उसने. And it has identified as 45 word features as important. ये नाम है उसका. ठीक है? It has identified 45 pieces as important. ठीक है? और 6 pieces को उसने identify किया which are not important, useless. This will not contribute. I will not going to include this 6 pieces. But the problem is Baruta is still unable to decide on 27 pieces. And these 27 pieces Baruta is calling as tentative. ठीक है? कितना decide हो गया? How many confirmed features? बताना. Will take some time in this. How many confirmed features in this? All the day. How many confirmed features in this? बताओ.
27, sir.
अरे आराम से. How many? How many you said? Hello?
I think it is 45 attributes which are confirmed important.
Which are confirmed as important. Okay.
Yes, sir.
Then?
And out of that, 6 are unimportant.
उसको drop करना है हमको. Then
Yes,
what?
sir.
27 are still in between.
Tentative attributes.
In between. Important भी हो
Yes, sir.
सकता है और unimportant भी हो सकता है.
Yes, yes. sir.
इसके ऊपर डिसाइड करना है हमको. पहले प्लॉट करके देख लेते हैं कैसे प्लॉटिंग आता है. देखो आप. ठीक, ये इंपॉर्टेंट फीचर है जो डिसाइड हो चुका है. ये प्लॉट देखो यहाँ पे. देख रहे हो?
Yes, sir.
So all the greens are confirmed variables. All the reds are unimportant variables. All the yellows are what?
In between.
Tentative variables. So we'll
Tentative.
have to convert these yellows either into red or green. ठीक है? यहाँ तक ठीक है?
Yes, sir.
आपका you started with 78. Now you have confirmed. I don't know how many. 45, I think, right? 45 variable as important. 7 as unimportant. 25 still hanging. Okay. So this next step is to fix the what you call hanging variable on either side, either on the red side or on the green side. तो मैं इसका कमांड रन कर रहा हूं. देखो आगे कि नहीं. अब देखो what is happening now. This is a second plot, not the first one. The first one is here. The first one is here. The second plot is here. What is happening? What is the difference between the second and first?
So, sir, the tentative ones have been dropped and
The
the
tentatives
unimportant ones have been marked.
Tentatives are now being what you call moved. It has been moved either on the red side or on the green side. So the green number also increased and the red also increased. The green was only 45 and the red was 27. यही है ना? The red was 6. Sorry, red was 6. Tentative was 27. That 27 has been divided into दोनों तरफ. देख लेते हैं यहाँ पे. Now this is the final. How many we have? यहाँ देखो. How many we have? We started with 78. Now we left with how many? 57 variables only. The remaining 21 are classified as unimportant. देखो ना आप मॉडल 78 में रन करेंगे. मॉडल कितना हेवी हो जाता. Now the variable 25 variable has been taken out before you start running the model. ठीक है? So you will be running the machine learning model only on these 57 variables. ठीक है? So those 57 variable I am collecting here and then I'm putting it in the data that I have. This is the one that I have. देखो यहाँ पे. This is. ठीक है? यहाँ देखो. The number of observation remains the same, but the variable has dropped to what? The variable has to drop to कितना में आ गया? 57 में आ गया ना? ठीक है? So now I'm preparing the structure. देखो यहाँ पे all these are data preparations before the क्या है आपकी actual machine learning. So you can again check the number of what you call control and this thing autistic जो है persons. This number remains the same. So now this is why the machine learning start. यहाँ तक जो है ना आपका एक तरह से क्या नाम है EDA बोल सकते हैं यहाँ तो. You're playing with the data so that you can start the machine learning. This is why the machine learning start. ठीक है? The first step of machine learning is splitting of the data into training and testing. One set of data you'll use to construct or train the model. Then other set of data which will be totally unknown to the machine will be used to test the model that you develop during the training data. So for that, I divide the data into 80-20. 80% of the data will be used in the training and 20% will be used in checking the what you call model that you have developed. Okay? So for dividing the data, I have used a function called create partition. Create partition will divide the data into training and testing. Okay? So this P equals 0.8 means what? You are dividing into 80-20. So 80 will go to training and 20 will go to the testing. Remember, create partition का एक फायदा ये है. What is the proportion? You have some number for. देखो ना यहाँ पे क्या हो रहा है? How many autistic you have? How many autistic you have? Are you able to see? Autistic is 344, control is 396. This proportion of autistic and control what you call patients will be maintained if you use create partition. एक तरफ नहीं जाएगा, बराबर का आएंगे. So I've divided this. The training data set I'm storing in this 80% in train data and 20% in test data. I'm sharing this code to you. You run it. आप data भी share कर दूंगा. You run this in your or in your system only. Then you check this structure again of the train data. यहाँ एक बार देखना. What was the total observation that we had? Can anybody tell me? What was the total observation that we had?
593 observations, sir.
नहीं, ये नहीं था ना. It was 740, I think, right? 740 में से 80% निकाल के आपने यहाँ डाल दी. ठीक है? Randomly निकालते हैं. Keeping the proportion of control and क्या नाम है autistic patient in this. मैं रिपीट कर रहा हूँ 740 में से 80% randomly निकाल के आपने इस डाटा में डाल दी. उसको हमने नाम दे दी ट्रेन डाटा and this will be used to train the models. Okay? The remaining 20% we keep it in the test data. ठीक? ट्रेन डाटा का आप स्ट्रक्चर देंगे. What was the proportion of the what was the proportion of the देखो यहाँ पे मेरे ट्रेन आपके क्या था वो उसमें आई डोंट रिमेम्बर दैट था क्या था वो देखो ये एक्चुअल जो गिव ओरिजिनल डाटा में था ओरिजिनल डाटा में यू हैड हाउ मेनी ऑटिस्टिक 344 and control you had how many 396 in the test data which is 80% of this you still have 276 autistic and 317 control. Okay, so this data we're going to use for training. Okay, are you okay with this? ठीक है. मुश्किल है. अरे मुश्किल है क्या?
No, sir, it's fine.
चलो
Yes,
ठीक.
sir.
मुश्किल तो होगा. एक क्लास में सब कुछ थोड़ी सिखा जाता है. चलो मैं यहाँ देखो एक चीज देखो समरी सब जो जितना भी जो आपका 70 या 57 वेरिएबल है सबका स्टैटिस्टिक्स याद दे रखा है. समरी निकाल रखा हूँ. ठीक है, मैक्सिमम मिनिमम सबका निकाल रखा है. तो देखो ना कुछ वेरिएबल तो एकदम छोटा छोटा डेसिमल पे है. कुछ देखो ये तो और भी ज्यादा छोटा हो गया. मतलब द वेरिएबल साइज आर डिफरिंग and this will create a problem in the modeling. So what we do is we bring all the variable into level playing field. That is done by again the pre-process, and we use the command center and scale. Yani, I mean, all those variables were subtracted from all those element of those variables. उसका अपना mean subtract करके divide by क्या नाम है standard deviation. What this is what we're doing. This will make all the variable almost in the same range. ठीक है? मैं run कर रहा हूँ बेटा, क्योंकि मतलब run कर रहा हूँ, then I'll share it to you. तो यहाँ तक आपका splitting of data and then pre-processing of data is now being done. एक बहुत एकदम यूजफुल कमांड है यहाँ पे फिशर प्लॉट करके, यहाँ देखना बढ़िया प्लॉट आएगा यहाँ पे. So what I'm doing is I am plotting the how many variable we had 57. Yeah, 57 में से first 20 को मैं यहाँ प्लॉट करके दिखा रहा हूँ. ठीक है, देखो यहाँ पे क्या कैसे आ रहा है. इसको थोड़ा बड़ा करता हूँ, देख रहे हो ये. Only for the first 20 you have a total of 57. मैंने खाली 20 का प्लॉट किया यहाँ पे. What is happening? Can anybody see what is happening over here? For each of the feature, ये जो वेरिएबल है इसका ऑटिस्टिक अलग, हर वेरिएबल में दोनों है ना, ऑटिस्टिक भी है और कंट्रोल भी है. How is a box plot of the control and autistic look like for this variable? सब वेरिएबल के है. जितना ज्यादा डिफरेंस दिखेंगे ना यहाँ पे दोनों में, if a particular pieces have quite a different in these two box plot, that variable is going to be important. For example, this यहाँ देख रहे हो, ये वाला फीचर देख पा रहे हो? हेलो, one of you please respond. Can you see this box plot? मैं आपको शेयर करेंगे, डोंट वरी, you'll be running it by yourself. ये देख पा रहे हो कि नहीं? Are you able to see this? Hello? चलो, I'll finish if you are not responding. तो आपका this is another Fisher plot, we call it. This is density. The previous one was box plot. इसमें देखो, if you want to check into this, you can have quite a lot of step in this. बॉक्स है, स्ट्रिप प्लॉट करके देख लेते क्या आता है. इसको कॉपी करके यहाँ रिप्लेस करना है बस. ये नहीं आ रहा, इसका नहीं आ रहा पीयर प्लॉट. Pr plot is coming. I use the box plot, not the other one. But I'm just what you call showing it to you how what all can be, what all plot can be done. These are the different math plots that you can do. Box, dense box, and this is something. I mean, I will not be able to explain this. तो 2 मिनट लगा के बताना. Somebody explain what we have done up to now. What we have done up to now? Can somebody explain it to me? बताओ. One of you switch on the mic and explain it to me what we have done so far. Yeah, मैं continue करूं? Should I continue running the code? Am I audible? Chalo, I'll continue running the codes. See, this is the training. This is where the actual coding starts. Okay. So this is going to take some time. यहाँ देख रहे हो लाल बटन, this is processing. This is support vector machine का coding है. So what I'll do is I'll go to this another what is this page. यहाँ पे है, मैंने पूरा सेव कर रखा है. पहले से रन करके have saved all the outcomes over here. When I run this course, after that, the output will be saved in this particular model. Then this can be plotted over here. This is the plot. This is the highest accuracy where you have. This is the best tuning parameter, 80% is the kind of accuracy that you're going to have. These are the important features. This is playing the most significant role in the classification of autism and control, and so on. And the important decreases over here. And this the higher the vertical high the variable at the tops are the variables which are contributing the most in the classifications. देखो यहाँ पे this is called confusion matrix. This is the actual, see, this is the predicted value. You have a total of how many autistic, kitna hai? 51, 61. You have a total of 61 autistic patients. Out of the 61 autistic patients, 47 are correctly identified. Okay? And 14 are wrongly identified as normal. Okay? And in the control, you have how many? 86. Of the 86, 65 are correctly identified and 21 are wrongly classified as what? Autistic. Okay? And these are the value. Accuracy is good enough. 76% is a very good accuracy. This is for the SBM, and this is the code for the SBM. Okay? Similarly, you have the KNN. This is the KNN plot. The tuning parameters are coming out over here. And then importance plot is here. This is the KNN important plots. You'll have to what you call compare the important features over here, important features between the models. जितना भी मॉडल जो आपने रन किया all those models are into agreement to the important features. अगर हो रहा है तो बहुत अच्छे. If there are contradiction, then you'll have to run the model again. Okay, again the confusion matrix for the KNN. The accuracy is very low in the KNN, 58 only. Okay, it was 70 something, 76 in the SBM. In the KNN, KNN is not a very good learner in such high dimension data. Random forest, okay. This is random forest. I have already run the codes. I have saved the output over here. If I started running again, it will take, random forest will take 15 minutes for me to complete. So I have run the model and saved the output over here. This is the output. This is the plot of the random forest running that you've done for 3 different forests. One forest is 153 and the second forest is 160 and so on. This is the variable importance plot for the random forest. You have 3 plots now. One for the SBM, one for the KNN, next for the random forest. And confusion matrix is here. This is the confusion matrix for the random forest. And the SBM and random forest are almost having the same kind of accuracy. Now, you can compare all the model in one platform using this plot. देखो ये plots all the क्या नाम है उसका models are being compared in one platform. This comparison is done on the basis of the training phase. So random forest in the training phase has the highest accuracy, and followed by SBM, and the KNN is very low. This is another plot that you can do. So that's all I have. If you have any question, you ask me. Should I share this code to you along with the data? Hello?
Yeah. Yes, I can share, no problem.
But see, machine learning, see, the advantage of nowadays, the advantage of doing machine learning nowadays is, so when I started learning, I do it all by myself, right? Now, the AIs, the GPTs, and all those things can help you in refining the code that you write. But you should be able to understand the workflow of the machine learning. Only then the AI can help you. The AI will not help you in the workflow. How many of you have done this? I mean, how many of you have read or heard of this machine learning before? You want to see the Oracle publication that I have done using this data? This is the publication which I've done. I have already used this data to publish a paper. See क्या है ये देखो. Classification and feature selection of autism spectrum disorder. This is published in Journal of Technology and Behavioral Sciences. It's a Scopus Q1 journal. ठीक है, Q1 का Scopus का journal है. जितना भी जो हमने pick, or whatever pictures that you have been seeing just now, you will find it in the what do you call this, in the paper also. You see this picture? Hana, which in this picture and the what do you call in one of the output, wherein you have the green as the important variable, this yellow as the tentative, the red as the what unimportant. Then the fixation of the what do you call variable in either side. And this, I mean, I have only demonstrated only 3 machine learning algorithm in this paper. I've included how many? 1, 3, 6, 9 algorithm I've compared. The highest ROC that I had in this was 87.96. And are you able to see the what do you call these slides that I'm showing to you? No. नहीं देख पा रहा ना?
No,
नहीं,
sir.
मैं तो दिखाते चले गए. कहाँ से लेगा ये देखो. This is a paper which I published using the data that I have just used. Okay. देख रहे हो अभी? Are you able to see it now?
Yes, sir. Yes, sir.
Journal of Technology and Behavioral Sciences is a Q1 journal. It's Scopus Q1 journal. Okay. And in this, we have published a paper using the same set of data, almost using the same algorithm that I have done. The algorithm that I have, the coding that I have shown to you was used to what you call write this paper. Okay. See, you see this picture? You see this picture,
Yes.
no? We've
Yes,
done
sir.
this picture in it was in one of the output. Okay. And what are these colors? Green, yellow, and red. Red is unimportant. Yellow is tentative. Green is what? Important. And then you fix the yellow. How many algorithm we had just seen in the presentation just now? 3: SVM, KNN, and RF. ये वाला. SVM, RF, and KNN. Okay, these are the vertical outputs of the training phase. I was able to achieve 88% ROC in the training phase. It's very high in the what do you call in the presentation that I had. I was able to achieve only how much? 78 or 80 something. Much lower because the tuning was very refined in the paper. यहाँ पे बड़ी हल्का ट्यून किया है मैंने. And this plotting also you had seen only one plot. I have combined all the 9 plots in one. And this is one of the plots that you have seen. For 3, I have 9 over here. Okay. So all these things can be done in machine learning. And you have quite a lot of videos and codes available online for some simple data set. You can start with that. Okay. So workflow क्या था? What was the workflow that we done in the machine learning? Can anybody remind me? This is the workflow that I have done. पहले you understand your data. Once you handle the data, then you start what? Selecting the features. How was the feature selection done? What was the name of the package that we use in the feature selection? Batao? What was the name of the package? Baruta. Yeah, right. Baruta. Right. Baruta. Okay. Baruta. Okay. Right. This one, na? Baruta. This one, right? Baruta. Right? You have another package called app selector, which is doing almost the same thing that Baruta is doing. Okay? And then model framing. Model framing was done using the carrot package. This is the package that I have used. This is the package that I have used for model framing, wherein you train, you tune, you test. That is called model framing. Okay. And then what? Training, tuning, and validation is model framing. Okay. No, sorry, my model training, it comes under model training. Then a proper algorithm will be selected based on the kind of work that you want to do. So the first two I've done in the demonstration, random forest and support vector machine, SVM we call it. The next phase is called testing, evaluations with the unknown data. So 20%, we divided the data into what percentage? 80 and 20, right? 80 was used in this phase, 20 was used in this phase. And then the moment you feel that your accuracy is good enough, you stop. Okay? This is all what we call it machine learning. And most of the machine learning that you find in the papers and real life most of them are classification, very rarely regressions. Though you can also do regression in machine learning. Okay? So मेरे तरफ से तो I have only this much. I have only this much. So if you so you have been writing messages. I was not seeing the messages. See, I'll tell you one thing. I'll confess you something. I'll very sincerely one thing. Machine learning, you can only have some idea. This is how it's done. The coding cannot be learned in a 1 hour, 2 hour session. Okay? The coding, you'll have to learn it by yourself later on. So I'll be sharing this coding to you. Ab dekh lena isko. Madam, I think I'm done. So if anyone is having any problem, I'm ready. I'm happy to answer. Aruna, madam?
Uh, Good morning, sir.
Tell me.
Yeah. So I don't have a question. I would like to thank you for this great session. It was nice. Yeah.
Okay. Thank you. You are from?
I'm from Mali. Mali is a West Africa country. Yeah.
West
I'm a
Africa.
PhD student
Ah,
in Djibouti.
good to know. Good to know. Thank you
Thank you
so
so
much.
much
If you
for
don't have any
this.
questions, then if you don't have any question, then we can wind up this so that I can attend a meeting. I'll be sharing the codes to Aruna madam, okay? Okay? Done?
Dear participants, if there are any questions, please take advantage of the situation because sir is very, hard to get. Sir is very busy and we have connected to.
No, not like that, madam.
You should, take the maximum advantage.
Madam, you can share my email ID to any one of them if they want to ask, because I had done. You from the commerce, right?
Yes, sir.
I had written 3 to 4 papers using machine learning in the banking sector.
Okay, very
So,
nice, sir.
so this can be used in, and it's a domainless where you have a data, quite a lot of data, then machine learning will come into the picture.
True.
Okay.
Sir, we would surely like to collaborate with you in the days to come so that we are able to come up with good papers and good articles so that the society is benefited.
Right. Okay.
Okay, thank you so much, sir, for joining us. A formal, vote of thanks from Royal Global University. You spared your valuable time. You shared all your, experiences with us and expert session you had delivered. So we are really grateful. We have got to learn a lot from it. So I hope to see you again in the near future when we come up with such FDPs and workshops for our
Right.
research scholars and faculty members. So thank you so much, sir, for being
Thank you.
with
Thank
us
you.
today.
Thank you for the invitation. Thank you. Bye-bye.
Okay, dear participants, so we have come to the end of this session and we will continue with our second session for the day, for the fourth day. We'll be starting at 2 o'clock. So kindly join back at 2 o'clock and now we can break out for the lunch. Thank you everyone for joining. Sir, please unmute yourself.
Yeah, namaskar and good
Yes.
afternoon. Can you hear me?
Yes, sir. Namaskar,
Okay.
sir. Huna paisu apna.
Oh,
Okay.
I'm sorry.
No issues.
It took my time. Actually, there were students here also, so I
Okay.
had a class, so
Okay.
that was the reason.
Okay. No issues, sir. Sir, we are good to start?
Yes, we can start.
Okay. Good afternoon to all the participants. So we are on the day 4 of our 5-day FDB program. And now in the second half, we have a session on time series analysis, which will be taken by Professor Ishankur. So sir is a professor and head, Department of Applied Sciences, Faculty of Technology, Guwahati University. Sir teaches physics in general and engineering physics, data sciences in particular, to the undergraduate and postgraduate science and engineering students. Sir is also engaged in research activities in areas related to computational physics, cognitive science, material science, and astronomy and astrophysics. Besides coordinating the efforts of the university to uplift itself to greater heights in quality and performance ratings, Professor Saikia is also steering the activities related to digital, online, and skill education, being the university nodal officer of SWAM. So we welcome you to the session and we look forward to get your experienced insights so that we are able to learn good lot of it so that we are able to apply our learnings in the days to come. Over to you, sir.
Thank you so much for the introduction given. And yes, today probably my intention is to share whatever ways and means we have been applying to do whatever little bit of research activities myself and the team I am assigned to guide and collaborate also with some of my colleagues in the campus and off the campus. What we have been trying to do, I just would like to share with you. Hopefully, that would benefit your activities. Over. So, see, may I know about the audience, the profile of the audience? Is it all the research scholars or it is faculty members who are engaged in research? Is it that way?
Sir, we have faculty members who are PhD as well. So basically, it's a combination of research scholars and faculty members who wants to know about R.
Okay.
So we have a combination of them.
So my assumption is that everyone is using data and everyone is trying to extract the information stored in the data in whatever form. Someone might be getting the data in the form of the experimental data or simulated data. So data needs to be analyzed. And yes, yesterday when I received that the banner, the poster, I saw that the session, previous session, you have had some hands-on also on some machine learning tools as well. So my assumption is that you are by now. This is the fourth day you have told me. So by now the participants are familiar with the introductory stuff. So I will skip those things. I will be focusing little bit of hands-on. If all the participants are ready with your laptops and desktops and either Anaconda or RStudio, whatever way you are having it. I don't know what platform you are using, but RStudio, not the latest, but before that, maybe the earlier version. One of the earlier versions would suit the requirements. But to start with, I would like to know from the participants if there is any specific requirements so far as your research, the area where you are engaged in, and what kind of data you handle. May I know about your research activities?
Participants may write down in the chat, or if you want to unmute yourself, that can also be done.
Or about the participants, you said? Ma'am, you said about the participants?
Yes, sir, participants. They can unmute themselves
You
or they
can
can
unmute
wait.
yourselves and you can speak. You can speak. Anyone can start. I mean, I just want to know what kind of data you are using. And R, Python, whatever software you are using, that doesn't matter much, but what kind of data? And what kind of analytical process or framework you use normally? Am I audible?
Yes, sir, you're audible.
Okay. Participants are there, I can see.
Yes, sir, there are 25 plus participants.
Yes, 25 plus. Yeah, come up. I mean, it's okay. I mean, see, whatever you are doing, just to make this session meaningful for you. That's why I like to have this initial information. That's it. Even if you have just started your work or you are already a veteran, like you have been handling data for quite some time, I just want to know health related data, okay, of stroke disease using R. Okay. So health related, maybe you are talking about may not be time series, but images also. You use images. For example, we use brain signals, EEG signals. One of my PhD students, I will see if his work is there. Okay, let me start with that only because I am not receiving. Yeah, I don't have one more chat. Let me check. Okay, only one response till now, health related data of stroke disease. Okay, so let us start with that only. As I have received, let me see first if I have that student's results here. I would like to share with that. There is no harm because he is already awarded. So let me check Pallav's research. We have been using EEG signals, okay, electroencephalogram, and he did little bit of modeling. PCA, probably some of you are aware of if you have been handling data, principal component analysis. There is another not version but another variant of this component analysis, that is dimension reduction technique, that is called independent component analysis. So he used independent component analysis, not PCA, but because there are multi-column data, I mean, there were many variables, attributes impacting on EEG, electroencephalogram. That I would like to show, and why modeling was important there. Let me figure out if it is there. I am not sure though, because that was not in my agenda right now, but let me start with that. That will be interesting. Hopefully it is there. Confirm. This, okay, let me ask you if, is there anyone who is doing modeling also? Do you do the participant? I'm sorry, I didn't pick your name. Do you do modeling also in health related data? Because that was my plan today, to talk about the modeling also. I won't be doing this is not meant for simulation, but though you do simulation also, today we are not discussing simulation, but modeling part, that I would like to focus, that I would like to touch upon, at least not focus, touch upon modeling part. So that's what we are starting. See, I'm sorry, I don't have the digital slate. Digital slate was there, somehow it has been misplaced, and now I don't find the digital slate. See, modeling is needed when the data is not there. Till this moment, I have the data, but I need to forecast for next 5 time steps, 10 time steps. There I need to go for modeling, right? But if I have data, but in between there are some missing values. Normally, what we do interpolations, right? That is interpolation. Simply you do linear or non-linear or of higher order polynomial interpolation, spline. All the techniques are there now, and you don't need to do any programming, any coding. In our times, we used to do separate program for that, but nowadays you just menu driven, so you just click on the tab and it does for you, so you need not to worry how it happens. But it is always good to know what statistics actually it is done. Suppose so that's what I'm saying. You have data on this side, you have data on that side, in between you don't have data. Let me share my screen. There you do interpol. Hello, am I there?
Yes, sir. You're audible.
Yeah, ma'am, you have to keep telling that I am not alone, because I don't see my why this is not showing up. This is not showing up. Okay, let me share again.
Yes,
Okay,
sir.
let me just
We can see your screen, sir.
okay, thank you. So this poster is visible, I guess, the forecast from Arima, this part.
Yes, yes, sir.
I mean, is the size okay, or I
Yes,
should
yes,
be?
it's visible. It's visible, sir.
Oh, this is the maximum limit, I guess. So, yeah, I think I can switch off this camera. Is it needed? I don't know.
So it's okay. Sir, it's okay. You can switch it off. No problem.
Yeah, because of maybe network
bandwidth
may stop that happening. I mean, I don't want to get disturbed that way. So yeah. So see, what I was telling you is, suppose in between I don't have any data. This is just a time series, for example, and time series means for 500 minutes we had some data. EEG signal, electroencephalogram. This was a 16-channel EEG machine we had. That time we had access that time. Now we have an access to a 32-channel EEG machine, but that time it was 16-channel. And these are the voltages. EEG signal means it is a voltage between two different electrodes put on the head, right? Now the respondent. So what I did, I told Pallav, my student, that I don't have data after 500 time step. After 500 time step, this data, I didn't share with him. I said that I have data till this, 0 to 500 I have. You just try to figure out, do some ARMA modeling. Some modeling, we will discuss it later. Do some modeling and tell me what is going to happen after 5 steps, 10 steps. Okay? That is what I wanted him to do. See, what he did was, oh, it is not there right now. In this poster, it is not there, but in detail, we will see. Initially, as usual, research scholars are in hurry. So what they did, he just did a little bit of exercise, and he shared with me the results, and it showed up that it was going down, and it was going down further. After 500, the trend was going down. You can see this is the 500 times it was going down. So he told me that it is going down. I said, no, wrong. It is wrong because I had the full set of data. So I knew that it is going up again. So he said, it is going down, sir. I have done it twice. I have done it thrice. No, I still say that, no, your modeling is wrong, and work on it. And you need to find out the time step, at least for 5 time steps. Don't go for 10, 5 time steps, find out. So he did it again, and next time he could come up with this upward trend. In the next modeling, he could come up with this model upward trend. That was test number 1. I did on this data, on this modeling, what my student was performing. And I also wanted him to regenerate all the previous data points. That means the whole time series. And that also he could do. This is also forecast. Okay. So he could do that. So, but unfortunately, what happened? He could regenerate this, but later on, after going here, he saw that upward trend, while after 500 time steps, suppose, it was going down again. But see, when you do little bit of customization of the set models, suppose you have a model where in cloud you just drag and use it there, that should not happen. The R has got that facility, but nowadays in Python, when people are using, students are using, what they do is the toolboxes are there, the ready-made, they ask in the chat GPT, they get the script, they just run it in the Jupyter notebook, and they get the output. So without getting into the details, if you are using it as a black box, so it is very likely that erroneous results are there, and you end up reporting those erroneous results. But that is one thing I like about R, that here, if you want to do ARIMA, is this RStudio screen shared? Can you see my RStudio screen?
So it is still that PDF. Methodology and other. Yes, now it's shared.
The RStudio screen?
Yes, the RStudio screen.
Okay. So I'm sure all of you are familiar with this RStudio GUI, that is the RStudio. When you just open up, you have been working on it, I'm pretty sure. Now suppose you just go to the computer is already slow. This is the one which is getting used for my classes here in this lab. I am in my lab only. It is taking time. Anyway, so suppose I want to know about ARMA, or he used ARIMA, right? So ARIMA. This is nothing but auto-regressive integrated moving average modeling, ARIMA. You have other variants like F-ARIMA, functional ARIMA. So it tells me where I can go, which packages I can use, and which one is to be used for that particularly. So in stats, in TSA, right? This TSA is a better one. We have figured out time series analysis package. Suppose you just look in the tools, go to the tools. Suppose you just find out if the TSA is there. We have a TSA. So if it is not there, you can just install and load it. By now, I'm pretty sure you know how to install, how to load If it is not happening directly, you just go to Google and get the zip file and bring it to your local library directory and just unzip is there. And from there you just load it or install it, right? Instead of loading it. Are these steps done? Are all the participants are familiar with that? What I am talking about? Can anybody validate my statement that you have been using it? For example, install packages. That is how you have been doing, isn't it? So either you get it from the repository, or if you have downloaded it from the online sources, just package archive file. Okay, so go get it there and either browse it. If it is not there from this repository, you go to that in C. You go to your file, your R directory, and then from there you can do it anyway. So normally it happens from there only. In C and repository, you can just install it if it is not installed. Okay. Now in our case, it is there. TSA is there, so it gives you the details how to use it, right? So there are some inherent data. You just install it. It does the I mean modeling part. It does, right? So but what is important to understand is what is ARMA modeling, right? Integrated modeling, how it happens, what is it? We will go to that, but that is one part. Before we start, I am trying to give it to you or share it to you so that you know what the output we are talking about. What is the requirement? Why we are into it? I don't know why this screen is not showing up again. I mean, yeah. Why? Suppose I don't have data at all of this time series. We go for the simulation. If I have data up to a certain point, beyond that I don't have data, we do modeling, right? And suppose I have data on both sides, in between I don't have, we go for interpolation. These are the three things. This modeling is most prevalently used by people because of the forecasting. We like to do forecasting. Now, this forecast is itself is a part of this tool. If you just go there, and instead of ARIMA, you just see forecast. Forecast is one of the packages. In the packages, you just browse through. You just browse to and tell forecast. Oh, I don't have it. Yes. And there is a tool also, but I just wanted to see if the forecast itself is there. Forecast is there, okay? This is there. Suppose I just load it. I'm not sure if it is working now. Okay. Okay. Forget about these warning messages, but forecast is loaded now. So here also, I am pretty sure that ARIMA and the top plot is there. ARIMA is there, okay? So so you can play with it. You can just go through this documentation and just implement it. You can implement it using these toolboxes and following these steps. If you need the details, how it happens, You just see his Hindman's publications. Unfortunately, here details are not given, but just copy and paste it in Google, you will be finding the details, right? So this auto-arima is important. Why I am showing this auto-arima? Now I remember that ultimately I asked my student to run this auto-arima. So what it does, how it happens, automatically how it does, with arima, why he was not finding the details, those nitty-gritties, he could understand only when automatically this toolbox, this particular toolbox was doing a run, changing the variables, controlling variables of that model and giving the best model. See, how to judge whether the model is a good model or a bad model? There are certain coefficients. Akaike index, mainly, or Bayesian index, right? AIC and BIC. Many of you might be using them also. If the AIC suppose there are 5 models, out of the 5 models, 5 AICs, the least one will give the best model. Okay. Akaike index. What is Akaike index? How to find it? Just type and find out. That is how you do it. Now, this is one aspect I would like to complete first. I go to my normal data. It's not there. Yeah, it's there. Okay. I can find that. Where is it? It's not showing up. I don't know why. It should show up. Okay, you have heard about PCA. I can see your message now. It is better if you can just unmute and speak out. It will be better. But now I'm struggling to share my another screen. It is not happening with me. There's not sure why it's not happening. What is the problem? I have. Is it visible now? Time series analysis?
Yes, sir, it's visible.
Okay, thank you. So see, I mean, all the ways how to do these things are there. I can share these write-ups later as well. but yeah. See, suppose I need to know the dependent variable at the time instant t, right? And we know this value of the dependent variable at the time instant t is a function of the previous value. That is the value of the variable at t minus 1, value of the variable at t minus 2, t minus 3, t minus p, right? And it can go on and go on. And also there are errors, right, in the estimate at the instant t, at t minus 1, t minus p, because errors are getting accumulated, and this sum up of the errors, the epsilon here are denoting the errors, and these coefficients phi 1, phi 2, phi p, these coefficients are controlling the importance or significance of the previous value on the latest value. The value at t I need is a function of this, and whether I go to the most recent or up to the 10th one or 100th one for that matter, that will be dependent on the requirement. First thing is requirement. Second thing is the capability, the computational capability of your machine, as well as the stability of the scheme you are using. That is also important. So suppose for the time being, we are assuming that this P is 3. So you are saying that as an example, what I am today is dependent on my father, my parents, my mother and father and their parents, that is my grandparents and their parents up to third generation. All right. My existence is dependent on them. But at the same time, that is also true that there are certain uncertainties in the estimates that are made. So these uncertainties are also showing up in this equation when I am analyzing or I am predicting now t plus 1. Suppose I need to predict t plus 1. Obviously, that t plus 1 will be a function of t, function of t minus 1 and function of t minus 2, isn't it? So my job is to find out phi 1, phi 2, phi 3. And here theta 3, theta 2 and theta 1. Thetas are the coefficients of the error terms and phi's are the coefficients of the previous values of this variable, right? Whether it is my cognition, my some biological attributes, my IQ or EQ, whatever you call it. So whatever estimates data is pertaining to, related to that, this dependence, that is the dependence on the previous values as well as the error terms at that instant of time, come together to forecast or to predict the next value. This is the crux of modeling. Whatever modeling technique you use, now that will be important. But the first step is to establish that the present value of that attribute is a function of the previous values and the errors, successive errors, right, that are accrued, that have come up to give the gross, the net, all right, and till which previous time step we go, that depends on the capabilities of the software, the requirement, right? So you may go up to 10th. We have gone up to 10th. The poster I showed, we went up to 10th, in fact. Now, in ARMA modeling, autoregressive and moving average modeling, what it is done? There are two coefficients. One is ACF, this ACF and PACF, autocorrelation function and partial autocorrelation function. These two functions are controlling those coefficients. One set of coefficients are controlling these phi's, another set of coefficients are controlling these coefficients thetas, all right? ACF and PCF. Now, I would like to show the ACF and PCF if it is there. Oh, it is not there. Okay, let us share that. It is not there. Okay. Yeah, I can just show it from here as well. Can copy and basically. Can you see my R Studio slide?
No,
Is,
sir.
is
No,
no? Oh, I'm so sorry. I was doing there. I thought that it is shared. Oh. Is it visible now?
yes, sir.
Is it visible? Okay, thank you. See what I have done. I have there is a you know, probably ggplot. This is the plotter. I have loaded that. Then I am trying to. There is a air passenger I mean data set available in R already. I am using that data set only because I cannot find what Pallav did for his work now. So I use that. So now it is fitting. Fit the model first to few years of air passengers data. So it is doing it. I mean, it is taking the data. Suppose the data was there. The original data, the black one, and it is the fitted data after modeling. So modeling is doing good. I mean, it is predicting the values. So suppose we do not give up after this 1956 and 1957. 1950 after 1957, if we do not give this data right to the model, and then we ask the model to give these time steps, what is going to happen from 1957 to say 1962, it would have given me these blue colored peaks. All right. So when I uh, try to tally it with the existing data, it shows up that almost it is mimicking, reproducing what actually it was, right? That is what it does. Suppose it has given me all the necessary information as well, which one is to be taken. And you can see these ACF values. These are correlation values, and it tells me, see if it is, nah, this is the last one. Okay. I don't know why. Okay, let me show you what is where I can run the ACF, right? Autocorrelation function. If there is any say no, in forecast only. ACF is there. Okay. So it is doing it for it is WinN. Okay. So let us find out what is this. No, I think it is okay. No, so hopefully it is not going to give me some error. Let me check. Oh, it is running. So it will tell me. It has given me some PCF, PACF, partial autocorrelation, and ACF, autocorrelation function. Now, suppose this is basically the strength of the excuse me, there is a phone call. Okay, so it tells me up to which time step, I mean previous time step I can go, I should be going, right? For this data, uh, the data I have, is it redundant to go up to fifth, to go up to 10th? Yes, it is. Suppose you know that this peak is there, this peak is there, this peak is there. Later on, it is all zeros. It is coming up to zeros. So maybe I can go up to, this is the present one. Suppose I can go up to 3, right? So same is the case with the PACF. Here also, suppose there is a threshold, so I can go up to this. So better to go up to third point maybe. There, otherwise it is all redundant. It is of no use. It is just you are just spending time and computational resources for the modeling. So there is no use as such. Other time factors are not impacting. Just like you and me, after the third generation, fourth generation, we are not much dependent to our forefathers. Till third generation, yes, we need to know. We need to be careful about the traits, the biological or social traits or emotional traits of our forefathers. But beyond that, maybe it is not that impactful, influential. All right. So PACF are telling me the moving average part, right? And the coefficients where P and Q's in this, when you go to that again, the packages, that is health file, if you see in the forecast, in ARMA, only ARMA. Okay, ARIMA is there. No issues. So in ARIMA also, out of the sample. Okay. Would have. I don't know why it is not doing what it should have been doing. All the screens somehow, probably I have done some mistake, I don't know. I have. Just give me 2 minutes. I think I just want to show you. Yeah, let me share. I don't know why it is not happening automatically. It should have been happening automatically, but it is not happening automatically. I made it to show up automatically. It is not happening. Okay, so this is a time series. Okay, so yeah, this is an ACF, autocorrelation function, which have been calculated or estimated by forecast, for example. And now it shows up that this is the threshold, and above the threshold just one is showing up. So this tells me that I can go up to the first coefficient, that is phi 1 and theta 1. That's it. So only my previous state is meaningful. But to be in the safer side, I can go up to second. That is phi 1, phi 2, theta 1, theta 2. That is, if I need to predict t plus 1, I can go to present state, that is t minus 1. And maybe maximum t minus 2 up to that. So what should be the p value? It should be 3, and q value maybe 3. But from 3 to 3 in p and q value, when you call there, initially when you call there, I am not finding it helpful. It is always good to have offline actually that way. I prefer the offline that way. Now I cannot write here as well. Yeah, this is another example here. Maybe you can see that there are two forms coming up. So AR2 in the parenthesis you are writing 2 means you are going up to the second one, right? Is here for AR2. So when you are saying AR2, your PACF and MA, moving average, see, when you will be calling it, when you will be invoking AR, only AR in R Studio, or using that in the command prompt, it is going, it is telling me which time step, I mean, the dependence up to which time step, t minus 1, t minus 2. So this p denotes to that time step, t minus p. You understand? So suppose I am saying 2, AR2. AR2 means it will go up to here. My present state depends on my last state as well as last to last state. These are the two states. When I say p is equal to 2. In Pallav's paper, probably you observe that it is written p and q, the values are there. If I can share it again, I will show you. I'm not finding it helpful. It's all gone again. Can you see it now? The paper again, the methodology forecast. Again, I am alone, I guess. Everybody is sleeping. Hello. Anyone confirm, please? Hello.
Yes, sir. Hello.
Yeah. Someone is there?
Sir, hello. Am I audible?
Is it? Yeah, you are audible,
Okay.
but your voice is breaking. I mean, there is some. Yes, this screen visible again. That is, we are showing the forecast from Arima. Is it visible to you?
It is visible. Yes.
Okay. In the parentheses, there are three numbers written: 0, 1, 3. Right. So this is 2, 0, 3. So this is the PQR. Okay, P value, Q value, and in between how many integrations are there. ARIMA is auto regression integrated moving average. So these are denoting those. So how many time steps I would be doing for AR part, auto regression part, how many time steps I will be going for ARMA part. For AR, I will be getting up to third. For moving average, I will be going up to second. So that is what it is saying. When I do it, it will be giving me this result. Okay, suppose here I showed you here, if you are writing it AR within parenthesis P means which time steps. Suppose there we showed 2, 0, 2, 0, 3. So you are writing that AR3, right? AR3 here. So you are going up to the third one. So when you execute that, and when you are doing moving average up to third, the moving average means PSF, and okay, so yeah, so ACF and PSF. So suppose there is one showing up, so you go up to one. Moving average RMI is up to one. First time step, that is, you need to know the next time, the value for the next time step. That depends on the last variable, the value of the variable of the last step. That's it. Not going beyond that. So in the case of ARM ACF also, you can see after a second, maybe, yeah, after a second, it is going down. So you can say that the second term is important. You will be going from moving average up to second. But ARM AR auto regression up to just first. Okay, so that is how you decide those values in the PACF. And what I was telling you was that it has to be done for all the permutation and combinations and figure out which is the best model depending on the AIC, Akaiki indexing. So that AIC tells me which model is the best model. The minimum value of the AIC will tell that that is the best model, and that is how the moving average is effectively integrated with the auto regression. And not only as it showed up in that again our studio is lost, I don't know. does that? So, so you can see here the partial ACF. It tells me that 1, 2, 3. Again, it shows up here. So these are the lags, time lags. That is, lag means up to 12 time lag. You can go. You should be going, in fact. The present state depends up to 12 lag. That is t minus 12. P value is 12 here. It is showing up. And for autocorrelation function, it is showing up that it can, here it shows that up to 24 it is showing up. See, the time lag. So that is how you decide, and doing that, it is doing the forecasting up to 12, right? With the different sets of values for the PQ, and then it is being able to reproduce. Even if you can see in normally, probably you know that if there is a trend visible, that trend needs to be detrended. We call it a non-stationary time series if the variance is changing with time. But whether there is a trend or not, that needs to be checked as a step 1. If you are doing time series forecasting, that is, forecasting is modeling. If you have to model it, first this needs to be detrended. So this is detrended already. Even if there is an apparent trend, it is going up, but it is detrended. Don't worry about that. After detrending, whether it is a stationary or non-stationary, how to check? Can anyone tell me how to check whether it is a stationary or non-stationary? I am pretty sure by now, this is the 4th day, you must have come across this issue, whether the time series is stationary or non-stationary. Can anyone tell me, please? You can write it on the chat box also, when the time series is said to be stationary. First, let me confirm, is this screen visible? The RStudio screen is visible to you? My question is to participants, all the participants. Is it visible to you, please? Could you please confirm? No, sir, no images.
Yes.
Okay. So our studio screen is visible. Now tell me whether this time series which is showing up after modeling, which is showing up on the screen, is it a stationary time series or a non-stationary time series? You can write it there also.
So it's stationary.
No, I don't see only one response here. Only one. Stationary. So just looking at it, can you tell if it is a stationary or non-stationary just by observing it, or you perform any test on it? See, again, I tell you, stationary, we call it a time series station, call the time series stationary if the variance is constant with time. It is not varying with time, the variance. But if the variance is varying with time, the time series is non-stationary. Yes. So how do you know? And there is this trend that appears to be a trend here may not be a trend. It may be a natural tendency. I mean, it is not artificial. It is naturally it is happening like that. How to check if the variance is changing with time? Variance is the spread. If you are talking about a Gaussian, how much is the spread from the mean? Right? That needs to be checked. And the best way to check is you just need to do Dickey-Fuller test. Are you aware of Dickey-Fuller test? Have you done it during this workshop? Dickey-Fuller test. My assumption was you have gone through, you have done all this. This here you will be finding as ADF, augmented Dickey-Fuller test. You just go to help and type. ADF is not there. Why? ADF. Dickey-Fuller. ADF test. Okay. In time series, T series, in the tool in the package T series, time series. Okay. So if the T series is not there, just install. Okay. You can install it, T series. You can find the augmented Dickey-Fuller test. What it does, it computes the augmented Dickey-Fuller. Okay. It will test whether the time series is computed, the p values are interpreted. Okay. So it tells you whether your time series is should be when you grow with the sample size for general ARMA setup. Okay. Before doing ARMA, you are supposed to do the test because non-stationarity needs to be made stationary, right? Trend should be done. So here also you can just test it whether it is a suppose I do y is equal to, I don't know which means way find. Okay. So let me see if it works. This is a normal, this is a random number generated first. 1,000 random numbers are generated. So it is doing, let me try here itself. And it is asking if it is a oh, because time series is not loaded here. T series. Okay. It has done. Okay. So it generated a random number and then it is checking it with a p-value of this. P-value is not very good. So still it has said that since Dickey-Fuller, I mean, this is up to 9th, it has seen and it says that it is a stationary for that random number. Right? So for this data. Okay. So if I go back to help, what it has done, it has taken this data and it has done. I don't know in the Winfield data if that is possible here. It is possible, but to show it here. Okay, but my idea was different. My idea was stationarity is tested, and even if it is non-stationary, you can detrain. There is a function called detrain. You can just detrain it and detrain the existing non-stationarity will be taken care of. After that, you have modeled it and it fits into. This is forecasting, this is modeling. Okay, now we would like to go for another important aspect of it. I am not sure if this ARMA or ERIMA or F-ERIMA, functional ERIMA, is already used by you. I'm not sure, but if you plan to use it, you'll find that there is enormous possibilities of ARMA modeling. Particularly, the core is ARMA, and which fits into any kind of data, whether it is data is coming in the form of survey reports. You have generated some variables, and from there you need to do predictions, or it is a lab generated, actually experimental generated data, or simulated data. In every level, at every different possibilities or requirements, this fits into, right? The core is ARMA, but the variance may be different. So any one of these variants will fit into the requirements. So it is very, very strong and powerful tool for modeling. So you should be having some experience with it to decide on the P and Q. Right? That is one aspect of it. But another part is, suppose you have the data, you have done the preliminaries. The first thing, in case of a time series or any image data you have, the first thing you do is a cleaning, right? You need to just clean the data. And once the cleaning is done, that is, you have got rid of the unwanted, the white noise or other noises, and you have taken care of the missing values, then your data is ready for the analysis. And then we are not discussing here the descriptive statistics part, but if you are doing time series analysis, that is a part and parcel. You will be having it just at the click of the mouse. You just get the summary of the descriptive statistics. What is the mean? What is the median? What is the QQ plot? Even QQ plot, quantile plot. So that up to that, it gives you whether your data has got a Gaussian distribution and whether t-test can be performed. If it is a Gaussian distribution, if the QQ plot gives you a kind of a y is equal to mx, that is a straight line with intercept 0, then it is a perfect Gaussian QQ. Okay, then other generic test can be performed. Okay, that part we are keeping aside, but we are focusing on another aspect of it, maybe new to you again, just like ARMA, because that is what came to my mind when I was asked to share how we were doing this forecasting. Just recently, our another paper got accepted, and it is related to geology. So particularly the core area was geology. There is some chemical decomposition happening in the minerals of that particular stone in that particular geographical area, and we are supposed to automate this process using some ML models. But whether it is machine learning model or NI models, I call it NI models, normal models, or natural intelligence related models, the typical conventional models, the basic requirement is the statistics part. whether you are using conventional statistics or little bit hybrid model, some nonlinear dynamical theory related parameters are incorporated into the conventional models. That part I am going to share now with you. So hopefully that will be beneficial. Let me share. Yeah. This was an earlier paper. Is it visible to you?
Yes, sir, it's visible.
Thank you. So, see, probably all of you are by now you have already had some hands-on session as well to do some Fourier transform analysis and power spectra. These are plotted by you already when the time series is given to you, right? You are all familiar with Fourier transforms. Why Fourier transform is important? So suppose this is a time series. Don't worry about the source of the data. That is, we do a little bit of astronomy, astrophysics also. So this is pertaining to the solar sunspots. I mean, we wanted to predict by looking at the sunspots, the data we have, we wanted to predict if there is going to be some geological storms in coming days. And we could do that. And that is the time series we had in this case. These are the parameters, DST index, PC index, these are the different index, KP index, AP index, these indices coming from the solar wind, SW speed. So they are the parameters. We got this data from the archives of NASA, and but most importantly, this reproduction was important for us. We could reproduce. Probably you can see the blue and the red lines. One is the reproduction was when moving average, only moving average was done, right? So we wanted to confirm first step one after cleaning. This is the prerequisite. I am telling it again. Cleaning, taking care of missing value is the prerequisite. That part is already done. That is my assumption. After passing through that phase, you just when it comes to forecasting, you just need to ensure that your model is reproducing the data already exists, isn't it? Then only you just apply it to predict next few steps. That is how we did it for different indices. When we were sure that, see here, this peak was missing. Okay, in the original time series, this black peak is there, but our reproduction, there is a peak, you can see, but it is a little bit shifted here. So this happens. This is a general trend in modeling. When the peak is relatively abnormal, I mean higher or lower in modeling, sometimes it leaves it as an outlier. Okay, that is a dangerous part of it. Also, we need to take care of this issue. There are certain ways to do it. You just break this time series into 10 pieces, then do one at a time, then that is taken care of. Okay, there is a procedure. But here just I wanted to show it. It just appeared to me. That's why I am pointing it out. But there is a peak, but a little bit shifted. But the rest of the peaks are coming in position. So that's a good sign. Now it comes to prediction, and these sunspots can be predicted. But I am not interested in that part. I am interested in something else now. The correlations. See, why you do Fourier transform? Can anyone tell me? What is the utility of Fourier transform? Hello. Again, I feel I am the lone one here.
Sir, your auditors.
Okay. So, can anyone, whosoever is there, can anyone tell me Fourier transform After the time series is there, suppose as I showed you, this is the time series. You perform Fourier, this is sunspot number, and these are the days. Okay, from January 1st to 31st March, you have these days, and this is a time series, and these are the observed values, and the model you have designed is being able to reproduce the pattern, the trend, right? So safely you can use this model to predict. That is fine. After doing certain process and following certain procedure. We are not going into details, but now my question is, can you see a trend here? Can you see a period here? Is there any period here? Or if I have a, these are the days, years, suppose I have some years. I don't have it. But don't worry. You can just see that time sunspot number. Okay, sunspot number. You can just Google it. Sunspot number for last 100 years. Just type. And look at the images, right? Suppose, where is I cannot share. Okay. I thought that it is coming up, showing up easily, but okay. Maybe this. This may be the first one. Can you see this, please? Can you confirm?
Yes, sir, it's visible.
Okay. So, I mean, is there a period? Can anyone tell? So these are the sunspot. Actually, the number of spots, black spots on sun surface keeps varying, but that variation you can figure out from these years. See, from 1900 to 2000, you can see some pattern. Okay, it is going up. The sunspot number, annual sunspot number in the y-axis, it is going up and coming down, going up and coming down, going up and coming down. If you take any two peaks, nearby peaks, you can see. So it is 10 to 11 years, between 10 to 11 years. Suppose maybe this. Okay. So this peak is 1938. There is a peak 1938. There is a peak here 1948. Okay. Can you see that? And here also you can see 1927, 28 around. There is a peak showing up here. This peak is lesser than this though, but you can see these peaks. And if you look at the dips, 1934, 1944. So between 10 to 11 years, normally 10.5 years, there is a variation. So we call this kind of a pattern to be periodic. And the periodicity in our case, in this case, is between 10 to 11, that is 10.5 years, right? That is we call it a solar cycle. It is a solar cycle because sunspot number is varying every 10.5 years. That is the solar cycle. Okay, so going back to that again. This paper. This periodicity, we do Fourier transform on a time series. We apply Fourier transform on a time series to figure out if there is any periodicity. And if there is any periodicity, then in the Fourier transform, it shows up as a single period. Okay, there is a frequency. Only one spike will be there, and that tells. Suppose you have a sine function, and the periodicity is of some 30 days. 1/30 days is the frequency. So in along the x-axis, you get a 30-day period. Okay. Suppose now is not there. Okay, so let me show you, because I am not being able to access my lecture notes I use for the classes here. Is it visible, this series? So this is the series, suppose, time series. There is a signal. So in the Fourier transform, when you convert it from the time domain to the frequency domain, there is just one peak showing up, okay, in the Fourier transform. So but again, if the function is like that, you will be getting a Fourier type. The periodicity is of that kind. Gaussian appears to be Gaussian, but the point is that that there exists a frequency, the periodicity is there. That periodicity is that at one instant of time, it is, you are not sure if it is sustained. If it is sustained for the whole time period, it is sustained. You are not sure. Like in the sunspots case, you saw that you saw that there is a periodicity every 10.5 years. That is for sure for last 100 years. But here, if you find out there is a peak showing up in the Fourier transform, and you are not sure that if it is sustained, the best way to do it a two-dimensional Fourier transform. Two-dimensional Fourier transform means you allow the time to progress along the x-axis and you keep plotting the frequency along the y-axis. And when you do it, what you get is wavelets. These are the wavelet of the time series you use. The solar sunspot numbers, the time series we use, these are the wavelets of those time series. These plots. Is this visible to you? These plots? The period in days are there in the y-axis, and the time in days are along the x-axis. Is this visible to you? Because we are going to discuss on this, the correlations.
Yes, sir, it's visible.
Thank you for confirming. Yeah, so this is the period, that is 1 by period is the frequency. 1 by period is the frequency that is being plotted and along the y-axis, and the time progression is happening along the x-axis. So now in this picture, the red, in the color coding, you can see the red tells me that these are the highly probable areas, days where the periodicity, that is the periodicity, is sustained. See, so this period, for example, 24, 16, and between 20, this is another 16, 8, so 24 days. 24-day periodicity is very, very dominant because the color is red, powerful, so it is there, this period. So over a longer time period, number of days, this is being repeated, okay? Till March to May, March 76 to May 79, the data was plotted, okay? 1976, I guess, okay, to 1979, this was plotted, and you can see that 24-day periodicity is there. Then you have got this periodicity as well, 64-day periodicity is there, okay? In Fourier transform, you would have seen only one peak for this 24 days, one peak for 64 days, one peak for 128 days. These 3 peaks will be there. The maximum height would have been here, lower than that, but these two would have been of the same height in Fourier transform. But you don't know who is a stronger one, who is a weaker one. Here you are sure this is a stronger one, this is getting sustained for a longer duration. So you pick this to be the sustained one. Okay, so this is in 21 cycle, that is from 1980. So this is in the rising side. Rising side means when the number of sunspots are increasing, this is declining. When the sunspots are lowering, even there you can see 24-day periodicity is there intact. Okay. Now we just want to find out that period and average cross wavelength power, that is this power. And you can see that what I was telling, this is 24-day period showing up prominently, but these periods are also there. 64-day period is also there, right? And these are the confidence level that what you are saying is statistically important. It is not just by chance. Okay, it is statistically important with 95% confidence. The red ones, 95% confidence you are saying, and the black one with 90% confidence you were saying. Okay, so with 95% confidence you are saying this 24-day period is a prominent one so far as the periodicity is concerned. Okay, so same is the case here. It is also in the declining, rising, declining in both the phases. This is showing up, but the declining phase you can see more power. You can see more power in the declining. Okay. And you go to the next level now. You want to see if there is some phase locking happening. Phase locking happening means when periodicity is there, that is something is getting repeated in the system, you are sure that there is some intelligent system is working in it. There is some science happening in it. It is not random. It is not stochastic. That is for sure. If it is periodic, okay, that part is done. Now, whether the coherence is there. Coherence means constant phase difference. That is, whatever difference was there initially, that remains intact. Okay, whatever relationship, because the sunspots are happening because of some internal physical changes beneath the surface of the sun, right? And these data you are collecting not from the surface of the sun, but from the atmospheric, terrestrial atmosphere, that is geomagnetic indices. These are the geomagnetic indices, the indices I showed you initially, sunspot number and other numbers. You want to just relate this DST, for example, or this AP index with that sunspot number now. You want to correlate, you want to figure out how the geomagnetic AP, these indices are estimates from the terrestrial environment, right? Using balloons or satellites. But sunspots are happening on the sun surface. What is the link up? What is the relationship? What is the correlation? You want to figure out. That is what we are trying to do. And to do that, you want to be double sure that it should not only be powerful, but it should be, this is showing up, this is powerful. In comparison to other time periods, there are variability with other periods as well. That is there. But this is the most powerful. But whether it is sustained, right? If that is getting sustained, yes. These areas, when you're plotting, these areas are showing up. Yes, this is important. So this, in this case, 24-year coherence, when you are looking at the coherence, that is, you are plotting the cross wavelet. Wavelets are two-dimensional Fourier transform, which is telling me CWT. These are the continuous wavelet transformations. So these are telling me that there is some CWTs, continuous wavelet transforms, are telling me if there is periodicities, and if those periodicities are periodic variations are there for a certain duration of time. That is ensured first. Next, you are looking at the correlations, that is the relationship. These are the cross wavelet between two time series. That is one periodic sunspot number, another periodic event is happening, this AP index, DST index, that is the geomagnetic. How these two time series, one from coming from the sun, the cause, the source of the geomagnetic storm, and other is coming from the terrestrial environment, the effect, cause and the effect, that is in the form of geomagnetic storm, it is showing up, and the value of the index, the numerical value of the index is changing with time now. Now, what is the relationship between the two? The best way to perform this is wavelet analysis, wavelet transform analysis, and we perform the cross wavelet, and in the cross wavelet analysis also, it shows up that the 24-hour period is there, and that relationship, that they are correlated, that correlation is sustained. With 95% confidence, you can say that this is there. Okay, this is showing up, this is showing up, and in the declining phase, there are some more coherences appearing. In the x-axis, you are plotting average coherence. It is showing up that the higher periodic events are also there. These are also there, and if you go a little bit deeper, you can relate it with some physics. We are not going to do that discussion here, because first thing, that is not needed, because we are doing data analysis but not astronomy or space science here. But otherwise, you can relate now why that's showing up 24 days, 27 days, not 24 exactly, actually it is 28 days. 28 days because of the lunar cycle. You know that the lunar month is of that period, so it is 27.5 or 28 days showing up here. And then double it, 54 days is showing up here because of the presence of the moon nearby the earth. That impact is also showing up here. Okay, so the point is the cross wavelet power, as they are showing up, how now you can be confirmed, it can be confirmed that it is happening in all the cycles, 23rd, 24th is happening till the latest one, that is 25 is now presently we are in the 25th cycle. So till 24 cycle, you can see those powers are there, but additional powers are, additional periodicities are also showing up, but nevertheless, those are showing up. That is, the some periods are showing up in all the cycles. Where what you have done, you have tried to see the correlations between two different time series coming from two different sources. One is solar, another is terrestrial, and you are trying to link up the source and the effect, right? And to double check it with conventional statistics, you are using the dimensional analysis, as well as this is the fractal dimension. As I told you, these are the dimensions you are using from nonlinear dynamical theory. See, fractal dimension is nothing but, in a simpler term, I can tell you, when you are just folding it. Let me use my video. Okay, suppose you are folding it. Can you see my? Suppose you are folding this booklet, right? This is a two-dimensional. This is a booklet, two-dimensional. You are folding it. What is happening? What is the dimension now? What is the dimension now? Can anyone tell? Now, what is the dimension now? Suppose an ant is sitting on this booklet. When I am folding it and I am trying to make this cylinder, what is the dimension now? On the curved surface, he is sitting. The ant is sitting. Everybody is sleeping. Hello, all are sleeping.
No, sir, we are. You're audible, and we are not sleeping.
Okay, then please respond. So ant is sitting. I am just folding it. When it is not folded, can you see my? Is my camera working?
Yes, sir, it's working. We can see you.
The ant is there. It is two dimension. Now I am folding it. When it is folded, it is three dimension, isn't it? This is three dimension because it is a cylinder. Now, what my question is, when you are going from two dimension to three dimension, what is happening? This is two dimension. When I am folding it, this is 2.1, 2.2, 2.3, right? This is 2.9, and finally it is a three dimension. Okay. So in between, when you are going from the discrete dimension is moving from one dimension, the thread, when you are making it a circle, suppose this is the wire, this is a one dimension, you are making it two dimension, you are making it two dimension like this. Okay. So from 1 to 2, it is not happening in a discrete way, analog, digital way, like 0, 1, 1, 2, 3. No, it's not happening that way. It is happening in an analog process. That is from 1 to 1.1, 1.2, it is going like that. So these are known as fractal dimensions. These are the fractal dimensions. You are doing it as naturally, as realistically as possible through the geometrical analysis, right? The geometrical analysis, not going deeper than that, not involving the forces, not involving the energy as we do in physics or any natural sciences. You are just looking at the geometry. Geometry may be the patterns of the tree leaves or the branches of the tree, sand dunes, flakes, formations in nature. Anything which has got a symmetry in it, right, or a periodicity. So that is the fractal dimension. When you are moving from one discrete fractal to the another discrete fractal, in between you have got the fractal dimension. So fractal dimension is one of the important numerical parameters picked up from nonlinear dynamical theory, which can be applied along with Hurst exponent. This is the Hurst exponent. You are plotting the Hurst exponent. So probably you are familiar with Hurst exponent if you are doing time series analysis. Hurst exponent 0.5. I am just giving you because of the time constraint. I am telling you what it signifies. What is a physically, if you want to interpret what is Hurst exponent. Hurst exponent comes up to be 0.5, means the process is pretty random. Okay, Hurst exponent comes up to be nearby 1. The process has got some memory, intelligence, so it can repeat itself. It can repeat the steps, right? The moon is repeating the process of going around the earth every 27th day, right? The sun is moving around the earth is moving around the sun in a periodic way. So it has got the memory. That's why it is doing it. So anything having memory, the memory is there, means Hurst exponent value will be coming nearby 1. Memory is not there, all random, it will come to be nearby 0.5. But if it is minor in from 0 to 0.5, what will happen? Can anyone tell? Negatively correlated. Okay. So if it is negatively correlated, the next value will be lower than the previous value. So Hertz exponent, the dimensions, these are also taken from nonlinear dynamical theory to come up with the conclusion that it is not that only that it is periodic and they have got the correlations, but also the processes, the nonlinear processes, periodic and Hertz exponent, hence the Hertz exponent is high here. This is the Hertz exponent. It is showing up. This is 0.76, okay, in this solar cycle, 22, 23rd, 24th, for AP indices. And this link is important, that they are correlated. They have got, as if they have got the memory. That is important. And the dimensional analysis, fractal dimension of sunspot number and AP indices. Both are showing up in the same range. So you are saying that they are compatible. Compatibility check is there to correlate. And along with that, next in the next paper, which I am not showing now, we tried to correlate with cosmic rays. So cosmic ray, when the cosmic ray particles interact with the high energy solar wind particles, there is rain yielding cloud formation. Cloud formation happens, and then that rain yielding cloud formation precipitates in the form of rain here. So if you can relate it with the amount of rain you are getting with that data, with the data of the time series that you have from the geomagnetic data, that is the AP indices or DST better, DST index data over last couple of that paper in April got published for this peninsula. That is particularly in Indian perspective, we wanted to have it. We got the data from 7 different zones of India, the precipitation, rain, precipitation, the amount of rain we had, and we tried to relate it with solar wind because this data was there with us, and cosmic ray. At Ulu, that is Finland, there is an observatory which has got very good data, cosmic ray data. We had access to that data. So cosmic ray particles, solar wind particles from NASA, and the rain we have. So all the anomalies showed up. See, time series forecasting, the modeling part I was discussing, as probably someone initially said that the health data you are working on. So what is going to happen? That is a prediction, right? Normal periodicity is there. Based on that, pattern is there. You are predicting something. That is one aspect of it. But before that, the cause of the anomaly, first detection of the anomaly. Why this anomalies happen? Why that? What has triggered the source of this anomaly? Why it is there? So if it is a periodic phenomena that you have figured out, if that is figured out, now you are trying to find out trying to link it up with possibilities, that is the sources of that anomaly through this wavelet transform. One, that wavelet transform analysis is done with the Hertz exponent and other numerical analysis, and also you can use multifractal analysis, MFA. I have not taken up that particular aspect of it now because don't have time also, and that was not in my agenda today. Multifractal analysis, another beautiful and very, very robust tool to do time series analysis. Again, pertaining to geometry of the system, whether it is image or the time series, it doesn't matter. It takes care of everything, because initially when I asked, nobody said that you are using image. Otherwise, I would have shown you what is a multifractal analysis. Through multifractal analysis also, using those tools also, along with wavelet, you can find out the correlations between different time series or images, what has caused what, right? we have done. Tumors, that there is a tumor formation. We have been able to predict the anomaly. First step is anomaly detection. Second step is anomaly prediction. So anomaly prediction has happened. We have some collaborated projects, and we have 2 publications also related to with IIT Guwahati in medical image processing. There we used these techniques for anomaly detection, that is tumor, detecting tumors, and then predict. You can do prediction only when you link it up with the sources, possible sources of the tumor formation. So wavelet transform, cross wavelet transform, coherence of wavelet transform. This analysis is wonderful, very, very reliable. Okay. Only time series predictions, you can use ARMA modeling or variance of ARMA modeling. But otherwise, this is a very, very handy tool, wavelet transform. But besides that, if you are thinking of automating these things, you are trying to train the model. That is, you are going for a machine learning model now to automate the process. You just patients images or time series, you are feeding it into the machine, and machine tells you that, okay, this is anomalous, this is normal. This is anomalous, this is normal. That exercise is also done. Recently, those publications have happened. In that case, these besides this visible, I mean the graphs, there are numerical values also to be double sure, so that off diagonal elements in the confusion matrix are lesser, right? And the diagonal elements are more. That is, reliability is more, accuracy is high of my model, and reproduction. That is, it can recall when I feed a new image or time series, it can tell whether it is anomalous or normal, right? Recall is also good. If that is happening, my model is suitable for training, not only training, but also to apply to automate the classification. Okay, that probably in the last session you have done it elaborately. So that part is also done by us now after this whole exercise. Initial exercise started from 2021. All right, so to sum up what we have said, ARMA or RIMA modeling is applied usually in all the cases after doing the cleaning and pre-processing of the time series. That is one thing we have said. That is very reliable, very efficient so far as modeling few time steps. When I say few, maybe 5, 10 time steps. Okay. So, but it's okay. 5 time steps, 10 time steps. You can just predict some tsunami or some other volcano eruptions or whatever. Tornadoes for next 5 hours, 10 hours, good enough to evacuate the people there, right? So, if you can do it precisely, so that is what ARMA does. That is one part we have discussed. Second part, we have tried to find out what is wavelet. I thought that is something I should be trying to introduce and tell about you. Those of you who are not familiar with, many of you might be familiar with wavelets. You might be using also wavelet transform, but for the researchers who are new to it, for whom this is new, we have tried to discuss the importance, that is not just correlation, not only correlation coefficients and other attributes of conventional statistics. Just tell you the numerical relation. There may be many errors, right? It may not be true. But first thing, in the time series, if you can find out periodicity, job number 1 is done. Now you are confirmed that there is something science happening. Intelligent system is there in my source, the source of the data. That is step number 1. That is done. After pre-processing and cleaning and taking care of the missing values, those and the descriptive statistics that we have not analyzed. We have not going into that because by this 4th day of this workshop, All of you must be familiar with that. Okay, so step 1 done. Periodicity is found, not just like the conventional Fourier transform, but two-dimensional Fourier transform, that is called wavelet transform. Periodicity with certain time duration. Done. Power is there. Done. Now it is sustained whether the cause, the time series you have got from the cause, that is the geomagnetic storm indices, that time series is somehow linked up with the sunspot numbers. Two different time series. Both are having the same periodicities. That is also checked. Now, can you find out periodicities are same, but is there any locking? Is there any interaction between them? Who tells if there is an interaction? The coherence. If there is coherence, coherence is found with certain power. Powerful coherence is there, but is it sustained? That is also checked. Yes, it is sustained. That coherence is also sustained, means they are interacting. The sunspot number, these activities of the sun is causing the geomagnetic disturbances or periodic changes in the geomagnetic index. That is confirmed, right? So now to double check or to convincingly conclude that this interaction has led to the observed results, that is geomagnetic storms or other disturbances in the terrestrial environment, that has been figured out using the tools from the nonlinear dynamics. But one conventional dynamic, because ultimately the paper has to be published, so the reviewer must be familiar with the parameters, the attributes you have used. So Hertz exponent is normally used in time series analysis as well as in any predictive analysis. Okay, because Hertz exponent, as I said, it talks about the memory content, memory retention capability of the that is imprinted in the time series, because time series is a signature of the source, the activities of the source. So Hertz exponent tells if there is some repetition which is happening with some memory, that is in memory the information is stored, and using that memory it is repeated, right? Plus the dimension. Higher the dimension, richer is the attributes. Okay, in the biological context, more designs, more lesser gaps, and more richer patterns, biological patterns on the flip, on the wings of the butterfly or the bird or the animal, right? You get higher dimensions. Numerically higher dimension means richer patterns, biological patterns. Electromagnetic sensing device, you get higher responses, okay, if the dimension is high. I'm just sharing what it means actually in reality. So we have checked that, and using that we have confirmed that there is interlocking, there is some interactions leading to related to the cause and the effect of the two time series. Okay, so that much probably is good enough. So I stop here.
Thank you so much, sir. I request our participants to come up with their queries if they have any doubts, any queries, anything that you would like sir to, explain. Some topics, some terms which is not clear, anything.
Everybody is sleeping except you and me.
It's a very rare opportunity to get hold of such an experienced resource person. Okay, so we have one participant.
Yes, I am here.
Oh, you were there.
Yes, I
Good to see you.
Okay.
You wanted to ask something, Dipankar? Did you want to ask anything? No. Sir, এইবিলাক আপুনি মোক মানে আমাক PhD কোৰ্সৰ আগতে পঢ়াই থৈ দিছে। সুধিবলগীয়া নাই। Now you can use them. No? These are very powerful tools.
Exactly. That is what I was saying. I mean, it's a very rare opportunity to have an experienced person like you. And if we are not able to take the
No, I'm not that experienced, but yes, I would love to come because we stay nearby. So offline is always good for me.
Yes.
So if there are some serious
Sure, we will
research
plan.
activities happening and we need to discuss, I'm open. I am open for that.
Sure, sir. We'll plan offline events as well, and we would love to have you here in the campus itself. So, any participant, any queries, any questions?
Everybody is saying thank you.
Thank you.
Only why, sir? Why not thank the organizers? They have given you this opportunity to be there, no? But it's good that you have, even if it is online, you have got some numbers. I mean, the participants, because
Yes.
no chicken, no mutton. Without chicken, mutton, and paneer, you have got these many participants. That is good.
True.
Normally, when you are giving a kit, I mean that bag and the other stuff, the pen, right, and the certificate, and then chicken, mutton, then only you will get the participants. See, but here you are getting participants.
True, sir. So, sir, formal vote of thanks. Thank you so much, sir, for sparing your valuable time with us.
My duty and my pleasure as well. And thank you for giving me the opportunity for sharing. Dipankar,
thank you so much, sir. So, in the future as well, we would like to have sessions from you. We'll try to plan offline sessions so that we can have you here in the campus. And it is much more impactful, I feel.
Yeah,
the participants can then and there raise their hands and
I need blackboards. Yeah, I need the board actually.
Yes.
But today I forgot and I misplaced somewhere that digital board.
So here in the Zoom we have whiteboard.
Oh yeah, I knew that, but somehow my computer, again, see, this is the old one laptop. I am using a mouse. I am using an external keyboard. So it is really haphazard happening here.
Okay, so it was very nice, very in a very lucid way, by taking examples you have explained us, and we all are beginners in using this particular software. So we are able to understand the things very nicely. At least I was very alert all throughout the session, and it was very good. In a sum, if I say, it was a very wonderful session, intellectual session. We learned a lot. Thank you so much for being here with us, and in the future as well, we'd like to thank you so much, sir. Thank you.
So much. And all the best to participants. Can I leave now?
Yes, sure.
Thank you. Bye, Dipankar.
Dear participants, so this was the end of day 4. So tomorrow is the last day of this workshop. So we have 2 sessions again, and then after the 2 sessions, we have the valedictory session as well. I request everyone to join the sessions. Sessions will be starting at 11 o'clock, so 11 to 1 and then 2 to 4. So after that, we have a small valedictory session. So I request everyone to be present in the sessions and the valedictory sessions as well. Thank you and have a good evening.